Hello, everybody. Uh, Hopefully you can all hear me and see me. Let me know otherwise. But thanks for joining us. Welcome to the first day of the Agentic AI Conference. So this is run by Data Science Dojo, and if you're wondering who I am, I'm Rebecca Merritt. I'm one of the conference organizers. I also take care of Data Science Dojo and Agento AI's technical content and some of the projects we're working on. So we have more than 61,000 people joining us for this conference. So it's really exciting to see that, level of participation and a growing, highly engaged community, sharing this experience together. We see such smart, switched on folks participating around the world, coming together with, a shared passion and a shared drive in this forever evolving field. And we have 5 days of time set aside for some just good, productive learning. So we have 4 discussion panels coming up. We have 8 learning tutorials and 6 deep dive hands-on workshops. So there's lots to look forward to. So we're going to cover a lot of what you really need to know, what you acutely need to be aware of, and to learn more about on how to properly orchestrate AI in your business or enterprise. So we're going to cover the really important AI governance stuff that you really need to know in order to scale responsibly. We're going to take an honest look at the realities of deploying projects and what we can learn from collapse projects, so we can take those learnings and hopefully be much better equipped, ourselves and in our efforts. We're going to learn about sufficient safeguards, better understanding the threats and the risks of AI so that we can, better prepare for them. And we're going to learn how to manage technical debt, so that we're not running into problems of unreliability, security problems, and sustainability problems. And after we discuss and learn a lot about the really important kind of crucial stuff, we'll then move on to, practical tutorials on day 2 of the conference. And we have some great experts who will walk you through, some of the tooling designed to, say, set up safeguards, tooling on how to, scale multi-agent systems and other kinds of tools that, handle different kinds of problems. And we'll use tools like, Docker and Samba Nova and Google AI Studio and lots more. So days 3 to 5 of the conference will be packed full of hands-on workshops, covering things like getting your hands on, more model optimization, safeguards and boundaries for your AI agents, having you work with, real world challenging data, messy data really, and other useful workshops. Now, just to kind of help set up maybe the scene for this conference, in terms of why we're focusing on, certain discussions, what is, really important to pay attention to. So, there are like many problems that can easily overwhelm you if you don't first develop a really solid understanding of, some of these issues that can occur, but also like how to execute and scale AI in your business and your enterprise. So take, for example, MIT's recently released a report in 2025, and it did find that 95% of, AI pilot projects just completely collapse and result in no return on investment. And this really does suggest, that the industry is still on a pretty steep learning curve on how to pull it all off end to end, have it keep going long term with, fairly minimal, or at least reasonable issues, or at least not to the point of facing total collapse. So it's just really important to further, develop and solidify your understanding of AI governance, really building value and not just, falling into hype, and, what an adequate security strategy looks like, being aware of technical debt accumulation and how to manage that debt and these kinds of issues. So the other important component of this conference is the tooling and the practical aspect of this. So we at Data Science Dojo, we do believe in actually giving people, the space and the time, the dedicated time to actually learn the tools, through real world examples and scenarios, and builds that confidence that you get from being, more hands-on, or, following along in a tutorial with a real person who has deep knowledge and expertise. So, whether these tools are designed for blocking unwanted vulnerabilities and those, sneaky bypasses, or for building AI agents without, what seems like those always recurring API costs, or for setting up a fully distributed, scalable multi-agent system, or, tools designed to make the most, to just take most of the infrastructure work off your hands when, building AI-powered applications, and, lots more. So that's another important part of your learning. Another important part of your learning, is the workshops that, really give you an opportunity to practice building, using, real world examples, and also dive deeper into some of the approaches maybe to modeling. So, you would learn reinforcement learning with human feedback. You would learn how to optimize models better, how to create some of the boundaries for your AI agents with some access restrictions, how to work with real world messy data, and lots more. So just a note, I think it's always a good idea, to come to these conferences and events with a kind of learning mindset, a kind of open learning mindset, I would say, just to get the most out of it, and not restrict yourself too much on what you ought to know or not know. So, whenever I myself participate and engage in these kinds of events, I tend to start from a place of, I'm here to purely learn. And I think it's a good place to be in, because you allow yourself, to genuinely keep growing. And sometimes we might think we've already had to learn so much, but there's always more to learn. And it's kind of my default state in life. I'm a learner first and foremost, and I think I always will be. So it's kind of like, how you see in the universe, or at least the observable universe that we know about, and the systems within the cosmos. You see them ever expanding outwards with space, and you also see, energy continually be reused or repurposed through, fusion and conversion, and so I tend to, also expand outwards in my knowledge as, time continues on. And, I also tend to keep reshaping and relearning and repurposing in life. And it's kind of become my constant to always be, open to learning. So my default state. And I hope you can also gain that kind of experience for yourself from this event, and any future events too. So we welcome questions and comments from you all across. You'll see in Zoom that you can post your questions throughout the sessions, and the team here at Data Science Dojo will be monitoring those questions. So we love hearing also from our attendees. So I want to say, thank you to those who participated in our poll questions. And so far, it looks like we have some interesting results. If, the team could bring up the poll questions, and we can take a peek at some of the interesting stuff you all shared with us in answering those questions, that would be great. So as I mentioned, we have a lot of people joining us from all across the globe. We have a big audience in India and the USA, but it's great to see such a diverse range of, countries from every corner of the world. So it's great that we're reaching so many different people and a diversity of people. So Yeah, I mean, I think we've always kind of had a big audience in the USA, but it's good just to branch out. And the world's so global now. It's we're not just speaking to a US audience, we're speaking to so many people across the world who are all struggling to navigate their way through something that's pretty quickly, rapidly evolving. The AI space is not one who wants, you know, um, consistency and never change. It's one where you have to really embrace the change, or at least enjoy some of that. So yeah, it's kind of cool to see that we're reaching so many countries, big and small, and it's kind of exciting to have you all here. Maybe we can move on to the next question. Okay, so getting more into it, this is insightful. So, what are your top AI concerns? Whenever I go to these events too, I come usually with some anxieties or some concerns that I need to, not only solve, but I need to see how others are tackling these kind of challenges. And I can see that, the security side, not surprisingly, is such a big concern for sure. And the reliability, like, um, you know, having, I don't know if anyone can say I have absolute 100% confidence. You can't really have 100% confidence in anything in life, really, but especially in a space that is still somewhat experimental. For a lot of companies, it is quite experimental, when we haven't seen a track record yet of years and years of how these projects play out. We haven't, um, got a long history to fall back on to show what might happen or what is likely to happen. Or so yeah, there's a bit of nervousness that's natural, and obviously we're dealing with data, your enterprise, your customers' data. There's already so much work around protecting customers' data, and there's going to be even more so much work just protecting it in the context of trying to push out an AI project. And so this totally makes sense. And our, privacy as well, which aligns a little bit more on information security, totally makes sense as well. And I think with this one, correct me if I'm wrong, but you could have selected multiple. So, if it was me, I'd be concerned about all of it. Not obviously not with equal weighting, like some would have more weighting on it. Obviously, security has a bigger weight than say, deep fakes or, but yeah, it totally makes sense. I think I was going to reach out to our co-founder, Raja Iqbal, to see if he had any insights that he found interesting from this. And it looks like our sample size is growing too. So we're getting a really good sample size from this. So I don't know, Raj, if you had any thoughts on this one.
Yeah, I think one of the, thanks, Rebecca. Hey, everyone. Good morning, good afternoon, good evening, depending upon where you are. So I think one thing that I found interesting here is the power concentration, right? So I think that's probably one of my top concerns personally. I don't want to bias the results here. So that was actually quite interesting to see, because some companies, it is very evident now that the foundation models, the frontier models, they are going to be concentrated in the hands of a few companies. And there are some long-term implications for that for us as a society. InfoSec privacy, yeah, they are the top ones. Reliability, absolutely. I see why that would be the case. Job loss, that one is an interesting one. I think this whole agentic AI transformation that we see as not just, I shouldn't call it the tech industry, it is, I would say, as humankind. We see this transformation, and we have seen similar transformations in the past. Going from steam engines to automation. Then we had those microcontrollers, we called them PLCs. Then we moved from there to a more intelligent automation, and we have seen all of that transformation. So job loss, possibly job displacement or job evolution, we don't know yet. I'm not an anthropologist. I'm not an economist. I don't know, right? So, but maybe a combination of jobs being displaced or reimagined or evolving would be the answer. And yeah, maybe we can just take it to the next one because we have to hand it over to the moderator for the next panelist. Yeah, this seems about right. I can see. Yeah, this is a good one, actually. I'm actually surprised that you already see significant transformation. So maybe we are talking about significant transformation. We know which industries will be significantly transformed, but we have not seen that transformation yet. Okay, I think without further ado, I think it is time for our first panel. Rebecca, over to you. You can hand it over.
Yeah, for sure. And yeah, thanks for sharing those insights with us, and thanks for participating in those polls.
Thank you.
So we're going to discuss our first item for the day, governing autonomy, policy, control, accountability. So, governance governance can no longer be sort of an afterthought in agentic AI systems. They become more capable of reasoning and acting, and they collaborate across tools and different environments. And so this panel, it discusses more of a coherence governance strategy. It combines architectural control mechanisms, human in the loop oversight, regulatory accountability, interoperability standards, alignment frameworks, and adversarial resilience, before operational failure or, before regulatory enforcement comes into place. Experts will, need to examine how businesses can actually scale autonomy responsibly, through auditability, compliance readiness, look at protocol standardization and just robust safety design. So we have a great lineup of speakers, and they're truly leaders and seniors in their field, with a deep set of knowledge to share with you. And our moderator, Muazma Zahid, will lead this discussion. So I'll hand it over to Muazma to introduce our speakers and start the discussion.
It's really a great honor for me to be here at this conference again, talking about the policy, control, accountability in agentic AI systems with the panelists that I have on this panel. I'm really excited to get this conversation going. In 2024, we all were talking about AI could write, AI could kind of build some chatbots, you can get some answers. 2025, we were talking about AI could reason. And in 2026, we are talking about an era of AI where it can act. So I believe this is the right time for all of us to come together and talk about agentic systems where they are using and have access to our code bases, our customers' data. What can we do really to make sure there is policy, control, and accountability for these agentic AI systems? I am monitoring the chat here, the Q&A section, so please put your questions in the chat. We will have time to answer some of the questions towards the end of this panel, and I want to spend this next 45 minutes to really get to the details of the panelists here, which are the experts in the area on intersection of infrastructure, collaboration, and data, and discuss the autonomy of these agentic AI systems. So without any further ado, I would like to each panelist to just give like 30-second intro for themselves. So we'll start with you, Rina. Please introduce yourself.
Hey, hi, everybody. Excited to have this conversation today on such a critical topic in our times that we have ahead of us. I lead ecosystem engineering at Atlassian, and essentially in my role here, I have a front seat of working through lots of AI agents and collaborating with multiples of our partners as well as customers to bring all of those agents to the table, amongst other work that I do. But this is very, very germane to the types of challenges we are dealing with today, and very excited to have this conversation.
Thank you, Rina. Over to you, Tushar, if you can introduce yourself.
Hey everyone, excited to be here. I'm Tushar. I lead engineering at Docker, and this is very top of mind and is almost everything we're focused on, particularly how to create a secure runtime for agents.
Thank you, Tushar. And last but not least, Philip.
Philip Rathley, CTO at Neo4j. The graphs have been becoming a big part of helping to assure trust, explainability in AI systems and providing context for agents that can help build better systems as well as help regulators and the human ultimately accountable for the decision. So I'll speak on behalf of what we're doing, but also what we're seeing many customers build as well. Real pleasure to be here.
Thank you so much. And I am Azama. I am a Google product manager in BigQuery in the data space. So really excited again to be hosting this panel. So let's get into it. So my first set of questions are around the architecture of control. So I'll start with you, Tushar, if you can explain how do we ensure agents to really operate in secure, isolated environments? I know at Docker, there's a lot about containerization. What are the things that you're seeing from your implementations and effective systems that you're building and your customers actually deploying it?
Yeah, thanks. This is a great question and great topic. So the way I think about this is agents are a fundamentally new, like we all recognize, right? They're fundamentally new type of system. They're intelligent, they can act autonomously, they can take actions. So when you think about this, we need a number of things here to address a number of challenges to safely use them. Fundamentally, we want to live in the world where we give agents access to all the things they need and they go do good work for us. The challenge we run into is how do we do that in a way that is secure and safe? And so safety and security, I think, are like the key problems to solve to actually get the productivity we want. I think we need a few things here. Like in my mind, there's sort of like three big things you need architecturally to get to the point where you can do this. One, you need to contain the agents. You need a way to run them that is secure, that has defined boundary. Second, we need identity or scope identity and access, and you're able to limit what they can do and to know who they are and then control what they can do. And then third, finally, we have to get to the point where we have intelligent, independent governance, which is controlling intent. So think of containment as where it can run and control its environment. Scope identity and access is what it can do, and then intelligent governance is like should it do what it can do. And so when you think about that, look, I think containers is still a good way to define workloads, but you need more secure, like a more secure way to isolate them. So for us, VM isolation is still the gold standard, and we need that everywhere, in the cloud, on your laptops, on edge, everywhere. So we need a new runtime that is, I think, VM isolation based. On top of that, you layer in identity and access. So these things should not just impersonate you. So everyone's doing stuff like we will inject in your credentials, your GitHub credentials outside, but then it's still impersonating you and has all the access your credential has. Really, this needs to be scoped down. This agent on this workload trying to do this thing and limit that. And then lastly, we get auditability, but you need intelligent governance. Like over time, agents are going to have access to more things than you're comfortable with, but you need that to get productivity. So what we need to layer on top of that is intelligent governance, so just control intent. So what is the context and should it do what it's doing and make that real time? I'll pause here, but that's sort of, I think, the journey as an industry we have to go on.
Yeah, that's a really great framework. And I think the three things you mentioned, I think if you look at the traditional software systems, those were the three things. But now that the impact with agents is the scale is higher, the boundary of control is really like the consequences are even higher in this case. So this is right, a good segue to you, Rita, in terms of the collaborative workspace and really talking about the second point that Tushar mentioned about control and access. So what are your thought process around the permissions of agents versus human users? What are you looking at from your point of view, if you can shed some light on that?
Yeah, thanks. Thanks for that. I think Tushar definitely shared a very great kind of framework for us to work with. And I think the first thing that I'd like to kind of call out is that this is not a new problem. This is a problem that we have to kind of, anyway deal with software, and we've been dealing with it for a while. So let's just first extend that and then, add on things for agents on top of it. So, bottom line here being great data classification and really getting a handle on your data has to be the first thing. So I think a lot of corporations are trying to roll this out with kind of, their existing data mess, so as to say. And this is just exacerbating the problems, and they're having a harder time understanding kind of, what's going on and making them feel queasy about it. So the first thing really is, even more granular data classification probably they need to do from what they've had in the past. And this will then be able to lead to the points that Tushar's making, to be able to then have the permissions controls, which are even more granular than what you're able to do with your users today. And so the more of the scoped access can be provided, more audit logging essentially needs to be built in, whether you have it today or not. And then, of course, the great aspects of threat modeling around security, risk assessment, and such really needs to be kind of, brought into the systems as well, and then upgraded for, what you need to do for agents here specifically. And then to your question around, what is the access models that we should think about, how Tushar was mentioning that, there is one model, of course, is around impersonating the user, right? And of course, that's the most default, everybody can use it in their existing systems, and that's where most of these systems, agentic system deployments today are starting. That's the easiest thing to do. But at the same time, if you don't at least start with the logging of like, this was done on behalf of the user and this action was taken versus this was done by the user directly, I think that itself becomes a very important first, very basic kind of, baby step to take in that direction. And then we are seeing lots and lots of kind of, patterns emerging here around using service principles, essentially, again, similar to how we've had, earlier software systems use service principles to access for permission control and so on. Also have systems which are building global access. This is like your open cloud model, essentially. It's like, just give me unfettered access to everything. But of course, these are all dependent on what the appetite for the individual use case and the user really is at, and, how do you want to control it. But really, if the corporation doesn't understand, the enterprise doesn't understand what their data access layers, what their permissions are, they will have a harder time doing it. So I think the more and more they're able to consolidate even, what are those access points, so as to say, for their data sets, it'll become easier for them to be able to, then have the audit control permissions and everything else built in there. So those are, I think, some of the things that I think about. What I would probably additionally say as well is, always start with least privilege for your agent. If you're a CEO, and you definitely don't want your agent to run as a co-CEO right away. So start with least privilege, and the more you can give them an agentic workspace themselves, which is contained, like Tushar was mentioning, either in a container or something else, those are becoming harder to have, because you also wanted them to have access to your Google workspace, to your Jira tickets and such. But the more you are able to kind of, start giving agents access to their own workspace, the easier it'll be to be able to know what's going on. Let me pause there.
Yeah, thank you, Reena. I think it's the least privilege access is a good starting point, and then giving them the containerize, and then of course logging, as Tushar was also mentioning, and you mentioned that. So that's a great point to get us started. I'll switch gears towards you, Philip. You mentioned in your intro about the kind of the knowledge graphs and data, and I also work in the data space, so very, very close to my kind of heart this kind of conversation. So what are you seeing from an agent access patterns when it comes to knowledge graphs, really to provide the source of truth and really grounding them? And why this do you think is important for the overall control of agentic systems?
Ultimately, AI decisions all boil down to data. Like every output of every AI decision results from a number of data inputs that occur either during pre-training or post-training or tool use or database calls or so on. And insofar as that goes, you need to then be able to surface all the data that's relevant to a particular decision for each agent, but you could complexify it. In reality, it's you have multiple agents working together, and they need to have each one needs to have the right view of the system, but that view needs to be coordinated in some way. So there needs to be some shared basis of reality where you're surfacing all the information relevant to a decision, minus what's not appropriate. And Reena, I like that you brought up access controls, because one area where models themselves fall short, if you're using just data that the model's been trained on to reason, is that any data has been trained on is fair game, and therefore you end up needing to use access controls in databases or other kinds of tools in order to gate what information is available in a particular system. And then all of this boils down to trust. So trust is some function of can I audit the decision? Can I understand the reason for a decision? And then also, is it a good decision? And what we are finding with kind of this whole explosion of context graphs, knowledge graphs, semantics, ontology. All these words kind of point to the fact that you have different kinds of interconnected systems. There's the ontology, which is like the meaning of the things in your system and how those things relate to each other. And then there's the context, which pick your term there, but I look at it as what are the actors, facts, behaviors, rules inside of the system that you're dealing with in the real or digital world that are relevant to your agentic system. And then you have the interactions between those things. And these, so to use a simple example, let's say I have a conversation. A conversation is between multiple people, can include multiple messages, can have different topics, can occur at a location, can draw conclusions, can have action items. And you can represent these all in an unstructured fashion, but then it becomes really hard to make sense of and to use. And a graph becomes a way to, let's say, provide some loose form of categorization and bucketing so that I can then relate things and understand how the system relates and have then an agent that knows how to query the graph through all the MCP server and tools to do that, have a shared view of that system and be able to make better decisions.
Yeah, thank you. So you mentioned a few terms, and I know our audience is all over the place, and they're different, a different journey for agentic systems. So if you're new to agentic systems and learning about just basic maybe retrieval, augmented generation, or just understanding how data is used in these agents, so definitely learn about MCPs, learn about how to set up your own MCPs on these data. And then, as Tushar and Rita mentioned, think about how do you control those systems? How do you give them access which is limited? So, for example, if it's a production database, don't give them access to all of your customer data. Start with a controlled environment. So, what we talked about so far is really the control around agents. So, what I heard from you, Tushar, Rina, and Philip, is that think about governance, think about intelligent governance, think about the control and access, and think about what data these agents have access to. So I'll switch gears towards the second part of this panel, which is about the risk and accountability. So let's say we did this and we did some testing and we did dev and test like our software systems. We did really well with that. And now we moved into kind of our testing phase and we deployed these agents. How do we establish kind of the accountability of these agents? So either Tushar, you or Philip, one of you can shed some light on it. And from your point of view, when agents are executing and if they make a mistake, what are the guardrails that we can put in those systems to really make sure and test and track them? I know you touched about that in the previous control question, but really now they are in action. What should we do about that?
Sure. I'm happy to start, and then Tushar, you can add. It depends on the kind of decision. So broadly speaking, you have some decisions where it's super high stakes. There's health and human safety involved, regulatory fines, et cetera. And usually when a decision's high stakes, each decision has high value, and then each wrong decision has very high negative value. And for those, the question becomes, how do I do my reasoning? Because what you're ultimately trying to mitigate against is LLMs can hallucinate. They're inherently not explainable. They lack judgment about what data is appropriate to be used where. So if I look at how do I mitigate those, you can look at two different ways to do it. One is I sort of just like tighten the aperture more and more with different controls and leave the reasoning to the model. And in that case, part of your training can become, having like early access where you're capturing each decision, and we see this being done in the graph. But obviously there are other ways to do it. But you can, if you store each decision and the reason in the graph, then you can end up having users steer the decision in multiple ways. So if there's a decision between two choices, you can capture the choice. And then refer back to it as part of your logic. If there's an error, then the user corrects the error. If there's a some other change, like a change in a basic assumption, like the GitHub dependency, then you can change that. So in that world, you want to capture all of the decisions and then have a feedback loop that helps you self-improve. And your accuracy gets better and better, and you might have some form of, let's say, gray box explainability, where I might not have the actual logic because the LM's making the decision, but I have all the inputs into it, and that's good enough for many use cases. In cases where you need 100% accurate answer, I'm going to be controversial and say that LLMs aren't the only place where one can do reasoning. There are other technologies that can do this. And so, for example, we have customers like Uber and Walmart that will take their highest stakes decisions around like telling what driver, what product they're eligible for when signing up for Uber in any one of their 15,000 cities where they operate, or telling a Walmart employee what their viable career path is to get from one place to the next. In that case, they do what's called multi-hop reasoning in the graph, which is a deterministic kind of operation. And that's an important part of the toolkit that I would say, obviously models can be used for many kinds of reasoning, but it's not the only way to do reasoning. And as a byproduct, when you're doing deterministic reasoning, like connect the dots, multi-hop reasoning in a graph, you get full explainability and access controls and your judgment out of that. So that'd be my two perspectives on it.
Awesome. Tushar, do you want to add anything from a tracking and governance point of view? I know you mentioned in the control part of it. So thanks, Philip.
Absolutely. Yeah, Philip, thanks. I agree. There's many systems you can layer in here, right? It's not just LLMs. You can think through this. So I think it's it's helpful to have I'll explain my mental model here as I think about this, right? Which is we can draw from other areas. In some ways, LLMs are just smarter automation you're building, right? Smarter autonomous automation. So if you think about, you can take many examples. Take how FAA does like airline safety. It's a deep history there what they do. I'm not going to try and summarize it, but a core part of it, deep checklist manifesto, right? Which is anything you do, you need a deep checklist. When I was back in AWS, we used to do a lot of things. We did lots of automation, but we had what we call the big red switch. If all of a sudden, the automation is trying to reboot too much stuff, let's just throw an alert and pause. So the way to think about this is think in rules of three. So three things. One, do everything you can to prevent the wrong thing from happening. So this comes from governance, constraint, scope control, but also other things like what rules you're giving it. What's the version of a run book or a checklist for the agent so stays on track. Second, limit damage when something goes wrong. So limit blast radius. So, okay, if something's going to go wrong, what systems can you put in place to limit the blast radius? This is where you think about things like observability come in, or some inbuilt gates come in. Okay, if something major is happening, flag and cut off. So having an execution environment and architecture that lets you cut things off is important, because then you can layer on observability and action on top of that. And then third, after the fact analysis, when something did go wrong, can I go back and understand who did what, when, and why? And then take that deeply, understand that, and then feed that back into step one of the system, where I try to prevent the same thing from happening, right? That's sort of the mental model of how we've all done ops, how we build systems. So I think the same thing I think of we should architect our way out of this problem with agents and try to build all this in. So have a execution environment that keeps on track, have algorithms or techniques that keep it on track, have alerts and observability and an architectural way to stop things when it's going off track so you can detect. And then third, have deep auditability and understanding. And here you need context and reasoning to really understand. I tried to do this. Why? What was its log? What was the data it had? What was the context? What was the reasoning it was doing? And then come back so you can understand what it did, why, when, and then relearn and come back to step one. That's sort of, I think, the world we have to architect into.
Yeah, it's a really great framework. And I come from engineering background. I've been on several 7 calls and on calls, as many of you have been. And that's exactly what we do in typical software systems as well. But just imagine for the agents, right? So what you just provided a framework for us to think about, like put the system in control, all the controls and audits and access, give it the right access to data, and then track it, and then if something goes wrong, how to stop it, and then eventually how to mitigate it, which is what we call RCA, root cause analysis, right after that. And then feedback loop into what Philip was saying is to go back to those controls, go back to those access, go back to see what went wrong, why it went wrong. I always boil it down to tech, process, or people. So it's one of these 3 things. So really think about what really happened in your agentic systems, and go from there. So Reena, I have a question, which is maybe a controversial question, right? We all work in technology for a while. We have been in this industry, and there's this thing called shadow IT, right? Like the IT's departments are there for the control, governance, and all of that. What is your point of view in terms of this shadow agents world? Do you think there is some threat for that? This was a question actually I received on LinkedIn last week, where somebody was talking about this bypassing corporate governance, and what do you think about ho- this whole era, and if you have any point of view on this one, and how we can help people really from both sides, IT teams and other business teams, really work together to work around this.
Wow, yeah, I know it's such a challenge, right? See, on the one hand, like employees bringing in new tech is always good because you're kind of experimenting, you're learning, you're probably going to get something which is much more useful and efficient for the corporation as a whole. But at the same time, it opens you up to so much risk. So we do have to be, I think, careful about what is going on and how it's going on. I think definitely employees should first like experiment outside of the corporate environments, and then kind of talk about how they can actually have the conversation with their corporate environments to say, what makes sense for us to bring in here, and how can we now open up that policy to be more experimental, and what is, again, the least risk areas that we can start with. We can try these new technologies. I would definitely kind of err on the side of being in conversation with the corporate security and the CTO organization, so that they are not kind of seeing these surprises come through. See, and again, it comes down to them building great guardrails for what boundaries of data kind of egress and they have around their corporate systems, and they all should have that already. It just kind of opens up the I think the space for much more. What I think the corporate systems also need to kind of think about is like, what are those high risk actions and what is the recoverability that they have around it. So we're talking about a lot of controls around audits and being able to tell what's going on, but at the same time, is there a quick recoverability around those high risk actions where you are writing maybe a lot of records to a system, or you are updating a lot of records? Is there kind of regular backups that are going on, and these things can be then recovered as well. So I think it's important for the IT teams to be able to kind of make sure that they are keeping their systems up to date and maybe even better from what they've done in the past for checkpointing, as well as kind of building up systems which can be not just governed but also be recovered. The other piece that I think about is that as we're bringing in newer systems and agents into the pipeline here for teams and companies to use, are they building evals around them? Because the other risk that we talk about, of course, from a data governance, all these perspectives exist, but are they actually producing the value that the company actually wants around, does it align with their mission, with their vision, with their goals? And of course, you could produce, for example, a creative for marketing, which is not that aligned with your values. And if it does go out, then it doesn't kind of, really make sense for the corporation to work with. At the same time, it's great for the marketing team to be working with maybe a third party also, even if they didn't bring in their data, to be kind of getting that value of getting agentic great marketing content out there. So I think for them to be building up some of those evals and giving proactively to their users could be another way to do that, so that they say, well, yes, you will be using some things which are not directly kind of accessing our data today, but do make sure that you're using these types of boundaries and evals. That my take on it is that corporations and ITs need to be more flexible, and great training and employees need to be kind of, okay with experimenting some, but within boundaries.
Yeah, thanks, Rina. I think so. Work together, right? Build systems, build trust, build between these teams. And what you just described is also evals is a good point. So I know that last year when I was at the same conference, there was a great talk about evals. So I'm not sure this year's agenda is covering this in detail, but definitely if you're new to this space, learn more about this for anyone who is listening to us today. Really to build the systems, because the way you test typical software systems versus these AI systems, these things have evolved, the metrics have evolved, the accuracy scores. And then I think what Tushar mentioned, and Rina, you touched upon that, is also recoverability. So in a typical world, we have these RTOs, RPO, and SLAs that we work across, like service level agreements. We have certain financial liability some companies have on those systems as well. So the same applies in agentic world, but really to really understand what is the process to really get to it and to the bottom of it. So thank you everyone so far, and please put your questions in the chat. Again, I'm watching this space if you have any specific questions that you want for this panel. So just to summarize what we have talked about so far, we talked about control, we talked about the agentic accountability, and we talked a lot about the systems overall, like the life cycle of agent, how to build it, how to govern it, how to actually log it and see what really happened, and then the feedback loop around it in terms of the systems. Rina talked about evals in terms of looking into the systems. So I'll move towards the last section where it's really, let's say we build all of this, we have deployed them, now we have tested them, we have a good process that's working. Now think about scale. And scale is a real problem, where if you see in all the research and studies that are coming out for agents, it's good, they work really well in dev and prod. Now you've actually deployed in production, and then you have like hundreds and these thousands of agents maybe working with each other or working on their own to do different tasks. So Rina, I'll start with you. What is your thought process? Because it's really easy to audit like human in the loop type of thing if it's like a few agents. But if it's really an autonomous system and you really want to build it for the enterprise data, how do you think about scale and the liability around it? Again, this panel is really about the policy and control. What is your thought process around that?
Yeah, I know, totally. So the human in the loop is like great starting point, but it will just move the bottleneck from one point to the other. So, if you're using human in the loop as a PR point for all the code your agent is generating, then your bottleneck moves from code generation to PRs then, right? So we really do need to kind of, then also look at the end-to-end system and say, how do we now make this all leveraged by AI, not just one piece of it. And here, for example, in the human in the loop process, if you were to use that, then, you really do want to then start moving to only the critical segments become human in the loop. And what do you do about the rest of them? And maybe there are options here are, where you use a multi-agent architecture, or you bring in other agents to perform the task of validating the output of other agents, so more independent agents, more different models that you can bring in. And those diversity kind of then helps you get to a point of getting essentially similar to a multi-team human to a multi-team agent approach, where they have diversity of thought, diversity of roles, and they can kind of value check each other and have that approach. And then again, evals and audits kind of go a long way. Continuous evals are really essential because of the drifts that we know exist in the models, as well as new models are coming out all the time. So the more and more your company is able to build essentially the objective function that you want for your agents to be able to follow. Again, the objective function being more of a mathematical way of saying, what your company's mission or your goal really is for the bigger picture, not just the specific task that the agent is doing. The easier it'll become to then be able to kind of, trust that agent and build that trust, which is long lasting over the life cycle of the agent as well. So those are some of the things that I think about is like, we really do need to scale up across the entire cycle of that particular aspect that you're trying to automate, not just a particular task, but the whole kind of epic, so as to say, or the whole journey.
Awesome. So there's a question that just came in. It is really what you just said is related to that. So I'll just post it. Maybe Tushar, if you can take it, or Philip, we can see. So the question is really around like the policy around it, right? So how do you kind of centralize policy register for enterprise, keeping agentic personas in mind? I know there is the overall policy discussion, like there is the EU Act, which is thinking about like what should be the policy around agents. But when you think about the agentic system for your corporation and you're building those, right? How you think about building a centralized policy register for these agents? Maybe Tushar, we can start with you if you have some thought process on that.
Sure. Yeah. Happy to start and then Philip, please jump in after that. So I guess a few things here. First, I think you need like the system that lets you do this. And then second is like, okay, what should my actual policy be and how to do that, right? So I think system-wise, it's everything we've talked about here, which is you need containment, you need agent and workload identity, and you need the ability to apply policy and have governance over all that, right? That's sort of the core thing we need so that we know what we can do. Then it comes down to like what policy should I apply where? And those become interesting. I think it'll depend. That's like I think highly contextual and depends on your organization and what the agent is. So, for example, for a code review agent that can run, I would like to apply a policy that says, "Cool, only developers can run these, and this code review agent should only be able to do, I'm making this up, should only be able to do reads from our repos and should never be able to go do any posts, like any HTTP posts outside, and it can only do reads from like, these network endpoints that go to Google for reads or go somewhere else, right? Like sometimes I can control what it can do. That's one way for me to like at least get control of what it can do. It'd be really nice if in addition to that, I can say, and make sure this does not, if when it's going outside the corporate network, it is not doing anything that looks like sending sensitive data, or any data, even in query parameters, is not PII. That'd be great if I can write a policy like that. So that's why like the framework and system is important that lets you define and do what you want to, like, that gives you the capabilities and control. And then you start layering in policies that you need across and running that. And this system, I think, how we like then scale across broadly, right? I can understand what the agent is, define the workload, and do all that. I don't think this existed. This is like sort of a thing what we have to go build. And then many people in the industry are taking stabs at this and getting there. But this is sort of, I think, the framework we have to go get to. And the ideal last thing, this is like, over time, it'd be great if like the system itself told you, hey, generally this agent is used by these people to do these workloads. Here's a policy you might want to apply to control it that then you can expand later. So the CISO start getting some help because everyone, like human context, is struggling with the workloads that are happening here. So more intelligence across all aspects will help us all.
I'll add this is clearly an emerging space, and so there's a dearth of off-the-shelf tooling that I've seen a number of startups try to address different layers in this. So like one additional one beyond what Tushar mentioned is what are the policies and access controls around agents? What systems can each agent access, and what can they do with each system? And like which agent is able to spin up and spin down other agents and agent swarms and so on and so forth. That's a whole new kind of problem that never existed in the past. I happen to know of one vendor that does this. They actually have an agent control graph underneath, which is how I learned about it. But IndyKite is, so you could look at them or things like them. Another is what's your data usage policy? Like, a lot of one of my takes on AI regulation is that a lot of the things that regulate AI behaviors actually already regulate the outcomes. You already have all these rules in financial services and healthcare and so on. And so then the challenge becomes how do you meet the bar for that inside of whatever you build, which is very high relative to, what just, something that you build trivially will do. So keeping in mind things like GDPR and CCPA and HIPAA and PCI DSS and all the rest, and making sure that, okay, if you create a new system and you need the user to have a right to be forgotten that they can exert through an agent, well, does that agent have a view of all the different identities and purposes for which things were stored, which GDPR, for example, requires? And then I'll just add one other point, which is that because things are moving so fast, the best way you can insulate yourself from and prepare yourself for being able to add additional layers of governance where you might have missed them is through audits. Because the more you can capture what's happening at a fine-grained level, then that gives you information you can come back and mine, including having agents that you can use to mine it and pull things out, extract rules, find misbehaviors, et cetera. So auditing to me plays an important role in maybe anticipating problems that haven't occurred yet and creating that audit trail and log that you can mine.
Yeah, thank you, Tushar and Philip both. So I think so. What you described is around the policy, and that, as you said, it's a very emerging space. A lot of companies right now are building these policy checks and making sure there are systems that we can do as part of the agentic system design itself. Like we used to do software system design, but really this policy is built in. And then audit and trail and really logging in the data world, we call it lineage, where we actually have lineage of everything, what touched who, access that, and where we log it, and then you use basically other systems to mine those logs. In agentic world, you can use LLMs to mine those logs and get to that point. So really, I really appreciate you all sharing that. I got another question, which is an interesting one I wanted to post, and probably that would be the last question before we have our takeaways. This is about like who should truly own agentic governance in enterprise: security, architecture, risk, product, or a shared operating model? And this is a question for all of you. If you have a thought process on this, I really like this question because it's had me thinking about a few things. But anyone of you wants to jump in and answer that, please go ahead.
Maybe
Shared.
I can share quickly, if that's okay, Philip. I think
Yes.
so. How I think of this is, again, it's like security is everybody's business. Is if even though you might have a card key to the door, if you let somebody in trailing behind you, that's kind of your responsibility and accountability. So I think it's everybody's business, and everybody needs to kind of do their roles, and they have to work together. I don't think this is a one or the other, and we can kind of pass the accountability. I think training and education goes a really long way when we kind of really don't have enough of it, I think, built up yet. And that's really where a great opportunity for investment really is at. Of course, training the people, and of course, giving them the tools. So I really think that, this is up and down and across the organizations. It doesn't have to be one person. Everybody who's kind of, signing off on the vendor and the agentic system that they're building, or, kind of the data access layers and the policies they're setting there, as well as each of the employees in the company that's starting to use the agentic flows, they all have their own share of responsibility here.
100% shared. Yeah, I was also going to use security as an analogy. It's everybody's business because you need to secure all parts of the stack, and the organization, each part of the organization deals with different touch points, different layers in the company's let's say process and organizational as well as tech stack. And because the stakes are so high and leaks or problems can occur at any layer, it has to be everybody's business.
Okay. Tushar, unless you think it's somebody's specific one, what's your verdict?
I can't agree more. It's hard to say something that has to be. And the only thing I'll say is like, look, CISOs need help and like end of the day, when something goes wrong, it's like CISO's name on the line. So CISOs have to go put in the systems in place, but systems are never enough. Like in the car key example, fully agree. But there is someone responsible for installing key cards, handing them out to the right people, putting the locks in place. So like the CISO has to go get the system in place, but then everyone has to recognize and take it on from there.
Yeah, and usually in these systems, the weak link is someone somewhere did something and then they forgot about it, or there was an attack or something like that. So yeah, I agree with that, and I think it's a shared responsibility. So if you're building agents today, start with those controls, start with the things that we talked about in this panel, and I definitely have a few frameworks. So I will go ahead and post about that later today at LinkedIn as well. So we have about 2 minutes left here in this panel. I really want to thank all of you, Tushar, Rina, Philip. This has been really, really interesting conversation here to discuss how you all are thinking about. So we learned about control, governance, intelligent governance, tracking, root cause analysis, feedback loops, evals, and really thinking about policy around it, and then thinking about a shared operating model. So I think there was a lot of good points. That's the purpose of these panels, to have you all thinking about it. I would just have all of you go maybe 30-second each, your last thoughts, one piece of advice when it comes to agentic AI governance journey for anyone who's starting today.
I would start with really kind of, the basic of it, which is like, is your data really kind of, in a great shape of understanding the permissioning and the access models on top of it? So if you just start there, you'd start with that one great thing to do. That would itself kind of, lend dividends over years of, various different types of agentic transformations that we're going to go through here.
I can go. Go ahead, Philip. I'll go after you.
Okay. I would say add to the non-functional requirements trust. So non-functional requirements is availability and recoverability, scalability, security. Trust hasn't really been on the list because you almost kind of assume it, but now it needs to become explicit, and then think about what trust encompasses. And then also, in some ways, like trust and all the gates can become an enemy of progress and even learning what the tools are about if you take an extreme view. That extreme view belongs there in production. But then for experimentation, you need to be able to experiment with new tools and techniques. And so find the right sandbox approach where you're not using production data, you're using isolated VMs or machines or containers, and so that you can discover as well, but then maintain production on absolute lockdown where trust, capital T, is an imperative.
Thanks. I fully agree with Rina and Philip. Maybe it's two things. One, yeah, as you're building stuff, think about safety and trust as you're designing up front. Second, we're all running agents all the time. Like everyone has assumed running plot code, CLI, etc. on your laptop, as everyone's doing, and that's just like that's a high trust zone where we all have stuff. So be careful about that. I will do a shameless plug. Apologies. Go Google Docker Sandboxes. Gives you a way to run micro VMs, run agents and micro VMs locally. Start there, or do something like that, because like your developer environment, your desktop environment has got lots of security credentials on it.
Thanks, Tushar. Thanks, Rina. Thanks, Philip. And the last point that you said, I actually have a system where I am testing my own features all the time like this. So that's exactly, depending on what role you are, if you're a software engineer, product manager, or maybe an architect or anyone, right? You can build these agents today and really think about this governance. Again, thank you for all of you, Tushar, Rina, Philip. This was a really great conversation. Thank you for Data Science Dojo for having us on this Agentic AI conference. Please connect with all of us on LinkedIn. We will be hanging it out throughout the day in the conference as well. If you don't see us there, please reach out. And again, back to you, Rebecca. Thank you.
Thank you so much. I just wanted to say it's been really, interesting discussion, and I absorbed a lot and learned a lot. I liked the points about, before you start introducing, AI policy and things on top of your already messy situation, maybe address the messy situation first, then logically, step two, introducing more layers on top. And I liked the idea of informing your training data a lot more by looking at a high-stakes decision made correctly or incorrectly and learning from that. And there were just so many great points. And our audience members were so engaged, by the way, on the Q&A. We had some great questions, people making great points as well around, when you add all these layers of security and safety controls and guardrails, there might be a bit of a trade-off and performance limitations. And there was just so many great questions coming out of it. So it's been really awesome to see such an interactive environment. It's got me really excited. But in saying that, I will pause for a short, I think it's like about a 12-minute break, 11-minute break. We'll be back at 10:15 Pacific time. So it's about, a 12 to 13-minute break from now. So go grab a coffee or a water or whatever you need, and we'll be back again soon. So welcome back, everyone, from the break. We're going to go to our next session for the day. So we're going to discuss moving on from, hype and more onto actual durable value with agentic AI. So agentic AI kind of, lies at the nexus of organizational design and capital intensity and also hype. And this panel kind of brings together some of the operational realities of stalled deployments, when you get ambiguous ROI, brittle architectures, and the economic debate between bubbles and durable transformation. So our leaders today will look at why projects fail, what distinguishes, speculative momentum from more sustainable value, and how to create, effective human agent collaboration models that, actually improve rather than worsen performance. So this panel is to help, executives and the like determine where autonomy actually produces long-term benefits. And we have a great lineup of speakers. They're leaders and seniors in their field. They have a deep set of knowledge to share with you. And our moderator, Raja Iqbal, will lead this discussion, and I'll hand it over to Raja to introduce our speakers and start the discussion.
Thank you, Rebecca. Hey, everyone. How is everyone doing? Hey, Bob, Joao,
Awesome.
Great to see you. Jeff, David, nice to meet
Hi.
you both. Okay, how's everything going?
Great, excited
Great.
for this panel.
Yeah.
Another day in
Thanks for
paradise
making
here
the time.
today.
Yeah.
Love it.
Thanks for making the time. Okay, so we'll go ahead and get started. I will set the tone, set the context, and we'll go around, quick round of introductions, maybe 30 seconds, a minute, and then we'll get started. So there is this. A while back, someone was joking, actually, right now, everyone is losing money except NVIDIA, right? So, that's probably, maybe there is some hint of truth to it, right? So that is where we are. A lot of companies, they are trying to get past that POC stage, and not because there is building production systems, in terms of technology, in terms of the viability of the agent working. We are there, right? So things for the most part, for many problems, we are there, but there is a lot of other organizational friction. Your operating model, your culture, how people look at agents, and all of that. That makes adoption of these agents at scale or productionizing it. That makes it very hard. And basically, the discussion that we are going to have is we see a lot of hype. We see a lot of excitement, but is there any durable value in building agents or not? I'm sure all of you think there is. That's why, that's what you do. That's what all of us do. But what would be the mechanics of getting there, right? So that is what we are going to discuss, and anything that comes up. It's going to be very conversational, so we'll go ahead and get started. For those of you who did not, I was there earlier in the kickoff session as well. My name is Raja Iqbal. I am the founder of Agento AI, yet another agentic AI platform. Like everyone, this is what everyone is doing these days. So I'm one of those people. And I will go around the room and ask everyone to introduce themselves. Joao, you want to go first?
Yeah, sure. Thank you so much for having me. My name is kind of hard to pronounce. I do go by Joe. That makes everyone's lives easier, and I truly don't care. CEO and founder of Crew AI, basically an open source framework and an enterprise agent platform. That's the TLDR.
Okay, thanks, Joao. Jeff, you want to go ahead?
Yes, happy to. Hi, I'm Jeff Boudier, head of product at Hugging Face. I focus on our commercial activities, and so specifically like how enterprises use open models to build their own AI. So yes, excited to be here.
Thank you, Jeff. David?
Yeah, thanks for having me. Thanks, everyone. Great to be here with this group. I lead our applied AI team at Landing AI, an agentic AI company founded by engineering Nice to meet you all and looking forward to the conversation.
Thank you, David. Bob?
Hey, I'm Bob. It's just Bob, so that's an easy name. I'm working in deep learning for 112 years, and I'm one of the co-founders of Weaviate. So it's great to be here. It's great to see all of you again, and I'm excited for the conversation.
Great to have you all. And I just realized that I now know how to pronounce Joao, your name, Jeff, your last name. I guessed what it would be. I can pronounce your last name as well. And Bob, I can pronounce your last name as well. And David, I'm assuming it is Park as it. Okay, so, okay, awesome. So let's get started, right? So Joao, perhaps I will go and ask you this question. You have done some production deployments. Out of the production deployments that you see, and I know Crew AI, awesome, right? Every production deployment succeeds. But in general, right? So in general, tell me, what do you see? How many of those deployments actually deliver the promise that we started with?
Yeah, I gotta say, it's not every production deployment that succeeds. I think like there's many issues that happens in there. I think like what people don't realize is that building these agents is getting, or building in general is getting extremely commoditized, right? I think these models are getting better at coding, so it's almost like the problem is not building. Right, the building has not too much value to be accrued there because you can build with Creo AI, you can build with LangGraph, you can build with anything, you can build in custom. There's many options, and you can use Cloud Code for that or any other of those harnesses out there. I think when you see this problem, like this use cases fail, is usually on the deployment, on the scaling, or even back on the discovery, right? Because these systems, they still have that last mile that turns out to be more 1,000 miles. When you're thinking about data readiness, when you're thinking about legacy code, when you're thinking about connecting these across the systems. And then there's also the human component. You need to think about change management. You need to think about the actual adoption. You need to think about things like governance. You need to think about things like data security. So again, when I see projects going south, usually it's recoverable, but the pain point's usually one of those things, right? Either they didn't thought about the data readiness side and they need to go back and fix that, or they didn't thought about the governance side, they need to go back and fix that. So I would say there's usually one of those things on those final 100 miles that kind of like gets in the way. But these things actually can provide a lot of value. So it's not like a magic thing, as most people like is lead to think that you just snap your fingers and you have agents and now you're 100 times more productive. But the beauty of this is if you put in the engineering work, you actually can achieve something remarkable. Like we work with companies like Johnson & Johnson, PepsiCo, ABI, the DoD, and you see that like, and you put in the time and you work on those, they actually get a lot of value on the other side.
Okay, thank you, Joao. So, David, I would see if you would like to add anything, and also in your enterprise deployments, have you seen anything? So, what is the common pattern for a promising agentic AI project to stall or get shelved?
Yeah, just to add to what Joan said, we're entering an agentic AI era for the enterprise, which is, really exciting, but that excitement comes with a lot of uncertainty. Agentic systems are expected to take action, not just generate content or code. And my team is focused on taking these systems into production, inside very large organizations, whether it's mortgage pipelines, investment research, legal review, or regulatory submissions. And before an agent can do anything useful, it has to read, reason across, and extract from, really messy, unstructured data. And that's the part most demos skip. And in production, as Joan said, especially in regulated environments, you're operating within data constraints, audit requirements, and governance processes that were never designed for systems to make probabilistic decisions. So in healthcare and life sciences, you're working in environments where errors aren't just bugs, they are consequential, regulatory events. So the most common reason we see projects stall is that teams move from a successful demo into production without addressing, governance, monitoring, auditability, and accountability, especially in these regulated environments. So, in demos, the system works, it works, beautifully, but in production, the critical change is the questions that you have to ask yourself. Who owns the output? How is this monitored? Can it be audited and traced back to source with calibrated confidence? And as Joe said, if these things aren't clearly defined, projects get blocked, not because the model doesn't work, but because the organization can't trust it.
Yeah. So is it safe to frame it this way, that a lot of reasons for failure are not necessarily technical, they are more organizational, maybe culture, mindset, operating model type reasons for the projects to fail?
Yeah, and I think it's a little bit of both, right? And to give you a concrete example, in one of KYC or know your customer workflow in financial services, we started by, restructuring their standard operating procedures to make them essentially agent friendly or LLM friendly, reducing, deeply nested and distributed data, and introduced a, ground chatbot. So over 1,000 analysts could, ask questions and get traceable answers quickly, and really tightening that initial scope to help, deliver and show value quickly. And then from there, you could build, a retrieval layer across customer documents, internal policies, and global regulatory guidelines to support, more complex reasoning and search using, vector databases like Weaviate. And the next step would be, designing the entire due diligence process itself, embedding document extraction as a kind of a standardized ingestion layer, and using automation to surface and route relevant information across, existing systems at each step of the workflow. So I think that kind of progression helps build trust and autonomy within the organization.
Thanks, David. So is there any other vector database? I mean, Weaviate is the only thing that I know. I mean, so hey, Bob, I mean, do we have any other vector database in market?
I'm aware of. Not that I'm
aware of, right? So how can there be, right? Awesome. So, Bob, maybe I will come over to you now, and feel free to interject, right? So we want to keep it very conversational. I will just shoot questions, and if you have any thoughts, please interject. So Bob, when we go to a customer, there are some assumptions that enterprises or SMB businesses or companies they make, or teams and organizations make, that go wrong. I mean, they make some assumptions and they go wrong. Do you have any thoughts on what are some of the assumptions that organizations make earlier on that end up not being the right assumptions?
Yeah, so that's a great question. So to answer it, I'll, if it's okay, also answer the previous question, because actually they nicely overlap, right? So we, of course, sit in a very specific part of the stack, and that is like when you outsource the knowledge to another place, in this case, vector database, is that where it goes wrong from our perspective is if not the right candidates are retrieved, right? So if a query returns something where the answer sits somewhere else in the data set, or not in the data set at all, but something is returned, and that is then being fed into the context window, right? So that is where that often goes wrong, and that brings me to your question, is that sometimes you have data sets where there's not enough information in the data set to solve a use case. So a human might look at it as like, look, the answer is here. But then the thing is like, well, yes, but you also have other knowledge that's not in the data set that informs you to get that question answered. So that is still a tricky thing that we sometimes see. Unless that all the information is exactly in there, and you always find the right candidates, that's a recipe for success. But it's mostly due to that, so that people want something from the data, but that it's not in the actual data set. So the candidates that you retrieve, you can be as perfect as you want, but if the information is not in there, then of course the model can't reason about it. So now I have to say that has changed significantly through the years, because when we started when I started Abbreviate in 2019, there was pre-LLM and all that kind of stuff. So we were working with like Centroids from Glove and those kind of things. Things got so much better over time, but that's still a challenge. So uncomparable to, what is it, 6 years ago, 7 years ago, but still, if the information is not in there, then you can answer the question.
Okay, thanks, Bob. And I think the entire ecosystem has been evolving and improving, right? So, it's so when we look at it, vector databases, if we case in point, I mean, if we specifically focus on vector databases, so definitely the hardware side is, of course, that is improving, but also the embedding models, they are improving. Hybrid search is there now, right? So there has been a lot going on. Better document extraction is happening, right? So previously we were just doing OCR, and now we are doing more complex document ingestion.
And let's not forget the whole concept of what we refer to as like agentic search. So where basically you have like a little agent that sits in between the query and the database, that actually that writes hybrid search queries, sometimes sets filters, and then based on what it gets back determines if it needs to search again or not. So you basically have like we call it a query agent. So that's actually the third generation, right? So first was pure vector search, then you got like hybrid search, and now you have agentic search. So that's something that keeps evolving itself as well.
Thanks, Bob. So Jeff, Hugging Face is probably one of the most recognizable names in the space right now, right? So you guys have been around for quite some time. Have been doing an amazing job at so many things, right? So do you see that, as Bob was saying, that things have improved over the last couple of years? Do you see enterprises making better choices in terms of their infrastructure, the model that they use, the framework, choice of framework, and document ingestion? Agentic AI, it's far more complex than just the word agent, right? So there's so many moving parts. Do you think that the way they're building the foundations correctly, so the things don't need to be re-architected? The term technical debt, we have a full dedicated session, fourth session around technical debt. But do you think that the way the architecture is built, it is sustainable right now? Do you have any observation around that?
Yeah, I do. I think there's a lot of transitioning that is happening. You mentioned earlier POCs. I think a lot of initial sort of proof of success were achieved using closed models, but you can't really translate that to like an enterprise context where you have like custom data, custom domain, and you need to run things in-house. And so we see a lot of transition happen. The number of open models has continued to be growing exponentially on Hugging Face. I think when I joined 5 years ago, there were like 10,000 models on Hugging Face. Today, it's about 3 million open models, and they're growing across different dimensions, like in terms of performance. Google just released Gemma 4 last week, NVIDIA Nemotron 3 Super. So if you look at frontier capability, the open models are right there, and that's very important for agents. But it's also growing in terms of diversity, whether it's like speech to text or text to speech or embedding models or whatever modality you can think of. Open models offer sort of frontier capabilities. And it's also growing in terms of the actual domains, right? One of the main benefits of open models is that you can customize them and make them your own. And that's what explains this Cambrian explosion of models. That's what explains millions of models on Hugging Face. And I think that's really what what benefits are really being instrumental in this transformation from POC to enterprise deployments. I think there are two areas where we're sort of hitting a little bit against what enterprises are able to do. One is governance. So I mentioned like how many models there are on Hugging Face, but there's also like hundreds of thousands of organizations. And today, I think about 30% of the Fortune 500 companies have like verified organizations on Hugging Face. So you can see that it's not just adoption in terms of large big tech companies, but it's like across every domain and every industry. But I think we're still early in how like the governance around the usage of open models is being instrumented at companies. And we see that through our Hugging Face Enterprise. That's how we are able to offer like SSO and access rules on who has access to what model within companies. And I think we still have a long way to go where companies are managing how they access and use AI internally the same way that they do with software. So I think that's one limit where we have to work collectively across the ecosystem to educate CIOs. And there's lots of progress to be made. And then the other is around data. So we talked about data earlier in the context of domain knowledge of companies. But when you transition from a model to like agentic systems, there's like different kinds and large amounts of data that are being generated by the agents and in order to build the agents. And that's a layer of the stack that today is a bit lacking. We're trying to contribute at Hugging Face to solve that. So we introduced like a new type of repository on Hugging Face called storage buckets to make it easier for companies to have AI native sort of storage. So these are the big trends that we see for enterprises and the challenges ahead.
Okay, thanks, Jeff. So my next question is, any of you can take it, maybe all of you can, because this is a general ROI type question. So whenever there's some kind of curve jumping, cutting edge technology comes in, some decades, once in a decade type revolution that happens. So there is always this question of, hey, is it a bubble or is it something durable, right? So all the time, right? And right now everyone is asking this question. So maybe I can express my view on this, and then we can go around and we can see what is it. So definitely, I mean, in my view, there is definitely there is some bubble-ish aspect of it, but I think it is this transformation is real. I mean, this is here to stay. And my question is, if you think it is the case, which part of it is, what would you consider a bubble and what would you consider, something that is more sustainable, that is going to be around for long term? Anyone wants to take it?
I think it depends a lot on kind of like what people were referencing when they called it a bubble, right? For example, are VCs running a lot of money into all these companies and every single one of them expect to have a 10x return? And if everyone gets a 10x return, well, that's more than the entire globe's economy. So that can't happen, right? So in that aspect, yes, like people will lose for other people to win. In terms of like the value added though, I think this is different from like the analogy that people make with like the internet days. I think the internet back in the day was the same frenzy, but like if you had a website on day number 2, that had zero impact on your bottom line, right? And what we're seeing with AI is that the impact's in there. Like for people that are the cutting edge and they're using it, like you can feel it, right? I know that inside Crew AI, 2 of our top 3 like contributors for coding are AI agents now. I mean, it is insane. We're feeling it, right? And we're feeling the vibes. I think it's what people are calling it these days. So I think it's very clear that the value in there is there, and the genie is not going back into the bottle. These things are never going to be worse than they kind of like they actually are. So I think there's no way that this is going to go back. I think if anything, we're going to be using it more and more as we go. Now, I do think that this bears the question around infrastructure, right? I think like it's even if you think about coding agents, like they do exceptionally work and they work exceptionally fast, but they still make mistakes. But I think the interesting piece is that they make different mistakes than kind of like what humans do. So the like original infrastructure that we have put in place in terms of code review, CIs, these kind of like don't necessarily protect that, right? And I'm choosing here kind of like a coding as an antidote to just show up that there's definitely investments that need to be made infrastructure wise. But I don't think there is a bubble in terms of like the value that is being generated or the upside potential or the fact that this thing's like there's no way back from this. This is going to be a big part of our lives in the future. But in the financial sense, yes, there's definitely has been like a lot of money being poured into a lot of companies. And I think like getting those to pay back will be a hard time for many people.
Thanks, Joel.
Yeah.
So David, I saw you unmute. Please, Bob, David, anyone? Yeah, please go ahead. Yeah.
Oh yeah, no. It's so. I second a lot of what Joe is saying. I think what's interesting to think about is that, and that's what I find fascinating, right? Is after the after the dot-com bubble, right? There was a couple of these companies that came out that were like that became really big, right? Obvious ones, right? The Googles of this world, the Microsofts. I run a database company, right? And so still today, one of the biggest database companies is Oracle, right? So what I find more interesting, and that's not exactly around the word bubble, but more as in like, will, thanks to AI, maybe in neo clouds, maybe in God knows what, right? Will new juggernauts stand up, right? That like those big ones, like the Googles of this world, the Microsofts of this world. I'm very curious to see if I would love to have like a crystal ball that I can look like 10, 15 years into the future to see like, is there a new juggernaut then that really came out of AI? And I think that's too early to tell. But I agree with Joe. This is going to go nowhere, right? So this is just going to stay. But the question is like, how big can these companies become, right? And that's something I'm very curious to see, in the not too distant future.
Yeah, just to add to what's already been said, I think both are happening at the same time. I think it's undeniable that the capability is real. These models can reason, agents can take action, but I think the deployment model is still maturing, and that's why companies like Crew AI exist, right? And that distinction I look for is whether the system's actually replacing a valuable workflow with measurable ROI. So improvements in throughput, cost, or risk, or is just simply being layered on top of an existing process. I think in many cases, what we're seeing today is augmentation without simplification. We have more intelligence, more data that's being generated, but the underlying workflow is still the same. And I think the durable value will come from being able to restructure those workflow itself, not just adding an agent or an LLM on top of it.
So if you look at it, maybe I think it could also be the case, depending upon how an organization is using it, can also mean if it is sustainable or if it ends up being a bubble for them, right? So I was reading someone's post on LinkedIn. So I don't know, they saved like 2 engineers, and their monthly bill for OpenAI token or Cloud tokens was 113K or something to like more than 100K. And they were proudly actually proclaiming that they have adopted AI for code writing. I mean, but I think there is an economics of everything. I mean, in the previous wave, we saw machine learning and all of that. At the end of the day, any technology is an economics problem, right? So, and depending upon how a company adopts it, right, maybe coding agents are here to stay, but the way a company uses it, I think that will make or break, and that will create the differentiator. Bob, please go ahead.
Yeah, so I'm completely understand what you're saying. I'm not a big fan of that way of thinking when I talk to people in mostly in enterprise, because it doesn't really go for startups. Is that I even once wrote like this article on Forbes about it. It was that I called like going short on growth, and the argument that I was making is like if you say like, okay, I'm gonna use, I don't know, Cloud Code to to rather than having 5 engineers, I'm gonna have 3. Okay, whatever, right? I really don't care about this kind of use cases. What I care about, if somebody says like, hey, I had 5 engineers, we started to use Cloud Code, and now we have 10 engineers because we can go so fast now, and we can deliver so many new features right now. That was like, we never predicted that would have been possible. So in every time a new innovation comes up, sure, you can think of cost saving, and those are always the first use cases. But what I'm more interested in is like, how is it just gonna help you with exponential growth of whatever business you're building? And that's, I think, where the value is going to come from, right? Not cost saving, but new products, new services. That's the exciting thing, right?
So basically, you're making case for, I mean, even within an organization, the way you frame it is the velocity of your innovation as opposed to cutting costs, right? And this framing also actually, there is this cultural aspect of it. You will face organizational resistance if you actually went with the cost-cutting narrative. It is not going to take an organization anywhere. Joe, please.
Yeah, I mean, I second all of that. For me, the way that I have been talking about it, it is a maturity model. So everyone starts like on the early days talking about cost savings because that's kind of like the horizon they can see, right? But then it's funny because from there, they go into like, all right, how I can generate money from this. I mean, no one grows a massive business and everyone's trying to make their business to grow by playing defense, right? And cost savings a lot of times is playing defense. So you're going to go on offense. So how it uses AI to actually gather revenue. And I would say the final kind of like frontier on their innovation is kind of like what Bob described. And it's like, all right, now what I can do that I could not even consider doing before because this was not even feasible, right? The economics didn't work or for whatever reason and did that. So usually I use that to actually measure how mature a customer are on their journey when we were talking with them. But I agree with everything that Bob said there.
Thanks, Joe. So, Jeff, I will steer the discussion more toward the open source versus proprietary frameworks or models. So Hugging Face is at the forefront of this whole open source open source adoption and distribution. Now, so there is an argument can be made that you want. I think it's not a new debate, right? So in the previous wave of SaaS innovation, do you go for some proprietary system, or you go for open source? So which side do you think is winning at the moment, and in the and longer term, which side do you think would be the winner in this case?
I think when it comes to open source, we've seen previous waves of technologies, how things shook out, right? We've seen it in databases, we've seen it in operating systems, we've seen it in mobile, etc. What gives enterprise control over what the products they build, what they give to their customers is open source because they have better supports, because they can customize, because they can host it themselves. And that happens to be true as well for AI. With AI, there is something else. There's open models, right? And I think earlier we mentioned regulated industries. If you work in a regulated industry, you have to work with open models because you can't have the data come out of your secure environment. if you want to have a more efficient system, if you want the model to incorporate some of the knowledge of your company, then you need to customize and fine-tune it. And that's only possible with open models. And we've seen this with the DoD episode. We've seen this with OpenClaw just yesterday, right? If you don't own or host a model, then you don't really control your AI. So in a sense, for me, like while for consumers, you can decide like to pay a subscription service here or try to run things yourselves. Like as an enterprise, it's a very different sort of decision, and I think that's where open models can give companies the confidence of what they build. In the end, I think we're using systems that use resources from open models and from closed models together in systems that can be open source or proprietary. There's all kind of like hybrid things going on. Open models can provide great tools for agents where the LLM can be either open or closed. So we're still in this Brownian soup where patterns will emerge, but I don't think it's necessarily either or, and there's going to be one winner take all. Just like, again, with previous generations of technology, be it databases, operating systems, mobile, etc. There's going to be proprietary, there's going to be open models, but I think for enterprise, open models probably going to be the way to go.
Okay, so let me take a contrarian view on this, Jeff,
Sure.
just for a moment. Claude is not open source. So some of the most mainstream, the ones that are
well, like, Claude Code is open code apparently since last week. But go ahead. I'm just kidding.
The model isn't. But I mean, where do you think this will? And this is maybe not only for Jeff, but this is a very interesting discussion here. OpenAI and Anthropic are probably the most recognizable names when it comes to individual foundation frontier models. Can open source actually deliver that promise that we are talking about here?
Well, yes, and I think that it is. Right? I mean, you can look at this from different perspectives. You can look at benchmarks. And so if you look at benchmarks, they compare sort of model capabilities, and you can see that there are many open alternatives to frontier proprietary labs, Anthropic, OpenAI, DeepMind, that provide capabilities like within the same range. If you care about more like regional, culturally relevant AI, it's even more so the case. And you can look at this on a systems perspective, like there are alternatives. So yeah, I think in terms of brand recognition, in terms of commercial adoption, there's definitely an advantage with OpenAI and Anthropic. But if you look at sort of the feeds and speeds and the capabilities, we have very comparable alternatives, whether you're talking about agents or you're talking about specific types of AI systems like document AI, like RAG, and other experiences.
Thanks, Jeff. And Bob, you want to add something? Please, go ahead.
Yeah, so I think, there are two things also especially for the people listening, right? So with open source, two things to keep in mind, right? So EVA is open source, but it's on a small scale. So if you just start a project, so you're like one or two people, you start something, you need to ask yourself the question, how do I reach people, right? And then open source is a way to do that, and then your product evolves in such a manner. Sometimes you build something where your architecture dictates that you can't do that, right? So and that's fine too, right? So it's often also just a way of like, how do I get my project out, and that grows into a company, and then it keeps growing. Sometimes there's situations where a company is built around an open source project, so then it's like open source by default. But it's also interesting to keep in mind that open source on a large scale, so like with big players and hyperscalers, plays an important role as well. Let me give you a very pragmatic example, right? So one of the unsung heroes of everything that's happening now with LLMs is the common crawl, right? So people get access to the common crawl and they download a whole copy of the web, and you can train your models. Now, I know that the common crawl is a foundation. I don't know how many people work there, but I think like 2 or 3, maybe 10, but I thought it was 2 or 3. I know it sits in S3 buckets. Do you know how much you need to pay AWS to download the whole web from S3 buckets all the time? So somehow, by magic, a 2 people, 3 people, maybe 10 people foundation is able to make the whole web available open source to everybody. I have a feeling, I don't know if this is true, maybe what I'm saying is complete BS, but I feel that foundation is not getting an invoice from AWS to make that data available. I might be wrong, but that's what I think. And there, of course, then open source is a very strategic element to it, right? So that was, of course, started before the LLMs, but definitely in the slipstream of deep learning. Like, hey, some companies have access to the whole web. Why not make an open source version available of the web? But if you would do that purely commercially, that would be impossible, because somebody downloads a copy or these work files. That's going to be so expensive. That's impossible to do. So my point is, if you're small, the strategic value of being open source is like, how do I get the word out, right? How do I show to the world what I'm building? Then that's an option. And on a very large scale, like with, for example, the common crawl and then AWS, there can be a strategic decision to say like, hey, you know what? We're just going to help make this stuff publicly available, that everybody has access to that data. So it's a complex question situation, I mean, but it's definitely not going to go away. And what Jeff said also is like in the end, it's all based on similar research. So even if the open source models are lagging behind a little bit, they'll catch up, right? I really believe that.
Yeah, thanks, Bob. David?
Yeah, I guess I need to talk to the Common Crawl team to help reduce our cloud bills. But I think in practice, most enterprises aren't choosing one side or another. Most CIOs and CTOs I've talked to are building a balanced strategy. As Jeff said, especially in industries where you have different data security classification. Some workloads can leverage cloud-based proprietary models, while others that are highly sensitive, they can't leave control environments at all. So I think what we're seeing is a shift toward kind of like this multi-model architectures where different models are used based on the sensitivity of the workflow and requirements around, privacy, governance, and performance. And that flexibility, I think, really becomes a true differentiation from your competitors, as you move from defense to offense, as Joe put it.
Yeah, thanks, David. So what I'm going to do is I've been looking at some of the questions on my screen. I will mention them and as many as we can answer within the next couple of minutes. So there can be a funny take on this as well. What if an organization's assumptions go wrong? Who should be responsible for the failure?
Yeah, I think the model that most people are using is kind of like the idea whoever was doing that before, it's becoming a manager of that agent for now, right? So they're still accountable for whatever they output. Think about it like same way that if you're using an LLM, right? Like if you're doing a presentation for an entire executive team and you're using an LLM to help you create it, I mean, if that goes south, it's still on you. So I think that's a little bit on the mental model people are going for. But there's definitely kind of like more of a common theme now around this idea of like policies, right? Where you might have like escalation policies, for example. So after like something become a little more mission critical, then it's not a one person give you a thumbs up and thumbs down, but you actually might have some clearance, and that might change in runtime depending on the data that is being associated. But I definitely feel that like you still need a knack You still need a neck on the line. That's some of these use cases at the end of the day.
It's somewhat related to that, but I don't know if the other panelists have this too. But what I find interesting is that sometimes I'm like at an event or conference and I see a presentation or I read a document where I go like, okay, this is too much LLM. You know, it's like you know what I mean? So it's like there's like no human creativity at all in there anymore. And that is something that I find that kind of turns me off to whatever I'm listening to or what I'm reading. And then I'm starting to get more and more appreciative if I see something that I see that that it's so pixel perfect that must have had help from an LLM, but it's still that person's voice in the text or in the presentation. I notice that I start to notice that more and more often. There's something about the LLMs that you can recognize as if it's too much LLM, and that for me personally, that kind of backfires. So related to Joe's point, it's like there's really like a taste element, how well that you use it in your day-to-day job, especially when you give like a presentation or those kind of things, or if you write software, those kind of things. It's and of course not the first one to say this, but I don't know who did, but that you're more starting to become like a curator of how you curate the software you're making, the presentation you're making, the documents you're writing based on the input from the LLM, which is something I find fascinating. And that's definitely, in my mind, the end responsible for that is the human, right? Not the model.
Yeah. So again, a question for all of you. You don't have to give us names of the companies. Have you seen any deployments in your experience that had a very fairly positive ROI, like immensely positive ROI, that they said, I mean, well, this was the best investment that we made?
Well, for some of our customers, that ROI is getting to millions now. So like, I think like there was one use case that we deployed that like in 2 weeks, it kind of like it generated like $2 million for them. So that was something that was remarkable. And the use case there was around, basically is this huge CPG company. So CPGs are shipping things all the time and all that. And the reason was they realized that some of these orders would end up just stalling for many reasons, right? And they would require some sort of human intervention. So either shipping or invoice reconciliation or there was something that required human to just be in there and like, all right, route to this person, route to that person. It was a very simple use case, but then like in 2 weeks unblocked like 800,000 orders. And they're like, all right, this works. So there's definitely has been some of that. There have been more like more use cases that were simpler, more back office around optimizing things on that same company for coupons and discounts, for example, where a lot of the efficiency gains end up being not necessarily headcount in terms of like letting people go, but like putting these people to do other sorts of work. And that has been something that we have seen as well. So it's definitely getting to the interesting pieces. And now I'm starting to see some of those, as we said, like those innovation use cases that are like, those are extremely exciting. Like some of things that I never really thought. So yeah, it's getting into the millions, but I would say it's probably like 7 figures still. I haven't seen like many 8-figure use cases widely adopted there, but yeah, like 2-3 million use cases that can save you or generate $2-3 million in revenue, that starts to be more common.
And if I rephrase it, and please correct me, it's more of a journey that you slowly, gradually get there, as opposed to you just adopt it and then stuff starts.
It's definitely more of a journey. It's definitely more of a journey. I would say like our customers that are most aggressive. We have this one customer that is super aggressive. They have a goal for this year that they want to save $100 million with agents. That's the most aggressive goal that I have seen for this year. And then for the next 5 years, they want to do $1 billion, right? So they're very much shooting for the moon. Like if they land on the skies, that would be amazing. But that's kind of like their North Star and everything they're doing around it. But it's like we have been working with them for over a year, and now it's getting to amazing results, right? But like it is, again, it's not a magic thing like you just snap your fingers and it works. It still requires you to put in a lot of work.
So should I buy their stock? I mean, are they public? I mean, going from, that would be awesome, right? So, but
they are
okay.
public, but
Yeah, let's insider trading, right? So yeah.
Yeah. No, well, so let's take the opposite point of view.
And
The startups.
that was the next question, right? So the
The
opposite point of
startups,
view.
right?
Okay.
Yeah, because the startups, they are building AI native. So I'm, for the people watching, I'm old, right? So I mean, I'm for so long in this space. I remember when we started with these first generative models, right? That it was like, that you could see where it was going, which were like, right? And then all of a sudden, when the LLMs emerged and RAG out of that, and that all those startups that came out of that and started to build, that I said, like, I literally had like a front row seat. So I saw all these companies emerge, building based on the models, built on top in combination with Weaviate, and then all of a sudden, boom. These companies, if you would take the model out of their business dies, right? So that's what got me very excited for the simple reason that, of course, startups are always a little bit faster than a little bit faster than the in adoption of those kind of things than the enterprise. So I would definitely not forget to also put the startups in the spotlight.
Yeah.
Okay.
And maybe to bounce off of that, I think there was a prominent Silicon Valley VC that shared, and it was already 6 months ago, that 80% of the new batch of startups were using open models. And I think to the point, that's something that we're tracking, monitoring quite closely, is how companies are able to be successful and save money switching from proprietary agents and models to open source. And I think that speaks to the transition I was talking about earlier, where companies will first get success using a proprietary system they don't really control, then the bills stack up and they need to figure out how to re-architect and re-engineer something from the ground up. And that's usually when they start using open models in an open source stack. And we've seen that across the board, right? I think Airbnb talked about how they were able to get success and reduce their costs using open models. I think Shopify talked about it too. So I think we're in this transition phase, and we have like the early adopters, leaders that are making the switch and saving a ton of money doing so. And I expect that will expand to like all domains of industry, which have been using AI pre-ChatGPT for many, many years already to be more productive, better manage their data, answer to their customers, manage their internal knowledge, and all these established use cases. And I think that will continue in the agentic era.
Yeah.
Okay.
And if I may add one more thing to that. So because what Jeff said, something popped to my mind. I remember that this is one of our, I can't say that, I mean, I can say their name, but I won't do it. If I tell the story, people understand why. This was a company that came up in the whole web 2.0 era. So they built these whole complex pipelines to analyze documents and those kind of things. And all of a sudden they became like a heavy Weaviate user. They started to grow like super fast. And I spoke with the CEO. I said, like, what's happening? And he said, like, we've spent years building these pipelines. And I saw these LLMs and I was like, oh shit. If I don't do a 180 right now, it's over. And that was the first time in my career that I was like, oh wow. And that was maybe like half a year or something after the ChatGPT launch. And then it went very fast. So that you started to see companies do those kind of things. And I still remember that I had that conversation. And that was for me also an eye-opener, that he was like literally like scared. He was like, we spent years on this, and now an LM can do it for me. We need to change this now.
Thanks, Bob. So we are actually way over time. What I'm going to do is I will close the session with one last closing thought, or maybe a question. So one of my mentors, advisors, is very well-known, seasoned guy in cloud computing. Long time ago, when SaaS was starting, he wrote a book on death of software. And now So we were having a discussion, and then he was telling me, people are asking me, are you going to write a book on death of SaaS? So do you think, is SaaS going to be dead? Or is it going to evolve? Like very quickly, your take on this.
Yeah, I think there will be some market consolidation on the SaaS, right? There was this article about SaaS apocalypse, and there was a big topic amongst Andrew and some of the leadership at Landing AI. I think SaaS companies will build agentic capabilities on top. There'll be new wave of agent native companies that may replace some of the legacy systems. But I think it's a little bit too early to tell. But I'm really excited to see how things unfold over the next 5 to 10 years.
I think the death of SaaS meme sort of misses the point of what the value of SaaS companies provide. I don't think the value that they provide is in their code base. In fact, there are a bunch of SaaS companies that offer services on top of an open source code base. I think the value of SaaS companies is how well integrated and how securely integrated they are with all the data connectors within companies. They're in the service that they're providing to their customers in order to make sure that they're using things the right way and creating value within the company. So the value of the code base doesn't diminish those pockets of value. So of course, everybody's adopting the technology. Of course, everybody's creating new features that are powered by the new capabilities of AI models and agentic systems. So yes, maybe there will be companies adopting this better and faster than others, and they will sort of shuffle a little bit markets. But the death of SaaS, I think, is a little bit overblown.
Okay, great. Okay, thank you so much, everyone. I would have loved to continue the conversation, but we have to take a short break before the next session at 11:15. So thank you so much, everyone.
Thanks all. Bye.
Okay, bye.
Thanks for having me. Bye-bye.
We'll be back in a few minutes for our next session. So stretch your legs and come back soon. Starts in just a few minutes.
Yeah, Alex, we'll start in about 4 minutes.
All right, sounds good. I'll be right back.
Hey everybody, welcome back. So our next item is going to focus on securing autonomous agents. So because persistent memory, tool execution, API integrations, multi-agent coordination, they create completely new attack vectors. Agentic AI systems can, significantly increase the security surface. So this panel integrates, new threat models into a sort of a coherent security strategy, ranging from memory poisoning and prompt injection to privilege escalation and adversarial manipulation, all those kind of issues. So in addition to discussing, whether current security measures are adequate, our experts will also, look at workable mitigation strategies like red teaming, policy enforcement layers, scoped identities, sandboxing, zero trust architectures, designed especially for autonomous systems. So we have a great lineup of speakers. They're great leaders and seniors in their field, and they have a deep set of knowledge to share with you. Our moderator, Raja Iqbal, will lead the discussion, and I'll hand it over to Raja to introduce our speakers and start the discussion.
Thank you, Rebecca. It is me again, and I have Alex with me. Hey, Alex, great to see you again. Krishna, nice meeting you. So we'll go ahead and get started. How's your morning or maybe afternoon going? Where are you, Alex? You are in San Fran?
Yeah, I'm in San Francisco.
Okay.
So
And
it
Krishna,
is
you
the
are?
end of my morning.
Palo Alto, but yeah, close to San Francisco.
Close to San Francisco, and that's where all the activity is. I'm based in Seattle, so same time zone. Okay, so we'll go ahead and get started. You're probably I would say, two of the companies that are at the forefront of, security. Observability goes hand in hand when it comes to monitoring agents. So we'll have an interesting discussion. I will go ahead and get started and kick off with this article that I recently published in HBR. And the idea is basically simple. What the position that I took is that treat your agent like your employees. When you, just like you have my HR actually vets them out, figures out the use cases, does a background check, onboards them, sets up authentication. Don't want to go through the entire cycle, right? But the same process, the same idea, we should be actually going with. We should be doing the same thing with our agents when we build an agentic AI infrastructure and allow people to create AI agents. And there is actually, if we accept that might be roughly the analogy that we'll go with, then a few key things actually are very important, right? Security, how much agents are autonomous. Generative AI tends to be stochastic, right? So, and now autonomy, non-determinism, and control. Autonomy, what level of control should they have? How secure are they? What actions they can take and not take? And also, is there any auditability? Can we monitor what is going on? And with that, I mean, that is the context of the session. I will go ahead and ask both of you to introduce yourself and give an idea to the audience, maybe take maybe a few minutes to explain how is your company helping secure agents or your agentic AI infrastructure. Alex, you want to go first?
Yeah, well, thank you for having me. So I'm Alex Salazar. I am the founder CEO here at Arcade. Prior to starting Arcade, I was the VP of products at Okta for all of their developer-facing identity products and all the new identity products. And then before that, I was the founder CEO of a company called Stormpath, which was an authentication API for developers that Okta acquired to drive its customer identity business. So at Arcade, what we've built is this concept of like an actions layer for your agent. So you have your reasoning layer, which is a large language model and the agent orchestration system. And then when it wants to perform an action after some sort of reasoning workflow, it calls MCP and then calls the action layer. For a lot of basic agents, that might be one or two MCP tools or MCP servers. We provide a really nice MCP runtime that handles both routing and execution of multiple MCP servers in a way that can be centrally governed and managed. But more importantly, we have identity baked in, so we can answer a really hard question that very few other people can answer, which is, can this agent on behalf of this user perform this action on this resource? Can Claude, on behalf of Raja, send an email in Gmail? And we're the authors of the MCP spec that made that possible late last year.
Thank you, Alex. And I was reading through the background of Arcade, and you position yourselves as a what Okta was for humans, Arcade is for agents, right? So I love the positioning, actually.
Yeah, I joke that if you took Okta and MuleSoft or Zapier and they had an agent baby, that's what Arcade would look like. And it doesn't make a lot of sense in the cloud world because cloud apps were very, very different. And we'll talk about that in this panel. But in the agent world, because of some of the security challenges, that architecture is actually required.
Okay. That's great. Thank you so much, Alex. Great to have you. Krishna.
Hey, Raja. Nice to meet you. Yeah, I'm the founder CEO of Fiddler AI. We are an AI observability startup. We started in the ML era, so we've sort of transitioned the company from model observability to now agent observability. Prior to Fiddler, I was actually working at Facebook on ML infrastructure as an engineering lead. So the mission at Fiddler is to really build trust in AI, right? The three big problems that teams are trying to solve when it comes to agentic AI right now is, as Alex articulated, an identity of agents, who's doing what, but also observability of those agents, how those agents are performing, what tool calls are they, calling, whether they're hallucinating, whether they're leaking PII, whether, they're getting jailbroken into. It's a lot of most agents are blindsided right now, and then the aspect of security, whether there's enough guardrails for those agents to be able to run in production. So we focus on the observability and some parts of security. We're building what we call a control plane for agents today, for both for first party and third party. So customers that are making agents in any of the agentic frameworks can integrate Fiddler with a line of code and send all the telemetry to observe for all the issues that's happening within an agent, but also set up policy enforcement, so that they can actually make sure that those agents are not doing unforeseen actions. And so that's what we do. Excited about the discussion.
Thanks for the context, Krishna. And I mean, so I can call myself a practitioner. I mean, I don't write code, but still I spend a lot of time thinking about these problems. So, and also, I mean, an educator, right? So I teach generative AI as well. If I were to explain it to, let's say I'm an agentic AI developer, I know how to build agents, but I don't quite understand what your startups do exactly. Tell me, where do you sit in this value chain or this entire stack? Where do you sit? And I think that will help those practitioners who are not complete full stack yet.
Yeah,
it will help them, relate to the discussion that we are going to have better.
Maybe I can go first. So our primary user persona is a software engineer or AI engineer, right? Like, so if you're developing agents, you're most likely either using one of the frameworks out there, say LangChain or, Google ADK, AWS Strands, or maybe even just Claude Code to spit out native Python agents. Now, when you are actually about to ship agents to production, how are you going to make sure that the agent is working well? Whether it's actually meeting your business metrics, And then when it's deployed to production, how are you going to make sure it's performing to your expectations? It's not going off the rails. So these are problems that every enterprise, every AI team faces, right? So with Fiddler, what you can do is you can leverage a very quick integration that we provide across all these in agentic frameworks to send OTel logs, like open telemetry logs. And Fiddler will visualize the agentic behavior for you, the whole trace view. It'll compute metrics for you in terms of hallucinations, PII, and so you can actually create custom evaluations. If your agent is a customer support agent, you can measure things like relevancy of answers. If it's like some sort of email workflow agent, you can verify if the emails are valid emails are going out, things like that. So you can measure what you're doing, and then you can evaluate them. You can monitor these things then when they're running in production. So that's basically the primary responsibility. And then we are now
And you can
closing
hook it. You can hook it up to any
we can hook it up.
framework that I'm using, right?
Yeah,
Doesn't
exactly.
matter, right? So
That
it
is the
just
value
simply
prop
plugs
that,
in, right?
yeah, it's agnostic to the framework. It's agnostic to the models. One of the big USPs that Fiddler offers is we come with our own models that evaluate your agents. So you don't have to send your open telemetry logs to another LLM as a judge if you're using Fiddler, because we actually do that ourselves. So that's actually a big value lock for large enterprise companies who care a lot about data security and low latency, because we can do low latency evaluations on the fly. And so that's actually a big sort of differentiator when it comes to some of the other tools out there.
Great. Thank you, Krishna. Alex?
Yeah. So I'll give you an example, right? So let's say we were building an agent that could manage human resources. It could access Workday, your HR system, and it could manage compensation data. It could manage bonuses and raises and promotions. There's two failure patterns today that you would run into, and you'd likely pick one of the two and have a big problem. The first one is you give the agent a service account. People sometimes call this non-human identity. This is where you treat the agent like a person, right? And that makes intuitive sense because that's people think about agents sometimes. But then the problem is, okay, what permissions do you give the agent? And so you say, okay, the agent can do X, Y, and Z. Well, the next question is, who has access to the agent? And so if the intern has access to the agent, but the agent has more permissions than the intern, you've now created a really big problem where the intern can ask about their manager's salary and see it through the agent, even though they shouldn't have access. That's called an authorization bypass vulnerability. It's a very basic agent security hole for most agents. So what ends up happening? You end up having to reduce the permissions of your agent to the bare minimum, the lowest common denominator. But then what happens? Your agent's not very interesting. It's not very valuable. The CEO and the head of HR don't get any value because all they can do is see very, very limited information. So that's not going to work. That's why most RAG systems never really succeeded in the enterprise because you couldn't control who could see what. The alternative is what everybody's experiencing now with OpenClaw, which is you give the agent your credentials and it can do everything you can do. Well, the problem is you can delete your emails. You can delete whole folders in Drive. You can drop the home directory in your computer. Do you want the agent having that same level of access? In theory, it is technically more secure because it can't do anything you can't do, but it's unsafe because if it hallucinates a folder delete when you really meant file delete, you might have done something that's irreparable and irrecoverable. So both of those fail. And this is why large enterprises in particular, have really struggled to deploy agents in most use cases. And this is also why when you go to a website and you see an agent on the website and you ask it questions about the products it sells, it can answer all kinds of questions. But the moment you ask it about your order, it can't answer it. And the reason is it can't prove that if I ask about my order, I'm going to get my order. But if I ask about Krishna's order, I'm not going to also get Krishna's order. And so Arcade solves that. We make it very easy as a developer or as an IT person hooking up an agent to hook us in as your MCP gateway. We call it an MCP runtime because it does more than gateway. You hook us up and all the MCP servers sit behind us And then we allow for this notion, a very technical concept of called delegated user authorization, where we take the intersection of what the agent can see and what the user can see. So if the agent has this level of privileges and the user has this level of privileges, they both have to have the right level of privileges to perform the action in order for us to execute.
So basically, we are talking about principle of least privilege being enforced, right? Just come to a common denominator, right? So that's what I'm hearing.
Well, actually, we get this. It is least privilege, but it's also delegated user authorization, because you could do service accounts with least privilege and technically be secure, but it's going to be very valuable. But it's when you take the intersection of the two, which is called delegated user authorization, then you get both all the power that you want your agent to have and the least privilege on the user side, which is very powerful.
Okay. So maybe we can expand on it right now, right? So we have set the context, what the your respective products do. Now, when you look at this principle, if we enforce it on humans, right? So there is one human, I go sign on, sign in, get authenticated, and access stuff or take actions that I'm authorized to, right? But now that let's call it a chain of this authorization, right? So first the human and then the agent. How practically do you see any complexities here, right? So yeah, agent should have been able to do it, but it could not, or agent should not have been able to, and it still ended up doing. I mean, do you see, I'm not a security guy. I mean, but I mean, I see this obvious question. Can this be a problem?
Well, yeah, it's huge, right? I mean, what is it, 3 weeks ago? NVIDIA's OpenClaw fork, I think called NemoClaw, changed its own guardrail on the fly.
Interesting.
Right? And look, if you've ever used Cursor or Claude Code to code, you've seen it turn off tests that it didn't like because it couldn't pass them. And Anthropic put a paper out, I forget exactly when, that showed that if the agent hits a fork where it has to choose between undermining a constraint versus failing the request, it will largely undermine the constraint, right? In order to deliver the result. And so what that means is that you can't trust the agents. And anyone who's been around large language models already knows this, right? They're probabilistic systems. They can't be predicted. Security and governance are deterministic operations. And so, allowing a model or an agent to kind of reason its way into enforcing policies will not work. And so you need other ways to do it. In our world, Arcade side of the house, we enforce it at the action layer, right? When the agent can hallucinate whatever it wants, it can fantasize about robbing the bank all day long. We don't care until it actually walks into the bank and pulls a gun. And so we are able to enforce deterministically at the point of action. When it actually tries to read the HR file, when it tries to wire the money, when it tries to send the email, that's when we check on our side, hey, are you even allowed to do it?
Yeah, so I love it, right? So we tend to be fascinated by this anthropomorphic view of agents, right? So we want to give them human-like abilities, but I mean, this claw agent seems like a dictator rewriting the Constitution to suit. Hey, I mean, if the Constitution does not allow me to do this, I will go and fix the Constitution. So I mean, I'm the boss here. So Krishna, in scenarios like this.
Yeah.
How does a tool like Fiddler, or in general any observability,
Yeah.
What is the role of observability in this scenario?
This is why you need a neutral watchdog, right? You cannot just leave everything to the model or the agent itself to figure out, because then it can make choices that are detrimental for your business or your company. And we are seeing this already. Like I was listening to a podcast the other day with the Brex CEO, and he's proudly claiming that he runs the entire company now using OpenClaw. And now Brex is a regulated company, and of course they're acquired by Capital One. The only way he's been able to do it is to connect OpenClaw to an internal monitoring system that they developed, which uses kind of the approaches that I mentioned. They sort of leverage LLM as a judge to sort of infer all the OpenClaw outputs and make sure it's not misbehaving. But they are able to use it. He claims that he's able to use it for responding to Slack messages, emails, even running HR and recruiting on it, right? So this is the world we are entering now. So agents are going to be this new age digital workers, and so we have to have a company policy, just like we do for even regular humans, but even more so because we they're like black boxes, right? We don't know what's happening within an agent at any given point of time, what it can do. So this is why you need all of those three pieces, identity, observability, security, really figured out, and have like a neutral third party doing those things for you. And that's where at least you have some deterministic layer to know what's going on. And that's the missing link right now for many of the enterprise. Like it's a big blocker for many enterprise customers to adopt agents today.
Yeah,
And the fact is now,
I'll
yeah,
validate that really quick. I run Arcade largely in the last like 2 weeks through Cowork, and it works really well.
absolutely.
Yeah. So
And
Krishna, if I phrase it like you're more the Freedom of Information Act for agents, right? So just if something happens, go back and you have access to everything
yeah, you
transparently.
have the audit trail to know what happened, right? What was the actually sequence of actions that made it through, which is important. And look, I think we're not like we are here to help customers to deploy agents, right? In our own world, we actually use a lot of these coding agents to develop Fiddler. One of the things that we have now done is we have connected coding agent sessions to Fiddler. So now we are measuring developer productivity, and our engineers are able to like create evals of how good their coding agent sessions are in terms of creating unit tests and all kinds of things through Fiddler. So we are discovering newer use cases of agent observability, not just for custom agents that people are developing, but also third parties so in fact, like this week at HumanX, we're launching this new product of coding agent observability where you can connect a Cloud Code agent session to Fiddler and observe a whole bunch of quality and security issues, right? So I think that's where the world is going. There are agents that are you're making, or you're getting off the shelf and you're working with them, and so there is a need for observability and governance for those agents right now.
Yeah. So where do you think in both areas, the respective areas, and interestingly, right? So when we were, you can already almost see that when we're trying to find panelists, competent people who can actually talk like an authority. This area was actually where we had the least number of people who were competent enough to actually talk about this, right? So that clearly shows this is not a priority. We'll build agents, right? So we'll worry about security later, right? So clearly, that seems to be the trend, right? So of course, maybe a few more open claw-like issues, and then people will learn how important this area is. But I will ask both of you, what is it that, in your opinion, any companies that, any real cases where you saw that most enterprises are getting it wrong when they are building their agentic AI infrastructure in terms of, auth, access, and observability. So what is it that they don't get right?
Yeah, so yeah, go ahead. Yeah.
You go. I'll let you.
So I guess like one of the things that we, if everyone probably has seen that sort of MIT article, right? Like, when people try to claim that 95% of the projects didn't work out. So one of the big mistakes that people have done at the time was to see every single use case can be done using generative AI. And I think that was like the first sort of big mistake, that you need to identify the problems that are suitable for these type of models. And some of our customers, for example, we work with like Nielsen, which is a big sort of data company. They have been building models for a long time for media measurement, and they did not throw all of their existing models and replace them with LLM applications. So the clever ones, what they're building is they're building like an agentic skin on top of their existing infrastructure. And so, enterprises have a lot of tech debt, right? They have a lot of existing systems. It could be existing data, software, ML models as well. And so being able to figure out where what's the leverage here for agents is going to be very important. So I think, and then after that, going through the best practices of being able to test these agents pre-production, being able to monitor them and do enough guardrails. And so Nielsen was able to launch like what you call an Ask Nielsen agent, which is an end user facing agent. Very few people have end user facing agents right now, and they were successfully able to launch it because they went through this best practices, and they were able to like leverage like observability and guardrails, and make sure that those agents are performing right. So I think that's kind of what we are seeing when it comes to custom agents. But now right now we are focusing a lot on third party agents. I think there's still a gold rush moment, as you said, like Raja, like in the coding agents world, there's a lot more people just going and burning tokens like there is no tomorrow. But like now people are still slowly realizing the need for security observability in the third party space as well. So
yeah. Alex?
Yeah, well, one, I would challenge the authority that challenge the assertion that it's not a priority right now, that companies are like just launching this stuff regardless. It's actually the opposite of what we see. When we go have conversations with organizations that are like over 1,000 employees, they're stuck, right? So one of our customers is like a top 5 bank. When we met them, they had just shut down their wealth management agent that they've been working on for, I think, like a year or two, because they could not figure out how to get a wealth manager, to be able to access the system and not be able to see wealth manager B's clients' information, which is like not like they're never going to launch that thing without that assertion. We're talking to a big healthcare company right now where the CISO has said no MCP, like no, right? Blanket. And so if you have an agent without MCP servers, like what are you going to access, right? How are you going to access it? And so what we're seeing in many places is organizations are very, very limited today in what they can build because they can't get the stuff right. A service account type agent can really only do like low level, low security background processes. That's not what people are trying to do. People are trying to do a human interacting with an agent where they state intention and get a result that requires access to systems on behalf of the user. And so that's largely what we're seeing in the market, is that people are blocked. Like they can't build or deliver the agents without figuring this stuff out. And CISOs,
or the CISOs are freaked out and they are blocking deployments, right? So the engineers want to deploy it, but the CISOs are not happy about it, right? So they don't think it could be
and
deployed.
the CISOs don't want to say no, because like the organizational mandate from the board and the CEO down is pretty extraordinary right now to get all this stuff out the door. So the CISOs begrudgingly have to say no. And that's where a lot of the opportunities right now.
So I will take one of the questions here, and then we'll come back to my questions here. So there's this question here. So can't you restrict agent capabilities and architect the agents in a services architecture where you only want individual agents to have specific restricted capabilities?
Sorry, what was the question?
So the question is, maybe this was already mentioned, this was already discussed, right? So basically, can't you restrict agent capabilities and architect the agents in a services-like architecture? And I'm assuming, Alex, this is what your company is doing, right?
Yeah. So basically, yes, you can constrain an agent all you want. The problem is if you don't take into account who the user is using the agent, you're going to be very, very limited in what the agent can do, even if you constrain it. Again, I'll just rehash the example of an HR system. You can take this for any system, right? If you can constrain the agent to only see compensation data as an example, well, then you've limited its value. But then the question is, what if a user who has less permissions has access to the agent? Then what do? You've got a problem. And so then you've got to lower the value of the agent even further until you hit the lowest common denominator. But that really undermines the return on investment of that agent project. The agent can't do as much as you want it to do because you can't separate agent permissions from user permissions. And so the right answer is to do both. You decide what the agent should and shouldn't be able to do, and then you also take into account what the users can do. So you take the intersection of permissions.
Okay, great. So there are some other nuanced edge cases, or maybe not so much. I mean, not edge cases. So let's talk about context poisoning or memory poisoning, right? So it is not the user or the agent itself that is the problem. It is the context, right? So someone from the context side, maybe in your RAG, through your MCP, you ended up some malicious context that comes in. What does it look like? Both from Alex, your standpoint, and Krishna, from your standpoint. Krishna, maybe you want to take this?
Yeah, so the model security, these type of attacks have been there even from like classical model days, right? Where you can inject like, malicious data so that you assume that it makes its way into the training data sets, and therefore if bad models get created for you, and especially in fraud detection type of use cases, spam detection type of use case, it's very common to try to game the models. And now it's sort of like manifested itself in, like, let's say in LLM world, like prompt injection attacks, where you inject bad stuff into the prompt itself and try to like make it do no things. And now like the context, you can also try to poison the context to sort of like make the agent provide an inaccurate answer. So I think the key is like there is no sort of silver bullet. For example, in the kind of model observability days, and the way we help prevent adversarial attacks were to sort of look for these anomalous inputs, and also like track model drift over time. So over time, if like an adversary is like gaming your system, you suddenly see a big spike in your feature drifts, and suddenly you might see the distributions change differently, and that would help you to track them down. In the case of LLMs and agents, we've built capabilities to detect prompt injection attacks, and we have trained our own small language models. We call them the Fiddler Trust models, to look at malicious prompts, that they're well-known attacks like do anything attack or dude attack, that you can catch these things and filter them out even upfront, right? So memory poisoning, context poisoning is new, and essentially you again have to like sort of have them filtered out at the boundary, or at when the agent is trying to make it, like processing it. You need to be able to like run these trust filters at that time, and to be able to catch these things. And that's kind of the approach that is working out. The big thing with these filtering is it has to be low latency. It cannot like you cannot really use a very large model as a judge to do these things. And so you need to be able to like, so there's these neurosymbolic AI approaches have come about, where you take advantage of some information from the user, regular expressions or other things, and then layer it on top of the models, and you create a neurosymbolic architecture to do these things very quickly, like under 50 milliseconds. And so that's where a lot of our work in terms of guardrails and trust models have has gone into.
Yeah, I think the way we see the problem and the solution is multiple layers. And so 3 layers in particular. So the first one is, what we would call structural prevention. The model can't bypass what it can't reach. And so there are 2 concepts here. One is token isolation. The model or the agent itself never has direct access to the authorization token, the access token. So it can't just access something on its own without going through the action layer, something like Arcade. And then and that's also true for credentials, right? So let's say you want the agent to access a database. It should never have direct access to the database connection string. That should be embedded in the action layer. So let's say you've got an MCP server for ClickHouse. That MCP server is where the credential lives internally or has access to from its runtime. The agent only sees, run a query. And so secrets, tokens should never be in the agent runtime, and the agent runtime should never have access to them. The second layer is runtime enforcement. And this is a lot of what we talked about. We largely talked about authentication and authorization-based runtime enforcements. Can this agent on behalf of this user perform this action? But there's actually other things that can happen. You can have what we call contextual access hooks. So right before execution of the request, you would have all kinds of checks. You could have a compliance check. You could have a governance check against a system like SailPoint. You might have all kinds of other little policies that you've defined wherever you want in the organization, and you might check into those as well. So that creates the opportunity for a series of checks right before execution, but then also a series of checks post-execution as the results are being returned. So you can do PII checks or data loss prevention checks to make sure, hey, wait a second, are we sending back credit card information? Are we sending back social security information or health information or PII? Maybe we block it, maybe we flag it, maybe we redact it. So those are runtime checks. And the last one is really detective controls. This is where audits really matter. This is where your logging infrastructure really matters. Having really good, rich, consistent, standardized logs of what the agent's doing, what the prompt was, what the tool calls were, what the parameters sent to those tools calls were, what systems were accessed, what was the response, what was the sent back to the model, what were all the checks and all the results along the way. And that allows you to catch things after the fact and then attempt to remediate if none of your other controls catch it in the first place. So that's how we see a lot of organizations approaching it as well. And it's not too different than how people approach cloud.
Thanks, Alex. So when we look at the agents, right? So again, going from a human knowledge worker to an agentic AI based knowledge worker. How do you think the attack surface and the vectors, the attack vectors, any similarities, any dissimilarities, any interesting things that you have seen and you said, like in an enterprise, you said, wow, never thought that this could happen? Like anything in that realm that you would like to mention?
I mean, the biggest one is the biggest thing that I think makes all of this harder and different is that so the first one is agents aren't people. They're not peers to people. It's a good mental model when you're envisioning an agent and what it can do, but from a security perspective, that doesn't actually work. Agents are really application workloads. And the moment you treat them as such, your whole security model starts to work much better. But the problem, the difference, the thing that makes it really hard is up until now, you could trust an application. Like if you wrote it, if you bought it, if it's yours, you can trust its code. Its code is deterministic. If it says it's going to do A, it's going to do A. That's not true in agents. And so you have this non-determinism issue that changes everything. It breaks everything. And so that's the thing that everybody's really struggling with. And, again, an agent changing its guardrail, an agent changing its code is going to come very soon. I think by the end of the year, you're going to see examples of agents changing their runtime code to do things. And so you have to assume that that's always going to be the case and it's never going to go away. And so if you assume that, how do you do agent containment? How do you do model containment?
Okay, and then Krishna, is there a way to monitor the behavior drift? And let me elaborate a little bit, right? So in traditional SaaS deployment model, what we did was, we had an InfoSec review. We have access to this system and this system, this system, and then you configure the permissions, deploy, done, move on, adoption happened, right? In this case, things are evolving. I mean,
Yeah.
we hooked up, it was GPT 4.1, now GPT 5, and now it's a different model, different challenges. How do you monitor this kind of drift? Is there a term for this kind of drift? I'm just using it from it's not necessarily your concept drift, but your
it is essentially
context.
like, you can try to, like, what we do is, like, you can measure drift in, like, the prompts and responses at the very least, right? So let's imagine that you have an agentic assistant that you built out, a very simple customer support assistant. It is retrieving some data from your knowledge store and it is using an LLM to summarize it. Now, as you mentioned, when LLM models change their versions, and we actually have seen this in our own experience. In fact, we have our own customer service agent that we give to our users, and we have seen every single time it's connected to OpenAI because it's all public documentation of Fiddler it's trying to answer. And so whenever OpenAI upgrades their models, we see the answer quality and lengths and conciseness, all of those things change, right? So we then monitor our own agent for drift in responses, drift in prompts. And so the way we do it is, uh, like, we map the prompts and responses into, like, their corresponding embedding vectors, and then we cluster the embeddings across, different topics, and then we try to see if there is a topical distribution over time that's changing. So that gives you enough insight into, you can quantify the drift in agentic AI using this manner, just like, how would you do a concept drift or a feature drift in regular machine learning. You can quantify, okay, you are seeing new kinds of prompts all of a sudden, or you're seeing response lengths change all of a time, or you're seeing new words coming in responses, or you so those are the things that you can catch with these drift measurements. That gives you an idea that, okay, something in the background changed. Either your vector database got updated, or your model has changed, or both, and then you need to sort of take into account for those things.
But how many dimensions can be observed, right? So, I mean, if you look at it, right, so prompt changes, I mean, I know version control, maybe I have it, right, the prompts have changed, but the worry is the behavior, right? So is the behavior, and how do you define behavior? I mean, maybe evals might help?
Yeah, so I mean, of course, I think when you're trying to, like, monitor the drift, you might see that it suddenly, let's say some user is using the agent differently, and it's asking, let's say they're trying to ask some privacy breaking questions. Let's say someone is trying to get my phone number or email address, right? Like, and so now that would pop out as its own cluster that is not very different from the other ones that you're traditionally monitoring. So you have the baseline that you're going against, right? Your baseline could be the last 30 days or 1 week or whatever time period, 90 days. So it gives you enough sort of ways to, like, monitor it. So if anything that sort of stands out as an anomaly can be caught. Now, one metric doesn't catch. So yes, you do have to monitor for conciseness, completeness, relevancy, like all kinds of metrics that you can see whether this is actually a behavioral problem, user behavior problem, or is it actually a model issue or a data issue. So you need to be able to segregate all of those things.
Yeah. Thanks, Krishna. So we are coming to a close. One last thought, right? So do you see the organizations that you're dealing with, are they taking a more security and observability first approach? Do you see that starting to happen? Or they go and deploy POC and then security, that's auth, access control, and observability, it's an afterthought. I mean, what do you see? What is the pattern that you observe in deployments?
Yeah, let me think about that for a second. I think in our world, the number one thing people are looking for is runtime enforcement. I think observability is table stakes. Like I think in every conversation we're in, they just assume everything's going to be logged for observability. But the problem statement right now is about runtime enforcement. How do we prevent the wrong thing from happening? And how do we observe that we didn't miss something?
And sorry to interject here, right? So because probably agentic AI observability is a natural extension of ML, machine learning models observability, right? So because we were doing it, the security, in terms of auth and access control, this is a fairly new area that has emerged, right? So because a lot of companies that are doing agentic AI observability, I don't know about Fiddler at this point, Krishna, but they evolved from ML observability into agentic AI observability.
Yeah. So we work really closely with LangChain and their product LangSmith. So we see this often. I think if you walk into a real organization with like over 1,000 employees, they have multiple observability systems doing different jobs. And so you've got your LangSmith system, which is critical. You want to know what the agent's doing and why it did it, and you can understand blast radius, and you can improve the agent and all kinds of really critical agent observability type work. But then you also have your security and incident management system, which is your security observability, which is a very specific product. And there's also new vendors there as well that are trying to do the agentic version of that. But those are different product suites. Now, do they overlap? Will they eventually merge into one product? Maybe. Datadog merged into a lot of different things. But right now, the overlap is there for small projects, but when you walk into an organization, they're currently separate.
Yeah. Thanks, Alex. Krishna, you want to add anything?
Yeah, so I think, as I said, like at the beginning, these three problems are important to be solved, like identity, observability, and security. Whether it's going to be a single platform that does it or there will be a multitude of tools, time will tell, right? So there is definitely a platform consolidation moment that we are seeing. Bigger players, the existing security observability players are interested in this thing. There's of course startups like Fiddler and Arcade that are trying to like establish ourselves in each of these areas. But there is, given how the world is moving, there is like from the developer angle, there is a need for tools kit that helps the developers to evaluate their agents, observe, and set up some controls around how these agents are performing. From a security angle, there's a need for discovery of all of the agents, first party, third party, identity, who's doing what, and some audit trail. I think eventually you will have multiple products that will be built in the space, and you have seen this in the traditional DevSecOps as well, right? You had like a Splunk, a Palo Alto, a Wiz, Datadog. You had so many different tools that would sort of emerge in with different angles. So I see that happening within the agentic world as well. There will be some new companies, some big companies coming into this space. It's going to be an exciting time.
Yeah, indeed. Exciting times indeed. Okay, we are 3 minutes over time, so I will end it here. Thank you so much, Alex and Krishna. Good luck being a practitioner in this field. I think both of you are doing some very interesting work. Very important piece of work that a lot of organizations, if they don't realize at this point, a lot of them they do realize, but those that don't realize, they will very soon need both of you. Thank you so much.
Awesome. Thank you, Raja. Thanks.
I just want to say it was a super engaging conversation. I liked how you looked at approaches to kind of handle, least privilege, but then if it's least privilege, it's not really productive. But you don't want to give it all the privilege. So you use a delegated authorization and, that neutral party to oversee and all the things that you talked about, really. We had some great comments come in. And questions coming through the Q&A as well. We have people who, look at some of our, participants, they monitor human activity, and they're asking questions like, I guess some of that might be applicable to monitor the activity of agent, like that was mentioned in this panel discussion. We are, think of them as humans in a way. We are monitoring humans in a way. So it's just really engaging, really great to see. And all the being in such an interactive environment with our participants as well was just really great and energizing. So we have 10 minutes to have a short little break to stretch your legs, and then we'll get to our next session. So we'll be back soon.
Thank you, Rebecca. Thanks, Alex.
Hey, welcome back, everybody. Hope you feel a bit refreshed after the break. We've had some great, interesting discussions so far. In this section, we're going to become more aware about, technical debt in agentic AI deployments. So there's new operational realities you need to be aware of when implementing agentic AI at scale, and this will be discussed in this panel. The accumulation of technical debt in agent orchestration, evaluation frameworks, safety layers, human oversight mechanisms, all these things will be covered by our experts. The discussion, focuses on engineering techniques, some architectural patterns, governance tactics that can help assist you in managing this debt just before it becomes, before it compromises dependability, security, and business value. So the objective is to offer kind of useful viewpoint on developing kind of production grade, sustainable agentic AI systems. So we have a great lineup of speakers who are truly leaders and seniors in their field, and they have a deep set of knowledge to share with you today. And our moderator, Kamesh Famu, will lead this discussion, and I'll hand it over to Kamesh to welcome our speakers and start the discussion.
So, hi everyone. I guess my name shows as Karthik. I'm Kamesh Vemu, and I'm going to be the host for this panel discussion. So, just want to make sure. Okay, so we have Karthik on the online as well. Hello everyone. I'm Kamesh Vemu, although my name shows slightly differently. I'm totally fine being Karthik though. A quick introduction about myself. I lead ecosystem success and product growth at Enterprise DB. It's an industry leader in Postgres and Postgres technologies. I work with enterprises across industries and geographies that are trying to adopt agentic AI across their enterprises. And I'll be driving this discussion, but with active participation from the panel that is online. So before we, just a quick context setting before we get into this panel discussion. I'm sure all of you have heard about agentic AI. It's different. It's different than everything that has come before. But the technical debt in agentic systems isn't just more of the same debt. It's a new category of risk, as a lot of us are facing today. In the last 40 years of software engineering, technical debt meant messy code or outdated libraries. You could still predict what the code does, but it just took longer to fix. But in agentic AI, technical debt is different. It's alive, it's stochastic behavior, constantly shifting reasoning patterns, etc. And this is certainly a very exciting topic for myself, the customers I work with, and the industry today. So today we have three people on the panel who are industry and thought leaders in agentic AI. Jerry Liu, co-founder and CEO Llama Index, Karthik Talamarpula, distinguished architect Oracle, and Nav Bhasin, who is a senior data science manager from AWS Generative AI Innovation Center. So if I can have you have the panelists introduce themselves. So maybe start with Jerry.
Hey everyone, Jerry from Llama Index here. You might have known us as a RAG framework around 3 years ago. We got pretty popular in the community back when ChatGPT first came out. Long story short, we kind of narrowed our focus and pivoted a little bit. So today, our main focus is building the world's best agentic document processing platform. So we really care about the world's most complex PDFs and helping to digitalize that and provide plain text context for your AI agents. I can speak to the general agent architectures as well. We think a lot about like the end use cases that will help like automate knowledge, or sorry, the agent architectures that will help automate knowledge work in general. For us, it all starts with the documents. But passing it over to Karthik.
Yeah, thank you, Jerry. Hey everyone, I'm Karthik. I'm an AI architect at Oracle. And at Oracle, obviously, we're taking agentic systems all the way from research ideas into production grade enterprise workflows, mostly to do with accessing your data and what you can do with that data. As you guys know, Oracle is one of the world's largest repositories of enterprise data and knowledge. And that's very important now because LLMs have basically trawled all of the public data that's there on the internet. And so now the differentiating data that really remains is a lot of the enterprise data that's there and so on. My background is from automated planning and reasoning. So these days I end up spending a lot more time thinking about how to make agentic systems more reliable, more predictable, more governable, so that they can actually be used at scale. And we'll talk about that in the panel, how to manage technical debt, reasoning debt, and a whole bunch of other things. Before coming to Oracle, I also spent some time at a couple of startups, training our own models, deploying them, and so forth. So yeah, I'm looking forward to the panel, and I'll pass it over to Nav.
Thanks, Karthik. Hello, everyone. I'm Nav Basant. I'm representing AWS here. I lead a team of specialist scientists at AWS Generative AI Innovation Center, where we partner directly with the enterprises as we move their agentic AI workloads from whiteboard to production. And that's the gap between these two things where all the interesting problems live. We're going to talk a lot about that today. A brief background of me, I'm one of the founding leaders here at AWS who is responsible for launching the AWS Generative AI products like Bedrock, very recently Agent Core, and prior to that, Amazon SageMaker. Thank you.
Okay, thanks, Nav. So I think in the audience, we have people with very different backgrounds and a great attendance today. So to start us off, I would like to ask each of you to talk about agentic AI technical debt, more in the perspective that you bring, the kind of users you work with, the customers, not traditional ML, but agentic AI. Essentially, what keeps you up at night as you think about your customers that you're working with every day? I'll start with Karthik, if I can.
Yeah, sure, Kamesh. So, I mean, there's a lot of things that keep me up at night, right? I think one of the things, obviously, a positive thing, and then I'll come to the negative thing that everybody wants to hear. The positive thing, obviously, is with all of these, with wipe coding and all the models that are there and so on, it seems like your legs cannot run fast enough, right? There's a lot of interesting things that you can do. I'm sure a lot of people, who are listening have had a similar experience. But let me talk about one specific thing that does keep me up at night, which is this notion of consistency debt, right? So what I mean by that is the gap between what an agentic system, a Gen AI agentic system, appears to be doing versus what it actually might be doing internally, right? So we all know that, LLMs, even today, 6 or 7 years, actually maybe even 8 or 9 years after the seminal paper came out and so on, they're still black boxes, right? And what we've managed to do over the last, almost a decade is we've moved from source code that we could read and, test and so on, to reasoning that we cannot see, that we absolutely don't even know, we can't predict what's going on inside and so on. What we can do is we can build structures around it and we can kind of, fence it in and so on. In traditional systems, you could kind of inspect logic, but in agentic systems, you're kind of relying on the latent capability of the system, which is very opaque, it's very black box and so on. And this becomes very dangerous at enterprise scale, right? Because what's happening is your failures are not loud failures anymore, right? They're not failures that you detect, as you're writing your code or as you're deploying your code. It's something that happens after you've deployed to production, right? And then these silent failures, they tend to, kind of compound, and they're very hard to root cause, because by the time you actually by the time you realize that there is a failure, you have to go back many steps, right? And you have to understand. And I know we'll be talking, I think, about telemetry and a whole bunch of other stuff, in the panel. But to me, that's the largest problem, this kind of silent failure, where, the agentic system will fail way down the stream somewhere, and then you just don't know, why it kind of came up with that failure. So in my opinion, agentic AI doesn't just create technical debt, which is the title of this panel. It also kind of creates this whole consistency debt, this logic debt. So I think that's kind of what keeps me up at night.
Yeah, that's a great point, Karthik. I think being able to explain what's happening, being able to see and course correct, that's actually a big challenge in enterprises today. So
and being able to do that early on, rather than wait for the silent failure and so on. Yep.
Absolutely, absolutely. So now, if I can ask you, I know you're at AWS, you're working with customers at different phases, from POCs to production, and many places in between. So what's the one thing that you consistently see and you think that's, I wouldn't call it keeps you up at night, but a top priority for you?
Absolutely. See, at AWS Gen AI, we work with hundreds of customers as we take their workloads from POCs to the productions. But one thing which stands out, and we've seen a lot of customers underestimate, is that the debt isn't really in the code. I think Karthik was alluding towards that as well. So when we work with the enterprise team, we rarely find a bad model choice or like a broken framework integration as a root cause of failure. Most of the time, they have chosen the right models for the right tasks, maybe a larger, in some cases, maybe a little bit expensive, but they know where they want to go to. But what I find is that the teams have built agents, they can no longer explain. It could be because of the using vibe coding or whatnot, but there are multiple issues as you start digging deep or peeling the onions within that, right? And they can't tell why the agent made a specific decision on a specific day. They can't predict what will happen if they change the prompt. In many cases, the prompts are humongous monolithic, right? They can't tell if a behavior shift they're observing is a bug or it's a feature. And it's not a technical debt in a traditional way. It's something what some of the researchers are nowadays calling as a cognitive debt. And it's uniquely dangerous in the agentic systems because the blast radius of something like, I don't understand my own system, scales directly with the autonomy of the agents though. So you can imagine if it is one LLM call versus the 15 calls within an agentic flow where you start with this, I don't know the system, that exponential increase in the cost, the risk there. Yeah. And in a way, we spent the last decade teaching the teams how to write tests for the code. But now they're pivoting towards, hey, how do I write the tests for the behaviors? And this is an interesting thing I was reading a few weeks ago. In 2015 or so, Google had a paper which they had published a paper about machine learning, that ML code is just like a tiny bit of the overall ecosystem of a machine learning project or a frame applications. If you look at the agentic AI, it's something similar. The agent code is a very tiny part of that. What's around it, the integration, the governance, the security, the observability, the evaluations. I think that's where there's a lot of tech debt, where we try to use technology first. Hey, I build an agent, I use vibe coding, but we don't think about the ecosystem around it to take it to production.
Yeah, that's the whole life cycle of the application, which is not just building it, putting it out there, but continuously maintaining it. And that's a great point now that, especially when we talk about technical debt, that's an underappreciated part of the business. So Jerry, I know your company is going through a bit of a reevaluation. They're kind of pivoting towards other areas, but Llama Index is also one of the frameworks used across the board. Right. So what patterns do you see consistently that teams are doing that actually makes the problem worse in a way?
Yeah, maybe. I mean, I can speak to the vibe coding piece too, but I think that was already covered by Karthik and Nav. And I basically 100% agree with everything you're saying in terms of consistency and cognitive debt. Maybe just speaking from kind of what I've seen in terms of like context providing for agents in terms of, you're all Gen AI builders. We started 3 years ago as like a very simple RAG framework. The fundamental reality is that like all the kind of retrieval patterns and then how you can actually get up and off the ground running in terms of like creating your own, deep research agent. These types of patterns have fundamentally changed. And so I think the biggest type of debt that I've seen is when you kind of like try to overbuild your system a little bit in the beginning. Like let's say you have some like extremely bespoke fancy setup with like, naive RAG, a vector database, but then you also get really deep into like knowledge graphs. You have this like entire like set of code that's just like extremely kind of like complicated and like orchestrated in a very bespoke way. The reality is like the stack for Gen AI is changing all the time. Like generalized agent reasoning has improved massively from 2024 to 2025. The idea of having an agent have access to a CLI with file system search with like grep tools and having that be a strong baseline for retrieval is actually like, honestly, it was really hard to anticipate like a year ago. But now that's like kind of the gold standard for just like deep research. If you use Claude Code, it just is able to use your file system tools plus some like basic indexing to surface you the right results. And so I think one thing I would say is for any builder for Gen AI, I would start with something that basically is relatively simple in terms of code to maintain. Use like the out-of-the-box Claude Agent SDKs, kind of define some basic skills, MCPs, try to like actually just make use of the agent harness with some like relatively basic retrieval tools. Don't overbuild your data stack because it's going to be like extremely painful to actually migrate that. I'm saying this from like someone who's built a bunch of framework tooling in the RAG side of things. For us, what we see is even as like the retrieval and like indexing stacks have fundamentally changed, we still see like a giant need to actually unlock context from unstructured documents and other types of data. And so for us, we're kind of more focused at that core API layer or OCR conversion from documents to text. But what you do downstream of that, like I would just start with something simple so that's a little bit easier to swap out. Talked to a ton of startup builders that had like extremely bespoke like RAG stacks for their like AI agent for finance or AI agent for legal tech use case. They all swapped it out for like a Clyde plus file system plus sandbox. It's just like the fact is the underlying architecture changes all the time.
That's a great point, Jerry. So, as I'm looking at it, like consistently, I'm hearing, your failures are compounding. You have a lot of complexity that is good, but then to your point, Jerry, like starting with something small, contained that you can predict and then deliver value, right? So, I'm going to switch gears slightly with this context. So, I know we think about technical debt, and there are many frameworks on how you define technical debt. But I would like to kind of couch it under three hard problems, right? So I'll start with the first one. When an enterprise is trying to build an agentic solution, let us say a support chatbot, there is a lot of data, tooling, etc., ingested in the development phase. But then, as we all know, agentic systems are stochastic. They're not deterministic like classical software, where you could give an input and expect a predictable output. This makes a lot of downstream things more challenging, testing, evaluating, observing drift that happens across the board. So I would like to hear from your individual perspectives. Each of you bring a slightly different flavor to this problem. So maybe I'll start with Karthik. I know you have a research background. So from an automated planning and reasoning perspective, we are obviously gaining something by unleashing the power of LLMs and Gen AI technologies. So what are we gaining and what are we actually giving up just from the stochastic behavior and unpredictability perspective?
Yeah, no, I think that's a great question, Kamesh. As you referenced, right, my research background comes from automated planning, where the whole point of automated planning, even before LLMs were a thing and so on, was to basically break down, to have goal-driven plans, essentially, right? So if you have a set of goals for your system, to be able to generate a deterministic plan, a deterministic series of steps that will allow you to fulfill those goals, right? So let me start with what we lose, right, in this new era of kind of agent-driven and LLM-driven execution, planning and execution. What you lose is guarantees, right? So classical planning and classical kind of code, what it really gave us was this notion of determinism and verifiability. The kind of failure modes were very clear. You could predict for those failure modes, and you could kind of defensively write against those failure modes, right? So you had a lot of guarantees essentially, right? And we obviously built solvers and we built systems that basically would exploit that. And so in some sense, what you have is correctness by construction, right? The proof of correctness, it comes from the way that you have built your system, from the way that you've constructed your system, right? That's no longer guaranteed now in this new kind of Gen AI world, right? The correctness by construction paradigm has gone away, right? Instead, now what you're gaining, so let me talk about kind of the positive side of it, right? What you gain is breadth, you gain flexibility, right? So you get the ability to now operate in applications and environments and use cases which we could never actually fully model, right? So the dirty secret of kind of the classical world, the way that we used to do things, is that you had to spend a lot of time upfront to actually model the world or the domain, right? So suppose you're writing an application for an insurance domain or for a finance domain or medical domain, whatever it is, right? There is a big bottleneck. I call this the domain modeling bottleneck, right? And this bottleneck is something that you had to employ, multiple people to do it. You had to maintain various versions, iterations of knowledge documents, models, all those kinds of things, right? That kind of the need for that has come down a little bit, right? And you get the flexibility instead, where LLMs know so much about the world, they've seen so much data, they've learned so much about the world, that you get that flexibility and that breadth, right? But again, the shift away is that you're going away from correctness by construction to now correctness by observation, right? Meaning you cannot certify a system before it runs, right? And you can only certify it during the running process, right? And that's kind of fundamentally a bit of a weaker thing. It's a weaker contract, right? So your real problem, your engineering problem becomes, how do you wrap the stochastic kind of process of LLMs, right? I'm kind of refraining from calling it reasoning because everybody has a different favorite definition of reasoning, right? We can debate that later. How do you wrap the stochastic processes of an LLM within deterministic guardrails, right? So because we all know that sometimes, for the same, effectively the same input, you can get different outputs, right? That's not necessarily a bug. It's how the system is designed. The whole game is how can you kind of write guardrails around it and so on. And I'll just end with one thing, right? I have a bit of a, I don't know if this is a contrarian take, but this is a very strongly held view for me at least, right? Is we tend to overuse LLMs and agents a bit too much, right? And I know I'm saying this, in a conference that's about LLMs and agents, right? Not every workflow needs stochastic, a control flow, right? In many cases, structured pipelines will just do the job just fine. They're cheaper, they're more reliable, they're more, consistent. What you need to, the trick is basically knowing in what cases are the deterministic workflows enough? And in what cases do you want to actually introduce LLMs and agentic intelligence and so on, right? So in some sense, the hardest part of the agentic system, it's not the intelligence part. We have models that are getting smarter every day, bigger every day, and so on. The hardest part is not intelligence, it's controlling the system, right? How do you actually control that system? And how do you bring back some of the advantages we had, with the controlled systems of the past, right? So yeah, let me stop there, but I think that's kind of the main trade-off.
Yeah, that's a great point. So from a application development or addressing the use case perspective, Karthik, every one of those things are spot on. Like having the right tool for the solution that you're trying to solve, not like every throw a very big tool and then realize it's a really much smaller scoped problem. And then of course the flexibility of having, we've heard about guardrails a lot nowadays. Input guardrails, output guardrails, how do you control? And it almost seems like you're tailoring it for the user behavior. You want, the right kind of input to the LLM, otherwise you can't present the right expected output. So
I will say one thing about user behavior. It's known that, the PEPCAT problem exists between keyboard and computer, right? The user is always the problem. The human's always the problem. You remove the humans, everything is hunky-dory. But yeah, I think a lot of the consistency that we want, that is born out of the fact that humans kind of want that consistency, right? And they thrive on it. And we should do what we can to marry those two things, the flexibility with the consistency.
Yeah.
Yes.
So that's a great point, Karthik. So I'm going to switch gears a bit to Jerry. So I think from a tooling perspective, given that there are so many tools used in a typical enterprise application, so how do you, if you think about the framework, how does Llama Index help developers manage this stochastic behavior, make it a little bit more contained rather than kind of open up the aperture too much?
Yeah, I know this isn't really in the spirit of the question. I'm going to take a step back from Llama Index and kind of speak to the overall trend of frameworks and kind of what we see in the world in general. Maybe a little bit of a controversial take. I think a good chunk of frameworks are kind of dead. I think, like it or not, like a good chunk of usage of AI agents and also programming of AI agents is moving away from formal languages into English. I think I totally agree conceptually with what Karthik is saying, and that a bunch of workflows conceptually should be deterministic. The fact is, a bunch of people are also really lazy, and writing code takes longer than actually just writing it out in some sort of shitty prompt. And so I think it's easier to just have a person spin up 8 to 10 quad code terminals and just go in and try to do a bunch of tasks, whether that coding agent actually is solving it on its own through some sort of native skills or writing some sort of deterministic code. That's a function of the task itself. If it's deterministic, I'm gonna go in and actually write some script that can actually execute it end to end. If it's something that does require some dynamic reasoning, it'll just be a function of the coding agent itself. That's honestly what I'm seeing in the market. And so that's why when you see the current trend of agent engineering and so to speak, it's not at the level of code or libraries. It's at the level of programming in English and programming existing agent harness. And so I think as we're all basically users of these tools, but we're also builders of these tools. And I think the fact is everything's kind of converging. Using Gen AI and using agents is almost the same as building agents because the new programming substrate is basically English. I know that wasn't necessarily in the spirit of the question, but I think fundamentally that's where the world is going. We're accounting for that world, and that's also why I think a good chunk of these code-based frameworks actually, it kind of matters a little bit less. The fact is for users to get end-to-end value, it's really just using these end-to-end agent harnesses. And then the kind of remaining needs is everybody still needs access to external services, to context. So we're providing document context. There's other tools and MCPs that provide web search context and so on and so forth. And then being able to actually have the human be really, really good at translating business requirements into the prompts and skills and whatever needed. Because, I think as Kartik said, the fault's usually on the human side. If you're not prompting it right, you're not really using it to the fullest potential.
That's probably a good segue to Nav. So I know, based on what Jerry said, human in the loop. In production, what are some common failure patterns you see as you look at enterprises across the board?
Yeah, that's a good question, though, right? So there are two patterns which I'm going to talk about, and these are the most common which we have seen. And surprisingly, the common pattern isn't a dramatic failure. It's typically a drift. An agent that worked at the launch gradually starts behaving a bit differently. It could be a customer support agent that starts issuing slightly larger refunds over time, or a document processing agent that grows increasingly conservative and starts flagging items for the human review as the volume grows up, right, as it scales. And nobody made a change. The model didn't change. That's a typical answer. Hey, the prompt didn't change, but the behavior did. And nobody notices it till somebody from the business asks a hard question: what the heck is going on? My KPIs are not being met by the agent. What you promised me is not working. And that's the first one which we see, is that, hey, with the business KPI is not aligning after as it starts drifting. And the second common pattern, which we call, is like a cascade compounding. One failed tool call may be a retrieval that returns incomplete data. And Jerry, you are very familiar with this. Sets off a chain in the agentic flow. The agent selects the wrong downstream tool. It fills the gap with a plausible but wrong answer, and then it enters a correction loop. If it was a single LLM call, you can absorb the error. But in a 15 to 20 step autonomous workflow, that error gets multiplied exponentially. And now both these patterns share the same root cause. We gave these agents observability. We can see what they did, but we typically observe is there's very little effort spent on the evaluations. That means you can see, but you can't tell. So we can't tell if what they did was right. And this is a gap where most of the production debt lives today.
Thanks.
And I'll give an example, right? So I've seen an agent very recently, and that was doing exactly what it was prompted to do. That's where these big prompts come in, but it was still wrong. And the prompt hadn't been updated. The business rules changed a couple of weeks earlier. Nobody knew that the business rules changed, but the agent was faithfully executing around the outdated instructions. So how do you align your prompt with the business rules? I think that's a gap which we still have to fill there, right? The system had a perfect uptime, but the business outcomes were wrong every day. So that's another outcome which we see.
Yeah. So this is actually a good segue. I think we're kind of touching on one point that I would like to call it, the velocity at which frameworks are getting released in the industry. And I'll speak from the lens of an enterprise user who is trying to manage a number of solutions across their enterprise. First came LangChain, then Llama Index, now Crew AI, MCP is all over the place, and so on. There are these every 3 to 6 months, there seems to be new technologies, new frameworks, and I'm going to be careful with that word frameworks, but it's always this evolution. So for enterprises that are constantly looking to adapt and stay on top of this, it is a significant challenge. So if I can ask Jerry, as you're from a tooling perspective or from an API stability, backward compatibility perspective, what would be your advice to people who are building these enterprise solutions? How should they think about compatibility across the board?
Yeah, for sure. This does kind of relate to my earlier point, but maybe just to provide a little bit more of a comprehensive answer. I think for us, Llama Index, especially the open source tooling, we see ourselves as really the providers of like data or context to various sorts of agents that you build. And so, regardless of what LLM or even LLM framework that you're using, whether you're using, Light LLM, LangChain, or just the broad like OpenAI, Anthropic SDKs, I would see us as really being able to be a core component that can help unlock context from specifically unstructured document-based data, and also index, retrieve it, and help provide context for your AI agents. I do think in general, that's kind of where the world is going, is that frameworks themselves are getting a little bit more specialized into like specific modules. Because I think in general, frameworks themselves are, again, kind of dead. Like I think LangGraph, you can see, I mean, not to like kind of speak ill of like other tooling. You can see like a lot of the kind of directional trend of a lot of these frameworks is they're going from like kind of these simple, shallow abstractions into basically kind of like what I said, like agent harnesses. You know, LangChain went from LangGraph to deep agents. There's like the Claude agent SDK. There's a lot of there's like open code, and there's like a few of these that kind of reflect the modern state of the world, which is you have like a generalized agent harness, and then you think about like the tools and MCPs that you actually like plug into the general agent harness. I think that's actually where the world is going. And so when you're a tooling provider or you're a decision maker figuring out like what stack you're actually trying to use, it's usually some sort of like generalized agent harness plus like how do I actually have the right platforms to actually connect my external tools and contexts into this thing. And it's a little bit different than kind of like having a very broad framework that covers like almost everything from orchestration to data end to end. Because there's actually a little bit less of a need for that now with the rise of both generalized agent harnesses plus the fact that vibe coding makes the cost of like integration pretty low. It's a very kind of like candid answer, speaking from someone who's like built a lot of these frameworks. But the reality is we obviously still care a lot about open source tooling. But I think when you look at us, I would want to make sure that we're the best provider of data from unstructured documents. You know, all our open source plus commercial efforts have been going towards that. And we're like a kind of like tool that can plug in to some sort of like generalized agent as a lot of these underlying model capabilities get better.
So, Karthik, as Jerry was saying this, I was thinking Oracle is on the other end of the spectrum, if you will. I mean, traditionally, historically, a company that has built extremely stable, long-lived enterprise infrastructure. So, how do you evaluate these constant changes in the industry? And it's only getting faster. So
yeah, look, I mean, again, in the spirit of being candid, right? Which it's great that Jerry was there. We are on the other end of it, right? And a company of like the size of Oracle, we have to assume that frameworks are ephemeral, right? That today there's this framework, tomorrow there'll be something else, and the day after there'll be something else. Especially given the rate of the speed of change of things in the AI industry right now, right? So my opinion, which surprise, surprise, happens to coincide with my employer's opinion, right, is that stability doesn't necessarily have it come from just the model or the framework, right? It comes from the system that you build around it, right? You could be using whatever framework, you could be using Llama Index, could be using LangGraph, could be using whatever, right? Frameworks are essentially temporary just by nature, right? But your architecture should try very hard not to be, right? Your architecture should subsume all of that, right? So one way that we try to do this is that instead of committing to any one single framework, we try to invest like one level higher in like the control planes and the abstractions that kind of sit above that, right? So let me kind of be a little bit clearer about what that means, right? We tend to standardize around interfaces and not specific implementations, right? So we say that we'll work with whatever implementation is there, whichever framework is on the ground, right? But we'll operate more at the interface level of okay, if you're now getting this output from a model, you want to render that output to the user, right? Here is how you deal with that. And then the actual machinery that you use to show the user the output, you can mix and match, and you can plug and play things and so forth, right? We also kind of isolate some of the business logic from the frameworks that are used, right? And again, like I said, you want it to be swappable. You want it to be kind of plug and play and so on, right? And one of the things that I want to call out here, right, is our team within Oracle, we've been working and we've released it now, it's open source, on something called Open Agent Specification, right? So the Open Agent Specification or agent spec is basically an open source way of defining your agents, right? Of defining the specification for your agent. And it works with every framework that's out there. It works with LangGraph, with Crew AI, with, you name it, whatever, frameworks are out there. So the idea is that you as a, business owner or as a subject matter expert, right? You shouldn't have to be in the business of writing code for a specific framework or whatever, right? You should be in the business of defining your agent, right? Because you're the expert. Suppose, you're with the insurance industry, you're with the banking industry, you know everything about that industry. And so you should really be encapsulating the business processes that happen and the agents, that should be born out of those processes. And then let something like Open Agent Spec take care of the translation to the specific framework that you want to use, right? And again, we're not interested in lock into one specific framework or like an Oracle specific product or whatever. That's not our point, right? Like I said at the very beginning, that we are sitting on top of very valuable enterprise data, the largest amount of enterprise data in the world. Our objective is to allow our customers to unlock that in any which way they want. They can be using whatever framework they want. They can be using, whatever tools that they want, right? So in some sense, my opinion here is that we should not be over-indexing on frameworks necessarily, right? They help, but they don't solve this question of reliability of agentic systems, right? Mostly what frameworks tend to do is they reorganize complexity, right? So they take technical debt from this side and they put it in the other side. And so you should be picking the framework whose technical debt you're the most comfortable working with, right? They're not all the same, right? A Llama index will be different from a LangGraph, will be different from a Crew AI, right? It's like technical debt is kind of this amorphous like mass. It moves around, right? And you want to pick the one that your team is the best equipped to deal with, right? And so I actually, the thing that I agree with Jerry the most on is we do need more and more of these open frameworks, right? Which different people can adopt, and then you can write adapters to them and so on. So I think that's kind of the approach that companies like Oracle takes.
Yeah. So I'll give Nav a chance to respond to Nav. I know when we mentioned abstraction layers, I was thinking Bedrock, Agent Core. These are all frameworks abstraction layers from AWS. So, what's AWS team's opinion on this, or what have you seen in the industry? So,
I'll give two answers. One is I'll start with the AWS Shabil. Yes, AWS provides these frameworks, these services like Agent Core, which you see. They really reduce the debt, right? But they insulate the debt. As an example, if you're using Agent Core, you probably don't have to provision all the infrastructure around it. And that saves several weeks and months of the time which you need. You need a HIPAA eligible environment or a PCI compliant environment, and you get it out of the box. You need a memory, long-term, short-term memory, or the security, which is all built in integrations with that, MCP servers, etc. So that's quite a lot of work. But the honest answer is it insulates some of the debt, but it relocates the other debt. I think that's what Karthik was alluding towards, and Jerry also touched upon it, right? So the managed services absorb some of the debt genuinely, which is the operational part of it, like versioning, patching, scaling, orchestration, infrastructure. That's real and it's not trivial, right? But what they cannot do is they cannot protect you from your own architectural decisions. The debt that gets relocated is the abstraction coupling. That's what we have seen over and over again. If a team typically wire their entire business logic tightly to a specific framework API, I think that's what Karthik was alluding towards, is the abstraction between the framework and the API. That changes the orchestration. Any changes with the orchestration layer under that breaks things, right? The platform can't fix the tight coupling in the application code. And the teams I see who are handling it very well, they have internalized this principle. They separate the stable from the volatile. What I mean by that is there's a stable layer such as identity, logging, policy enforcement, tools, contracts that should be totally decoupled from any specific orchestration framework, regardless which you're using. This is your platform, your baseline or the foundation. And the volatile layer is the reasoning engine, the orchestration patterns. That's where you want the flexibility to swap. There are multiple different rubrics you can choose to which framework works for me. It could be based on your business use case, the compliance, all of those, right? The region you are based in, the programming languages you are supporting, right? But if you are designed for that separation, framework churn becomes a configuration problem, not an architectural crisis, right? And if you haven't, it becomes a total rewrite. So that's what I would say.
Yeah. So I actually, when you're saying stable and volatile, I think that thought came across multiple ways from the panels here. I think of observability as a key requirement when we think about that separation. You still need to be able to think about where do I need to go in and address anything that's not having the intended outcome. So the third topic that I want to touch on, and maybe I'll stay with now on this one. What do you think about observability and think of a production agent? What's available today and what is missing? And that's the key part that, industry is evolving towards. So.
Yeah, and see, the good part is observability is not new. I mean, we have been using observability for almost like a decade since I remember, right? The same term came up with observability. Folks, there are multiple specialized tools like Datadog, and even within AWS, we have CloudWatch. We have Bedrock agent with the monitoring, etc., which is there, right? So most teams I have seen, they have observability, perhaps with the Langfuse or Langsmith or Arise, or many of those different platforms exist. But almost no teams or very few teams have evaluations, and they're not the same thing. Sometimes we use that term very interchangeably. I have observability, but you need to separate it or think about the evaluations differently from the observability. So observability tells you what happened, things like latency, the error rate, the token counts, the tool calls. But evaluation tells you whether what happened was correct. It answers things like, hey, did the agent achieve the right outcome? Why the right reasoning path, using the appropriate tools within the acceptable cost and the risk bounds there, right? And recently there was a stat which came out of Databricks. They released a state of the agents report. And it's aligned with what we have been observing as well, as is that almost 89 to 90% of the organizations which are deploying the agents have some observability, whereas around 50% of them have some evaluations, not even very comprehensive, but some. So that's almost like 37 to 40% gap between the observability versus evaluations. And that's where the production failures occurs, right? The systems that look fine on the dashboard say, I can see my metric, I can see my cost, but you're drifting towards the wrong outcomes, right? Now, the second part is, what does a good looks like? That's very important. And in our experience, something what we call is a golden trajectory. So validated execution traces from the production that captures not just the output, but the complete reasoning chain, every tooling location, every intermediate state. When you change a prompt or swap a model or update a tool schema, you automatically run your new behavior against those baselines. And if you see a divergence, that's an automatically blocks your deployments. Same as failing like a unit test, right? You can see what happened and you can tell if it was right. And what I typically tell folks is that what's the practical takeaway out of this, right? When you go to production, take your first 100 production agent runs as your most valuable assets, instrument them obsessively, curate those as they represent the correct behavior you're going to see in the golden data set. And after that, this becomes a regression problem. And these regression problems are solvable. We have been doing it forever.
Thank you, Nav. I know we are coming up on time, and this was a very interesting topic that everyone wants to learn more about. So, as we come to this, I want to ask each of the panel members to tell us, in your view, how should leaders think about organizing their teams? Like, it's not just a tooling and infrastructure and ecosystem problem, which is constantly evolving, but it's also about how you line up the teams and the capabilities. So I'll start with Jerry, but if you're a senior leader in a big organization, how should you think about having the right kind of organizational structure?
Yeah, I'd like to think we're pretty bleeding edge organizationally when it comes to AI. But it's kind of interesting because we're a 35 to 40% org. And the reality is every engineer, and to some extent every non-engineer too, is managing a team of agents through whatever your favorite agent tool is. And the cost of implementing code is actually, going not quite zero, but like going down quite a bit, which means if you think about the chunk of time that you have allocated during the day, it means that engineers get a lot more leverage, not by writing more code, but by actually setting the right goals, outcomes, doing actually some of the product specking, making sure the designs are right, doing the right testing and validation and iteration afterwards to make sure that you're actually able to deliver like a high quality feature and then are able to multitask and ship like multiple features at once. So the reality is the line, and I'm pretty sure like other business leaders have said this, it's not just me. And so like the line between product design and engineering are basically collapsing down into not quite one person, but like getting there. And so as a result, I think it's quite interesting. Like if you are almost like you basically need to make sure every engineer has that skill set of being more product minded, because that is where they're getting the most leverage today. After making sure that they're able to make use of all the tools to automate the actual code writing. The need for kind of like cross-functional, like, product engineer like delegation has like fundamentally shifted a little bit due to kind of like some of the speed of vibe coding tools. That's what I'll say on the organizational side.
Yeah, thanks, Jerry. So Karthik, you have a unique perspective. I know you've been in research and industry. So what does organization and the right teams, what does that look like for you from your perspective?
I'm going to say something for the sake of the panel that I hope my leaders don't see. But I think a lot of leadership, senior leadership in the AI era, they need to start getting themselves into the mindsets that they're actually now research leaders, not engineering leaders, right? And what I mean by that is that, and this is building on Jerry's point actually, right? That you have a bunch of whatever you call them, engineers, product-minded people, designers, whatever. Everybody has access to a team of agents, right? But there is no playbook on how to, work with these agents yet. We're kind of discovering that right now. And so it's more of a research problem than an engineering problem right now, right? It's more of an art than a science right now, right? And so I think, see, one of the things is that the biggest gap always between research and production, research proves possibility. You've succeeded at research if you get the thing to work for the first time, okay? Production means you need to get it to work for all the other times afterwards, right? And that's where the technical debt kind of lives, right? It lives between working the first time and then working consistently all of the times, right? And this is what actually creates a lot of hidden debt. Like going back to vibe coding, right? Vibe coding is great. It increases the potential of what your team can do, right? But leaders need to think like that too, right? Leaders need to not just be wowed by the demos, right? That's only step one. The POC or the demo that was built, that's step one. There's a whole bunch of technical debt between that and, don't wake me up at 3 a.m. because, something went down in production, right? And so I think leaders also need to account for that. Yes, you're getting a huge productivity boost with having, your engineers and all of your, assets be able to use agents and so on. But understand that you're now fundamentally in a world of research, not production yet, right? And so, you're living, it's no longer ideal inputs. You're living in a world that's messy. There's adversarial environments. Your main workloads may be long tail workloads, things that may not occur all the time and so on, right? So I think that is what I would tell research leaders, right? Like think like research leaders, not engineering leaders anymore, right? And pay attention to the part that works in a demo is also the part that's going to become debt later on in production, right? So pay more attention to that is what I would say.
Okay, thanks, Karthik. So now over to you. It's like one consideration for enterprise leaders on structuring their team.
It's a very good question, and it comes very often actually. And there's a saying here within AWS, and I have an article on this. Is so the agentic AI works best when it looks less like a magic software and more like a well-run team with the clear jobs, supervisors, and the playbooks, right? And what does it really mean is that before you build an agent, write the job description literally, right? When you hire a new employee, you write a job description, you post it. That's how you hire somebody, right? Same thing should apply to the agents. What is this agent hired to do? What decision it's authorized to make? What out of scope? How to escalate? When to escalate? Who to escalate? What the success looks like, et cetera, right? And many teams skip it and they start with the technology first rather than the definition of the agents, and they end up with the challenges which we are all discussing about here, right? Now, coming back to the team structure side, I think the enterprises who are doing well, they have separated three roles that often gets conflated. There's a platform team that owns the infrastructure. These are the ones who are experts in identity, logging, tools governance, cost metering. That's one. The second, which is very important, especially in context of agents, is the domain teams. They own what the agent actually does. It's not an IT job. It's not a data science job. It's a combined, it's a responsibility of the domain owners who really know what the business is, right? They are the one you should work with the prompts, the tools, the evaluation criteria. Typically, if you just make data scientists as a responsible party for the evaluation criteria, you're going to fail because we are not domain experts at that time, right? And then the third pillar here is the operations team, right? They own what happens when it breaks. And sometimes you can club even the compliance with that. These are the folks who own run books, escalation paths, rollback procedures. And the failure is when it's the same person who's doing all these three roles, or it's one team doing all these three roles, you get a system that's optimized for launch, but neglected right after it's launched. Right?
Okay.
And the most important part here is that it's not a one-time activity. Once you deploy the agents, all these stakeholders, they need to continuously work with each other, keep on monitoring the agent behavior because all these drifts that happens, right? It compounds.
Yeah, thank you. Thanks. So I do want to pause here. So I want to thank all the panel members. This was a very enlightening meeting. I think we touched on a broad array of topics. So certainly a lot for the conference attendees to think more about. So back to Rebecca.
Yeah, no, thank you so much. It was super insightful for me, and I learned a lot. And we even had some of our audience participant members reflect on the kinds of debt that they're experiencing themselves firsthand, whether it's cognitive debt or that consistency debt and the overbuilding debt. So it can definitely help. Yeah, we're going to take a short 4-minute break, and we'll be back at 1:10 Pacific time. So it's 4 minutes from now, and then we'll get on to our next session. So we'll see you soon.
Thanks all.
Okay, welcome back, everyone. Our next speaker is Andrea Kropp, and Andrea is going to show us how to do agentic document extraction at scale using Landing AI. Thank you so much, Andrea, for being here.
Yeah, thanks for having me.
Over to you.
All right, let me take it away. All right. Well, happy Monday, everyone. I'm Andrea Kropp from Landing AI. I'm excited to talk to you today about agentic document extraction at scale. I am an applied AI practitioner, so today we're going to be talking about a specific application of agentic AI in the document space. And in addition to sharing some of the technologies that Landing AI has developed, I'm also going to show you how you can create a self-improving pipeline using some multi-agent orchestration. So I'm not going to claim that I am the expert in the pipelines or the multi-agent piece. I see that there are some amazing speakers on the rest of the agenda that will cover those topics, but I do want to teach you a little bit about the document space and how to integrate that with existing pipelines. So before I jump into it, quick thanks to the Data Science Dojo team. You're putting on an amazing event. There is so much great content, and we're really pleased to be back for a second year. So let's go ahead and get into it. So as I go through the talk today, I do want to encourage you to maybe not follow along in real time, but definitely create an account and test some things out in the playground afterwards. So special offer, create an account with us in the US or the EU region. There's no credit card required. There's enough credits to do quite a few hundred pages. So I've got this QR code on a couple of my slides, and I'll flash it up in between. I'm also mentioned that I am joined by my team, Ron, Bianca, Seshu, and Ava. You can find them in the chat in the Q&A area, and so they'll be handling your questions while I'm talking, and they can also get you hooked up with that QR code or that link. So just really briefly about me. One, I talk really fast. That comes from several years in management consulting, leading technical teams, now doing technology sales. I am entirely self-taught as a data scientist and practitioner. I originally studied chemistry in graduate school, worked with lasers. Now I work with data. And my hobbies are tennis and board games. I live in Washington State, so if you're ever in the area, we can connect for a game. So I'm going to organize my talk actually around the title of the event, right? So agentic document extraction at scale, building a self-improving pipeline with multi-agent orchestration. So first, we're going to talk about agentic document extraction. So that is actually our product name, but it's also a very descriptive name of what we do. So we process documents. And we do want to help you do this at scale in production, right? So the last group of panelists was just talking about the difference between research and a science experiment and then making something repeatable and scalable and not having to get people out of bed with 7-1 emergencies. And then we want to take some of those concepts and figure out how can we make this even faster with this kind of self-improving pipeline multi-agent orchestration. So as we kind of gradually reveal all these pieces, hopefully it'll really come together at the end. So part one, what is agentic document extraction? So I'm going to introduce the technology, the product, because you're going to need that information to then think about your document processing pipeline and how can agents operate on that pipeline. So a couple of key takeaways for this section. So these are APIs that convert documents into accurate structured data. Everything's going to be fully auditable and traceable. It is agentic by design, that's even in the name, works on all documents, capabilities far beyond traditional OCR, and very easy to integrate. So hopefully, if I do my job well, those will be kind of the key takeaways. So let's pause here and think about the world of documents. Like, oh my gosh, the world still runs on paper. There are photographs of paper. There are scans and faxes of paper. There are all sorts of crazy document layouts. There are handwritten notes. There are multiple languages on the same page. So real world documents are incredibly, incredibly messy. So what we really set out to do was to create a system that is made for these real world documents, right? We're almost starting with like the edge cases first. So can it work on lots of different input types? Can we deal with handwriting and scans and photographs of documents? Can we equally support character-based languages, as well as we support English? Can we understand lots of embedded charts and diagrams and kind of go past a bar chart or a pie chart to get into some of these complex scientific charts? Can we understand like circles and handwriting and signatures? So everything we're going to talk about today is designed for this real world messiness of documents. And what we've created at Landing AI is a proprietary set of models that we call the DPT family. So these are document pre-trained transformers. So if you're at an Agentic AI conference, you're probably familiar with transformer models, but this is specifically trained only on documents. And it offers some really unique agentic capabilities, which you'll see once we kind of get into some of the demos. So enhanced layout detection, chunk ontologies, figure captioning, really detailed table captioning. This is all possible through some proprietary technology. And this is really the direction that our founder, Andrew Ng, thinks the world is headed. So Dr. Ng is our founder, still serves as our executive chairman, and he gave a great interview with Forbes at the end of last year where he says that we're past the era of one-size-fits-all models. So he really believes that these kind of purpose-built models to bring specialized intelligence is really the wave of the future for the next couple of years. So this DPT model, where D stands for document, is one of many probably purpose-built models that you're going to encounter in the next few years. And ADE, DPT, that's a lot of acronyms. So Agentic Document Extraction, Document Pre-trained Transformer. It's really fundamentally different from OCR. So in OCR, the C and the R stand for character recognition. And if you just look at the paper from OCR, like you realize that what's happening under the hood here is actually like the recognition of shapes of letters, right? Incredibly difficult problem. And kudos to the people who worked on it, in the early 2000s. But this is fundamentally, we're in this agentic era, we no longer have to focus on kind of this character recognition of letters. And what we're going to talk about today is also fundamentally different from vision language models. So I threw in this slide because a lot of people I talk to are really familiar with large language models, right? So you've got some sort of text input that gets tokenized, gets sent to an LLM, and there's some sort of text output. A vision language model is actually taking two sets of inputs. So there might be an input image, like, here's a scan of a receipt, right? And then there's a text input that says, what is the total on this receipt, or what are all of the items purchased? And that visual input and that text input are actually going through different pathways. They both need to be tokenized before combining them for the LLM, and then hopefully answering the question, like the total is $10.91. Right. So the vision language model approach is powerful, but still has a couple key drawbacks when it comes to documents. So they do tend to hallucinate when visual cues are missing and ambiguous. They can't tell you where in the document they found the answer, so they can't really ground that $10.91 back to like the pixel location in the receipt. They really struggle with a lot of nested layouts and multi-page structures, right? Because they're looking at kind of one page at a time. And honestly, to fit those input dimensions of the encoding models, they're often really they're resized and compressed, right? They make the text so unreadable that a lot of the fine details are lost. So what we've set out to do really is address kind of the shortcomings of OCR, address the shortcomings of the vision language models, and we've been able to achieve, a document extraction model that performs extremely well on this kind of doc VQA benchmark. So again, my goal with this section is really just to give you enough information to absorb what comes next. But this is definitely worth checking out, and we'll take a quick look at the benchmark in a moment. But this is a comparison against vision language models that are taking that approach of the text input and the vision input at the same time. So we offer a couple different APIs for what do you want to do to your document? Do you want to parse it, split it, extract from it? So parsing is really about understanding all of the content in the document and turning that into layout-aware markdown. Splitting is taking a longer document, breaking it into pieces, and extracting focuses on key value pairs. So typically things, you're going to have to parse first. You may skip the splitting step, go to extract. You may not need extract if you're doing mostly RAG applications. And again, like I'm a huge visual learner. I'm going quickly so we can actually get into some of the code in the demo. So a couple of things that are special about the Parse API, you're going to see layout awareness, you're going to see cell level grounding, you're going to see like the ability to handle really complex layouts. And again, all of this is designed for processing at scale. With the Extract API, as of last Friday, we can now support infinite schemas. So, my receipt example, you may only want to extract 4 to 5 items, but if you had a massive 10K report from a company and you wanted to extract 800 items, you can now do that all in one shot. And a lot of these other things I think will make more sense once you see them. So 2 use cases that I want to highlight. I know there's a lot of data scientists and developers and builders on this call. So anything that deals with field extraction, and especially if you're an organization that receives a lot of user-supplied documents, you often need the ability to extract specific information from that and also be able to tie it back to the original. So if you're processing mortgage applications, for example, you may be asking for a pay statement and you need to extract the gross wages or year-to-date wages. You may similarly need to extract from tax documents. You may ask for something like a utility bill as address verification. So this kind of user-supplied documents where they're all a little bit different and they can be damaged and they can be rotated and they can be crazy is a great use case for what you're going to see here. And then the second major use case really is preparing documents for RAG when they contain a lot more than text. So if you are, working in the healthcare space or maybe in equity analysis, there's a lot of cases for doing more sophisticated chunking of your documents to prepare them for RAG. So some of the images that you see here, there are complex tables, there are flowcharts, there are infographics, there are scientific charts. These are often typically ignored by a lot of chunking approaches if you're using traditional OCR. But if some of the richness of the content actually exists outside of the paragraphs and it exists in these images and figures, you're going to be able to actually agentically extract them and also get an explanation of that flowchart or that infographic. Okay, so here's the QR code again, and now we're going to go see it. I'm going to do a quick time check. Okay, that was nice and fast. All right. So at this point, you see all of the tabs that I have open, and we're going to spend a lot of time here looking at some examples, and then we're going to do some code as well. So this is our visual playground. As I mentioned before, we are an API-based service, but we provide this visual playground to make it really easy for people to get started and kind of test some of their own documents. So you already heard me talk about parse, split, and extract. Pretty much everything starts with parse. And our demo document for today that we're going to start with is Mr. Demo Patient and his 12-page lab report. So he's got some blood results, some kidney function, some liver function, some cholesterol, and we've got a really extensive lab report that also has, some patient details and the lab that ran the tests and the doctors that ordered it. So let's go ahead and take a look at what happens with a document like this when we go to parse it. Okay. Okay, so what's happening in the background now is we're calling that DPT model. Right now we're on DPT-2. We'll be releasing DPT-3 sometime in 2026. This is a 12-page document, so that's actually being parallelized and you will get the result back basically when the slowest page in that set of 12 is done. At the parsing stage, we're going to get back a markdown response, of which one of the top level objects is a markdown representation of the entire document. And there we go. So at the parsing stage, we have Markdown and JSON. And let me actually start here with the JSON output. So this first row, the Markdown, is a top-level object and contains all of the content on this tab. So it goes far, far, far over to the right, contains all of the content on the Markdown tab. And then we have individual chunks to identify the regions of the document. So let's go ahead and go back to the Markdown, and you'll see kind of like why people like this visual playground. It makes it really easy to zoom in on the original and then take a look at the extracted values and compare them for accuracy. So a little bit of color coding here. So we've got a logo in red, a text chunk in green, a QR code here in, call that orange, table in blue. Right? So this is a recognition of the chunk ontology or the chunk types, and also the human reading order of the document all the way across the 12 pages. So starting from 1 and ending probably with, over 100 chunks here. This is all responsive and interactive, so you can click on this table, you can zoom in on the values, verify accuracy, take a look at the next table, and so on and so forth. So all of that happened agentically, right? Or sometimes I tell my friends it's kind of like auto-magically or auto-agentically magically. But it really is quite an impressive feat to understand all of this document in one shot. So let's take a look at something like the grounding information. So let's choose a value from this table that we can all easily see, like this hemoglobin value of 14.4 grams per deciliter. So say that we want to do key value pair extraction on this document. We're going to do a lot more with building a more substantial schema across the entire document, but right now we're going to start with just a single field. Extract the hemoglobin. Okay, if I don't tell it to do only this value, it's gonna do a whole bunch of others as well. So we'll see how well it follows instructions, considering there's quite a few values to extract here. I could have also uploaded a schema with just a single item. Haha, okay, we have a one item schema. So hemoglobin, it's a number, and let's go ahead and run that schema. Okay, so I already know that I'm expecting this result to come from table 6 as a chunk, but table 6 also has individual cells. And so here with the extraction results and the table cell grounding, I'm expecting the value, which I got. And then in the metadata, I'm actually getting back the cell reference for exactly where in the document that one value was found. So we do have kind of notation for ordering all of the cells. So on the 0th page, this is the 9th cell, and it is a unique reference value, also highlighted over here in the original. So as I mentioned in the introduction, our long schema support now supports, hundreds, if not thousands of values that you can ask for all at once. So this is just a short demonstration for kind of how this works for one field. So this reference 09, I should be able to find in the original JSON. And indeed, here is the table cell identifier for that hemoglobin value of 14.4. So unlike a vision language model, we're able to provide visual grounding for exactly where in the document this appeared. So we know that it's inside on table chunk number 6. I'm trying to get back to here. So it should be 1, 2, 3, 4, 5, 6. So here's a table. So there's a unique identifier for the table, and then there's an identifier for every cell inside of that table. So we've seen some people build some really elaborate kind of human in the loop systems here. So being able to extract particular values, show them to the user, and verify accuracy. Okay, let's look at a couple examples and then we'll start to build on these concepts. So in the introduction, I mentioned that we can do handwriting and circles and checkboxes and other things. So here's an example of kind of an intake form. Right, so we've got some handwriting, we've got some checkboxes, we've got some circles. So you can see like the type of response that you get back for a figure chunk like this. So it makes it very clear to the downstream LLM like which items have been selected. And then for a document like this, you can create a more elaborate schema. Right, so you can do things like taking all of these yes/no questions and turning them into Booleans. You can ask just for a list of the pre-existing conditions that are circled, and it is getting those 4 conditions correct. Here's another quick example of a document, which is just a 2-page fax. And we talked to so many facilities that are just like, oh my gosh, the medical world still lives on faxes. Right, so in this fax, actually, most of the information on this first page is not of interest. The interesting information is actually all in this one text blob. So being able to write kind of an extraction schema where you may want to pull out the study details, the report of findings, and all of these values are actually just coming from this text chunk. I did mention kind of bad scans. This is not as bad as it gets. This one, has clearly been scanned a few times. It's got some signatures, it's got some degradation, but it's not too bad. What we do offer to detect kind of issues with the document is this confidence score. So you saw as I toggled on the confidence score, I've got a couple regions here that were highlighted, and also this text chunk number 3 is indicated as having lower confidence than the others. And indeed, here it's this email address. So we can zoom in on it. You can see here G Houston, and then it gets a little bit garbled because, the stamp is overlaying it. So this is a great example of bringing to the user's attention any sort of low confidence regions, especially if this was in an amount due or in a social security number or some sort of critical field, you would want to bring that to the user's attention. We get a lot of questions about handwriting in other languages, also another chance to show confidence score. So I threw in this kind of handwritten German document, and the model's pretty confident about the extraction except for this one region, right? So we can zoom in on that. If any of you read German, it's kind of these 2 words right here that it's the least confident about. And that's a good chance just to make a point about language support. So we do perform really well on most character-based languages and documents with mixed languages. So here's an example. It's one of those disclaimers at the end of a document, and I'll pause there, take a sip of water, and just let you take that in if you are a speaker of any of these languages. Okay. So here's what we're going to do. I said I would briefly touch on this benchmark. So what's important about this DocVQA benchmark is that we were up against a kind of all of the frontier vision language models. And the key takeaway here is that an LLM can answer 99% of the questions using only the parsed API response with no image access during the question answering step. So now that you've seen the parse and you've seen the markdown output, you can imagine taking that markdown output and just asking a question about it. And so a model without actually seeing the original document actually performs better on this task. So we did publish a lot of these cases. This also gives you a good sense of the variety of the documents that are in the DocVQA benchmark. So a good example might be something like this one. So here the question is, how many days were the subject JW on the baseline diet? And the answer is 40. Right. And so in order to return that answer, you would first need to parse this document, understand that this is a table, understand that, JW and baseline diet, the intersection here is this 40. So our approach to this is to not show a vision language model the original document. Rather, we're taking this original document, we're sending it to the document pre-trained transformer to generate that markdown and JSON output, and then we're providing that along with the question. So at the point of answering the question, the model has access to this markdown, which has kind of detailed like HTML of exactly kind of how the table is laid out. And so then when you ask a question about it, not only can it answer the question, but it can also return exactly what cell the answer came from. So hopefully that kind of connects the dots between parsing and that benchmark. So let's do one more thing, and then we want to get into some code and putting this into some workflows. So I'm going to start over. I'm going to put in 3 documents that are all various lab reports, and we're going to create a project. So you heard me talk about field extraction being one of the key use cases. And typically, if you're trying to extract, an address from a set of utility bills or a total from a set of receipts or a, total amount of damages from an insurance filing, all of the starting documents are going to look different. Right. So previously we saw, I think, this lab report from Mr. Demo patient, but another lab, their format might look like this, and then another lab, their format might look like this. And if you're on the receiving end of all of these documents, what you really need is not that one hemoglobin value. What you really need is a schema that's going to work across all of these diverse document types. So everything starts with parsing. So what's happening in the background here is the parsing. So this one's a 6-pager. It looks like it's completed. We'll give these a moment to complete as well. And then we'll start to build up a schema using kind of agentic tools to accelerate the work of creating that schema. All right, this one's done, and 7 pages should be done pretty soon. So, okay, so last time we were over on the extract screen, I had just added 1 document to the project, and then I wrote a very specific guideline to just return 1 value for me. But this is actually where you can prompt to generate your schema. You can also use the auto-suggest schema. What I find with the auto-suggest is that it goes extremely comprehensively now across the 3 documents. It's going to create probably more fields than you're actually interested in, and it gives you a chance to pare them down and organize the ones that you want as a massive time saver. So what's happening right now with no instructions whatsoever, it's looking across the 3 parsed documents to understand what are the commonalities here. So I'll tell you in advance, like they all contain a hemoglobin value. Some of the others have cholesterol and maybe another one doesn't, but it's now trying to unify and build a schema that is appropriate for all of these documents. All right, and we'll give it a chance to load here. Grab a sip of water. All right, so while that's happening in the background, that's actually fairly computationally intensive. I'll go ahead and put up the QR code here for a moment. Also put in a plug to ask your questions in the Q&A. I am not looking at the Q&A because I still have a bunch of content to cover, but I do have Ron and Seshu and Ava and Bianca standing by to answer those questions. So let's see if that is completed. Excellent. Okay, so schema v1. So this is also going to offer version control as you iterate on your schema. So this was all generated automatically by looking across these different documents. So you can see it's nicely organized into a couple top-level objects. Again, as I warned you, it probably listed more items than you're actually interested in. But it's a great way to understand what's available in your documents and then be able to pare down from here. So this is another thing that a vision language model would typically never be able to do in one shot, right? So on that benchmark question, it was like, how many days was JW on the diet? You can get away with asking one question, maybe like 3 to 5 questions. But you're not going to be able to provide a schema with hundreds of items and be able to extract that all with visual grounding going back to the original. So again, this is a very computationally intensive task, but hopefully you already realize kind of the time savings and the potential here. All right, we'll give that a moment to work. Let's see, while that goes ahead and extracts, let me put in a plug for the documentation. So all of this is public at docs.landing.ai. We've been working largely in the playground so far because it makes it much more interesting for a webinar. But this is where you'll get information for API reference. And if you would prefer to interact with us via Python or TypeScript, that gives you 3 options. So REST API, Python, or TypeScript. There's also some great quick start resources here for each of those 3 options to get you started with the API. So you will need an account in the Visual Playground because that's where you're going to get your API key. All right, and we've got our responses here. So we've got Mr. Demo Patient, that was the patient section, report section, results section, right? So I'll just kind of scroll through this, but really a tremendous number of values extracted from one document in one shot. So again, we've got the extractions and then we have the extraction metadata. So this is going to give us the reference for where particular values were found. So it looks like this lab has no fax number, but we do have the doctor's name mentioned. It looks like in 8 different chunks. And so you will get that kind of multiple references if a value is found multiple times in the document. And again, this is going to connect back to the parse response. The JSON over here, every chunk has a unique identifier. Okay. So now that you've seen it, we're going to go back to the slides for a moment, and then we'll get into the scaling piece and then like putting this together into an agentic orchestration. So a couple things to note here is we do focus very much on accuracy, auditability, and autonomy at scale, again, so you don't need to get out of bed in the middle of the night. We've got a couple different options for deploying this. It can be multi-tenant cloud, which is what you've seen me using during this demo, or in Azure, GCP, AWS as a VPC. And we've got all of the required kind of security compliance operations covered. So this is very much built for scale. SOC 2 Type 2 compliant, HIPAA compliant, 99% uptime. We have options for 0 data retention. We work with a lot of healthcare, financial services, legal firms. So lots more to say. I'll just refer you there to the link security at Landing AI. But I think the more interesting part is this self-improving pipeline, which I've been trying to preview. So let me slow down here because this is the cool part and make sure that this sinks in. So problem statement. Given a set of documents and a golden eval set, can you iterate the schema until 95% accuracy is achieved? So what we're going to do here is we're going to use the parse API, which you saw in the playground. We're going to use the schema builder, which you also saw in the playground, and extract, which you saw in the playground. And then the rest of it is some like wrappers that I put together using Claude Code. Right. So bullets 1, 2, and 3 here, like absolutely production grade APIs, Andrea's personal code. It's a great starting point, but it is what it is. So here's what we're going to do. We're going to take a set of documents. We're going to continue to work with lab reports, but now we're going to have a golden eval file. So this is basically like, what are the correct answers? So like, what hemoglobin value are we expecting? What set of units are we expecting? What patient name are we expecting? So if we have the original documents and we have this golden eval set, can we just let the agents crank on this until they arrive at a schema that gets all the answers correct? That's what we're trying to do. So what do we have to do? So first, we're going to send those documents to the parse API. So you saw that happen. And then I've created just a quick schema builder agent, right? So we've given this agent a specific role, like you are the schema builder agent. You're going to take a look at these eval files and you're going to suggest a prompt for the schema. So that was the step where I said, like, give me only the hemoglobin value. Like, that's me generating the prompt. Then what we can do is we can take those parse documents, we can take the schema prompt, and we can make that V1 schema, right? So you saw the V1 in the drop-down list. Then we can take that schema, apply it to the parse documents, and extract the values, right? So we already know like what hemoglobin value we're expecting and what patient name we're expecting, right? Because we're going to iterate against a golden eval set here. So then we can have kind of an evaluation agent and a report generation agent that compares these extracted values to the golden set and writes a nice tidy report and says, here's where it was correct, here's where it was wrong. And then what's nice about this is we can iterate through this lower right-hand section. So we can send the evaluation report back to the schema writer that can generate a new schema prompt, and we can iterate through these 3 steps again until we eventually hit the pass rate. So in my demo, I set the pass rate at like all fields need to be 95%, but you could set the pass rate wherever you want. Right? So all of this code is available on GitHub. So I published it last night after this was all working. So on our GitHub, there is an events section and data science dojo. So don't worry about like madly scribbling this down or trying to screen record it. It's all here for you and you can use it yourself. So let's switch over to VS Code and we'll take a look at this. So here's my Claude MD file. Okay. So this is the part that's up on GitHub, and my team can post the link to exactly where you can find this. So what are we going to do here? So we're going to go through the loop that you just saw in the slides. We're going to parse all of the PDFs. We're going to build an initial schema, and then we'll extract, and we'll evaluate against the golden set. If all the fields are over 95%, the task is done. If there's 3 iterations and there's no progress, it'll escalate to the user, and otherwise it will keep cranking until it has a schema that achieves success on that golden test set. So in case it's not clear what I mean by golden test set, it basically looks like this. So for each of my files, I've got 6 CBC lab reports. These are the actual values that I'm expecting. Right? So it does take a little bit of human effort to actually put together the golden test set, but hopefully you'll see the value of doing this once and then letting the agentic system kind of crank on it. So I was very ambitious and was going to show this to you live, but then when I timed it, I realized that it was going to take more than about 20 minutes. So we're going to just kind of scroll through work from last night. So apologies for that. So here are my agents. So these are the ones that we previewed, and they each have their own set of instructions. And then in the data, we have the golden eval set. So this is the CSV file that we just saw. So the first thing is to parse everything. So in the pipeline outputs, we now have the results from parsing. So this is the full JSON response, right, with that markdown being the first row, and then just the markdown. So the script has done all of these, and the scripts are also provided for you. These are basically just taking our REST APIs and adding a little bit of extra around them. So this parse file is going to handle, it's got, I set it as like 6 threads simultaneously because I had 6 documents. So take a look at like what's inside the parse files. But basically, we parse all of the documents, and then we have to create the first schema. So it says, here's the proposed prompt for that first schema. So what it's doing here is actually just looking at the header files in the header row in my golden test set and saying like, oh, these are the things that she wants to extract. And so I will ask, do you approve this as a prompt? To which I replied yes. And from that, the system is then able to generate the first schema. So the first schema looked something like this. So we've got, the patient name, we've got the age, we've got the gender, and notice that it's already starting to fill in this like X alternative names. So this is a particular feature of landing AI schemas that allow you to kind of enumerate like other names that this value goes by, right? So RBC count, red blood cell count, like I would not have known this. But this was all automatically detected from the markdown files and then from the golden test set. So this is our V1 schema. Oops. All right. So we've got the V1 schema, and then it's going to apply that schema. And in the pipeline outputs, it's going to return all of the extraction responses. So here's the extraction response for document 1, document 2, and so on and so forth. And then, of course, we have to calculate the accuracy. So because we know the values that we're expecting, the evaluation agent and the report writer agent can then report back to me exactly how the model did. So on the first iteration, we got 95.9% accuracy. And of course, this was a somewhat simplified problem for, demonstration purposes. So it's reporting back my field level accuracy, and it's also keeping track of any sort of like systematic issues, right? And you can immediately see that the fixes for these are going to take us in different directions. So this is really just a data normalization issue. We've got some like ASCII versus Unicode characters. And then over here, we're actually like picking up the incorrect value. So we're able to do a proposed revision. So based on the errors, now we're suggesting these refinements to the schema. Reply yes if I approve those, and that's going to allow us to create the second version of the schema. So coming back to my schema files, you see there's one labeled current, and then I think this was from the second iteration. So I'm going to fast forward here a little bit, and this is now the loop running sequentially. So here we're checking the stop conditions. We have not yet achieved the accuracy that we want, but on iteration number 2, we've now fixed the issue with gender, which was a data normalization issue. But we've got some regression on these 2 values. So that means that the second iteration of the schema actually made things worse. So we can run the entire loop again and say, given this error analysis, please update the schema and try it again. So what you're seeing over here in the extractions, right, is the history of each run, and then kind of the final current run. So spoiler alert, when we get to the end here, we do eventually solve all of our problems. And in our final result on the 4th iteration, we've now achieved 100% accuracy against the golden test set. So that was, I'm a fast talker. If you've come to any of my talks, always an ambitious agenda. But this is really the part that I wanted to get to, because, man, we talked to so many organizations with this kind of need to develop long schemas across really complex documents. And as much as I love our visual playground, it doesn't really allow, so you're still kind of left spot checking things, right? So I love our visual playground, no knocks on it whatsoever. But it makes it really difficult to spot check all of these values and actually know if they're correct. So if you can take 3 powerful APIs, you can wrap them together with a little bit of knowledge about, an agent that can write you a quick report and an agent that can kick off the next iteration here. You can create this kind of self-improving multi-agent flow to just iterate on your documents until the values all finally pass. So that's what I had prepared for you today. I'll leave up the thank you slide for a moment. I'm not sure whether there's a question section here or not, or if you just get a slightly longer break. But thank you again to Data Science Dojo for having us. I hope that there were good questions. I've not been glancing at them, but you know where to find us, and would be glad to connect with any of you on LinkedIn and take a question or two if appropriate.
So, Andrea, if you don't mind, I mean, we have a few minutes. So I see there's a consistent theme of questions.
Yeah.
So maybe you can elaborate, right? So so there's a consistent question about, hey, what is the use case for this? And then something along the lines, will it understand other languages? And I think the way I look at it is more of a data extraction tool or data extraction platform, as opposed to, basically whatever data you extract, you create embeddings and then you build your application on top of it. So this is more for complex document processing, right? So, but I will let you answer.
Yeah.
So I think there's a few questions that I saw along these lines.
So if people are asking what's the use case for this, then I have completely failed. So that I was hoping that would be more clear. So these are the 2 main use cases that we see, is the field extraction and preparing documents for RAG. So most of the demonstration that I did today deals with this field extraction. So if you're on the receiving end of documents and you need to pull out specific values, that kind of connects to the lab report demonstration that we just saw. And this will work across, financial documents, against shipping and logistics documents, really, work against education, right? Exam results, right? So there's a wide variety of use cases by industry. And then the other is kind of preparing documents for RAG. So we didn't look at too many like flowcharts, tables, other things, but being able to pull out a description of these items so that they can be their own chunk in your retrieval apparatus can be very powerful. And I do actually have a few use cases by industry. Like for me, sometimes like the use cases seem obvious, but I'll just flash some of these up. So in financial services, there's a lot of this like, processing of documents, like when you apply for a mortgage. In healthcare, there's stuff like these lab reports, or like your doctor's office receives faxes from like a previous study. In retail, we see a lot of, invoices and shipping and logistics and, I don't know, inventory checks and safety checks and a wide variety of things. So hopefully that kind of gives you some idea of where this might be useful.
And there's multiple industries, and every industry, multiple use cases around, invoice processing, order processing, customs, you name it, right? So the shipping, bill of shipping and all of that, right? So there's so much medical reports and all of that, right? So many use cases. So there is one question that someone asked here. I think I scrolled past. So is there an API available to compare data across multiple scanned documents? So, you have an individual document that you can access, but someone says, hey, I don't want to do all the work. Can I see, for instance, my medical reports, my hemoglobin level, it changed across 2 reports. Can I compare 2 reports or multiple reports and see historical evolution? It's an interesting question.
Yeah. So you would need to build that logic on your own, but if you were applying the same schema, that's going to be very straightforward, right? So in this particular example, like this was 6 different people, right? But this could be the same person in January, February, March, April, right? So being able to extract the information and organize it is then going to allow you to do the comparisons that you want.
Thank you. And there is one question around HIPAA compliance, of course, an obvious one.
Yeah.
Can you speak to that?
Yeah. So let me actually go to our security page. So all of the documents you saw today actually were found online. So don't put your test results online unless you want them to be inadvertently used in somebody's demonstration. But our solution is entirely HIPAA compliant. So to be HIPAA compliant, you do need the zero data retention feature turned on. So with this option, the data is processed in memory and is not stored by us, and it's used exclusively for the extraction process. So you do need to have more than an individual account with us. You need to have an organizational level account, and it needs to have zero data retention. And then you can request the BAA, which would make the account HIPAA compliant.
Okay. Maybe one last question, and then we can call it a day.
Yeah.
How scalable is the self-improving schema loop across hundreds or thousands of fields?
I've been trying it for a more substantial project that has about 850 fields, and we have 10,000 reference golden set documents. So the concept is working just fine. I mean, the iteration on each loop is, kind of limited by, my Claude usage. But the concept has scaled up nicely to like 850 fields and like 10,000 sample documents. And it was actually like inspired by that real world work that I kind of put together today as like scaled down demonstration. But you should be able to go up on the number of fields and up on the number of documents.
Okay. Maybe one last question because that may be relevant. I'm sorry.
Yeah.
So how does the pricing work? I mean, is it per token, per request? I think once again, it scrolls very quickly. But what is so do we pay for tokens per user? Is there a built application ready for deployment? What are the, how does it really work?
Yeah. So we run on a credit-based system. On the pay-as-you-go, basically 1 penny is 1 credit. And then everything that you do, parse, extract, develop schemas, costs something in credits. All of that is public in the documentation, so I'll just show you where to find it. Here we go, pricing and billing. So this is going to take you through credit costs for parse, credit costs for extract. So parse is fundamentally based on the number of pages. So it's a flat 3 credits per page, and extract is based on input and output. So slightly different credit consumption models, but a credit at pay-as-you-go is roughly a penny, and then it's all usage-based. And actually, the usage is quite easy to see in your own account. So you can see kind of what individual operations. Yeah, so Ron's been doing some work while we're talking here, so you can see like each individual operation. Also, in an organizational account, allows you to do chargebacks based on API keys and things like that.
That sounds good. We do have more questions. I would encourage everyone to reach out to Andrea and the team members. You can look her up, Andrea, up on LinkedIn. Please reach out to us, and we will be happy to make the introduction. Thank you so much, Andrea. This was fun.
Yes, it's always a pleasure to be here. So hope the audience got something out of it, and I enjoy listening to whoever's up next.
Thank you so much, Andrea.
Bye-bye.
And we will be back in about 4 minutes. Hi, Kayla. How are you?
Good. How are you?
Doing well. So welcome back, everyone. You just saw in the previous tutorial how do we build an document extraction pipeline for complex documents. Now we are going to switch gears and we are going to look at GitHub Copilot. How do you write code even if you're not a developer? Or if you're a developer for that matter, right? So whether you are a developer or not, how do you use GitHub Copilot? I will hand it over to Kayla. Thank you, Kayla.
Cool. Thank you so much. I'll go ahead and share my screen and we can get started. Okay. So this talk is really around the availability of GitHub Copilot and how it's pretty much everywhere and how you can use it across Copilot CLI and the terminal, VS Code, and also the cloud. My name is Kayla Cinnamon. A little bit about me. I'm a developer advocate at Microsoft. Before being a developer advocate, I was a product manager and I delivered Windows Terminal. So if you've used the terminal on Windows, I was part of that. And I also helped deliver some experiences on Windows, including PowerToys as well. So to get a little bit more into the slides, just to give an overview of where Copilot really is available, we could start with an agenda. So I'm going to talk about the evolution of Copilot, how we got to where we are today, and then really where Copilot you'll find it in all of the developer tooling. And then I'll go into some live demos of how you can use it across these different workspaces. And I'll have time for Q&A at the end as well. Feel free to drop questions in the Q&A chat. I've got it up on the side here, so I'll try to answer them as I'm going, but I'll hopefully have some time at the end as well. So a little bit about how we got here with Copilot. It really started back in like 2021 to 2023, where it was somewhat of a pair programmer where it just helped you with code completion. And then we've moved into wave two, which is kind of where we are today. So it's really part of the agentic software development lifecycle. So it's going a little bit beyond just doing code editing. You can use it for automation. You can use it for code reviewing. It's way more integrated into the lifecycle. And then where we see it going next is in hybrid teams. So you're working with agents somewhat as if they were team members. So then you can work back and forth and assign stuff to agents, which you can do now. But they become more of like a teammate rather than just something that's pair programming with you. So Copilot is really everywhere. It's one GitHub Copilot, but you can find it pretty much everywhere where you write code. So we have it across github.com and on GitHub mobile app as well. It's in VS Code. It's also in other IDEs like JetBrains, Eclipse, Vim, Visual Studio, Xcode. It's in the terminal. There's some Slack and Teams integrations for it as well. And it's also in ADO or Azure DevOps, Linear, and Jira. So it's pretty much everywhere. I see an answer or a question that I'll try to answer live. I'm answering this question live. It disappeared. I think it was about writing tests. Copilot will help you write as many tests as you want, and also help you determine best testing criteria too. It's really good at writing code, but it's also good at evaluating your project and helping you come up with something really thorough. And it's good at like not coding stuff too. So I've had it like reformat files for me. It's made PowerPoints for me. It's really, really effective at doing pretty much anything on the computer, which is pretty cool. I hope that answered the question. I hit answer live and it disappeared. So if I didn't just put it in again, I'll try to answer that. So what's really neat about GitHub Copilot in particular is that it has access to a bunch of different models from bunch of different providers. So you can have your Claude models in there from Anthropic for Haiku, Sonnet, and Opus. And there's also the older versions as well than the ones that are here. There's also models from OpenAI, so the GPT-5.4 Mini, Justify 4, and the Codex models are there. And you can also bring your own key. So you can really have access to all the models that you want
all from the same GitHub Copilot, which is great. And Copilot really acts as your pair programmer. So it has real-time code suggestions. It can comment code. It can give you next edit suggestions as you're writing code. You can chat with it back and forth to understand how your code works. There's also inline chat commands, so you can work with it that way. And there's also an agent mode, so you can have it work for you rather than alongside you. And you can find it in places like VS Code. So here's a quick video of it working where we're in just ask mode, asking what are my open issues. Copilot has access to a GitHub MCP server, so you're able to pull in those issues from GitHub, and then you can assign it an issue saying, hey, I want to work on issue number 3. And in this example, we've also linked a Figma mockup, so a UI design, linked that in there, and then it's able to decipher all of that, come up with a checklist of items that it wants to make, and then it goes and implements that code, and it's all happening within VS Code. You don't have to leave your IDE, and then all the code's done, and you can work back and forth that way. So this is how it appears in VS Code. It made the website, and that's what it looked like. There's also just a list of features of what VS Code has to offer. It's got the agent mode, a plan agent. So if you want to create a plan without writing code, and we'll do that today in the demo, you can do that with VS Code. There are background agents, and you can also delegate to the cloud, which we'll see today as well. And you can have custom agents. There's MCP apps and servers in there. There's skills, hooks, prompts. Like these are really advanced AI topics, but all of it you can work with VS Code, which is really handy. Visual Studio also has a lot of this integration. So it has a debugger agent, profiler agent, test agent, and GitHub integration. And you can do those same sorts of things like planning. It has connections to Microsoft Learn and NuGet and GitHub, and then also the Azure MCP server. So I won't be showing Visual Studio today, but there is GitHub Copilot integration there as well. If you're someone who's building with VS and you have solution files and you're building apps, you can use GitHub Copilot in VS, which is really cool. I'm just going through the questions really quick. I might be able to show you a Figma use case. I don't have any Figmas on hand, but I'll show you a little bit about using an integrated browser and doing some UI development. So that'll be a little bit close. So we talked about Visual Studio and VS Code, but it's also available across other IDEs that like we as Microsoft don't produce. We just provide GitHub Copilot to. So that's JetBrains, Eclipse, and Xcode. And those have a lot of those same features that I mentioned for VS Code. So the code completion, the next edit suggestions, there's agent mode and ask mode. You can plug in MCP servers, there's a code review agent. And then there's also those advanced things that I was kind of mentioning with like skills and plan mode and instruction files and subagents and all that stuff. So if you're not someone on VS or VS Code, but you like these IDEs, GitHub Copilot is there too. And not only is it in IDEs, it's in your terminal. So we released the GitHub Copilot CLI, which I'll be showing off today as well, where you can just work with Copilot in your terminal. It'll write code, it'll create PowerPoints, it'll reformat files for you. It has the power of everything on your machine all within the terminal. So that's really handy if you aren't working in an IDE, or maybe you're not even a developer and you don't have an IDE. The terminal is really a great place for that because the terminal is on every machine. So Copilot's there too. And then Copilot's in the cloud. So let's see if this video works. Here we go. So you can assign GitHub issues to Copilot if you have a GitHub repository, and it'll go ahead and work on those issues and then create a pull request for you that you can go review, or have Copilot review it with maybe a different model, and then you can go merge it. So you don't even need to be in an IDE. You don't even need to be on your desktop. You can just do it from github.com if you have GitHub issues or a GitHub repo that you want to work through. And then it also works on mobile. So this is the mobile app for GitHub. And I recorded this a little while ago, but here I'm creating a new agent session in my log analyzer repository where I'm asking for it to check for any security vulnerabilities. And it'll go ahead and kick off a new draft PR as it's working. And then I can go review that later. So this is great if I'm on the go, or I'm like at a coffee shop, or I think of someone, if I'm like talking to somebody and I think of something that I want to go implement, I can just do it on my phone. So the mobile app is really handy for that too. And it works in the same way as if you would on GitHub Copilot, or sorry, on github.com, or if you delegated from CLI, it all kind of works the same way. So everything is really, Copilot's really everywhere, which is great with your Copilot subscription because you have access to all of these tooling, all this tooling. And the goal for us was to just meet you where you are. So if you're already an Eclipse developer, if you're already in Visual Studio, our goal was just bring Copilot to you so that you don't have to change your workflow. You could just work with an agent that way. So it's really everywhere. I only kind of touched on a few of them, but there are a lot of surfaces where Copilot's available. Okay, so and then, sorry, one final slide before I go into demos. This is just kind of a quick overview of all the things Copilot can do, and this isn't even everything, but it's really great at coding, which we kind of all know, and then deploying, design, planning, refactoring, documentation. That one's really nice because sometimes someone else writes code and then you have to go document it and you know what you're looking at. So Copilot's really great at reading through code and helping you through that. Okay, so let's jump into a demo. I know this is really meant to be a tutorial, so I wanted to just give a base overview in slides, but then we can get into some more in-depth examples of how this is working. So let me just pull up a few things. That's my PowerShell profile. Okay, so first we're going to start in Copilot CLI. And what I want to do in this session is implement or plan like 7 different things. And we've got like 40 minutes, so we'll see how this goes. So I last week created a website for my gardening that I started also last week. I planted some sugar snap peas and now I'm obsessed with gardening. So I made a website and I used Copilot CLI to build it. So I only built this in my terminal. I didn't use VS Code for anything, but I can keep working on this and we're going to work on this in the session. So to walk through kind of what we're looking at, I can add more plants to my garden this way. This is what my garden looks like. This is my sugar snap pea plant that I planted. I have a timeline of when I watered it. I didn't have a picture of it, so this is literally just a picture of dirt that I found online, but that's what it looks like right now because it's just dirt. Nothing's sprouted yet. But I can keep uploading photos so I can get a timeline of its growth. I can also look up a plant library. This was really what I wanted this website for because plants grow differently depending on where you are, the soil that it's in, how often you've watered it, how much sun it gets, all that stuff. So this plant library is hooked up to the Copilot SDK, which is using Copilot CLI in the backend. So what this is doing is that it spins up a CLI instance under the hood, and then it queries information about tomatoes, for example, and then it brings all that information back in a formatted layout that then I can read about how can I plant tomatoes. So we'll be doing some changes to this page here, but this is really handy. And then there's settings for the page. So I'm in the Boston area, so for me it's like almost 5:30 p.m., but I want to know like when I can plant things, the growing season, and then there's also different color themes if I wanted to change this. So this is what we're working with for all of the demos we're going to be doing today. So the first thing I want to do is I want to add a weather indicator somewhere on the page because it knows I'm in Boston and I want to know when it's going to rain. So we can jump into Copilot CLI to do this. So this is my terminal and I'm already in my Kayla's Garden repo. I checked out a branch called Weather. I'm going to type Copilot. So I already installed Copilot CLI. There's docs online for how to install Copilot CLI, so I recommend just checking that out. But at this point, everything's installed. So here we are, and this is where I'm in like a back and forth agent situation with the CLI. So we can plan this feature out with plan mode. This plan mode's available in a lot of those IDEs that I mentioned, and it's also available here too. So one way to get there is we can type /plan and type out the prompt. We can also switch modes with Shift Tab. So now I'm in plan mode. If I hit Shift Tab again, I'm in autopilot mode, which is enabling all tool permissions. So it's not going to ask me for permission to write to a file or anything. It's just going to go ahead and do it. And it will also continue to iterate over on top of itself until it thinks the task is done. So that's autopilot mode. We'll probably use that for this demo because it's going to take forever if it's asking me if it can use all the tools. And then Shift Tab again puts you back onto the main prompting window. So let's hit Shift Tab. Now we're in plan mode. So I can say I want to add a weather indicator somewhere on the page so I can see when it'll rain in my area you already have the location. So now this is going to go ahead and start working on a plan. And the model that I'm using is Claude Opus 4.6. I can change models using the /model command. So what I'll do is I'll just open a new tab really quick so we can walk through. I can see that this is spinning here, so this will just keep running. But to walk through a little bit of Copilot CLI's features, I'll type Copilot again. This will drop me back in. This tab in the middle is running the server of that website, so we're just going to leave that there. And we'll confirm the folder that we trust it. And so typing /model gives you the list of all of the available models that Copilot CLI has access to. So I'm using 4.6 Opus as my default, but if I wanted something lighter weight like Haiku, I can select this instead. So it's nice to use different models depending on the task that you're doing. So my philosophy, which is sometimes inverted from other people, but I like to use a heavier model for planning because I feel like it thinks more in depth about the problem and has a deeper reasoning. And then I'll use a lighter weight model for implementation because all of the planning has been done. So it's just kind of like checking the boxes off. But some people do it the other way. They create a plan with a lightweight model and then they do a heavier model for implementation because they want a more solid implementation theoretically. So it just depends on what you want to do and how you want to use your tokens and all of that. But right now I'm just using Opus 4.6 because that's the default. But there's a bunch of different ones you can play with. The Codex ones I like as well because they're a bit more concise. Opus can be kind of wordy. So it just depends on how you like to work and what you're doing. But you can change your model with /model, and that's how you do it here. So I did get the notification that Copilot needs my attention, so I'll hop back in. So this is what's really great about plan mode is that it's going to be asking me clarifying questions back and forth so that we can create a full plan. Because I didn't really specify a lot. I just said add the weather indicator. So it's asking where should it go? I think probably in the header. Let's see. Let's look at our website. Yeah, up here is fine. Sure. So I'll put it here next to the nav links. And then how much detail? That's probably fine. I don't think I need a lot of detail. And then, yeah, a free no API key would be great because I don't want to try to deal with API keys and things. So that's going to keep working on a plan. This will not be implementing any code. It's just planning. So we're going to let this continue running, but maybe I want to do something else. So what's also nice about CLI and VS Code and all that stuff is I can just keep spinning up sessions. So this, whoop, how do I move this title bar? Go away. Okay, there we go. This is currently another session of Copilot, and I can keep adding new tabs. I can keep creating more sessions. I can keep doing all the Copilot-y things. So let's do another session because I want to implement all of these features. So I'm in the wrong folder right now. I just launched Copilot from my root folder. So to switch folders, you can type /cwd, and that'll change your current working directory. So I am located over in my GitHub folder, in my my GitHub account, and I'm in Kayla's garden. Okay, and before I start that feature, I got pinged again. Let's see, plan ready for, I want to remove the Zoom title bar. I don't know how to do that, so I apologize if I keep pausing because it keeps popping up. Okay, so the plan is done. So the plan is to add a compact weather indicator to the header using Open Meteor, which is a free weather service. And then this is the interface it's going to build to implement it and the API route and how it's going to grab all that information. And then I can accept the plan and build on autopilot. So autopilot was that mode that I explained earlier, where it'll approve all the tool calls and then also continue to iterate over itself until it's done. I can accept the plan and build on default permissions. So if I don't want it to use specific tools like Git, for example, I can do that with the second option if I've already allowed certain tools. If I didn't like the plan, I can just exit. And if I don't like the plan, but I want to change it, we can suggest changes. It'll go ahead and rerun the planning again and then come up with a new plan and we can rinse and repeat. For this, we can just accept the plan and build it. I'm on a branch, so if anything breaks, it's fine. So we're going to have this run, and I'm going to enable all permissions because we're in the autopilot mode. and we're gonna let that go. So this is just gonna run. Hopefully it'll finish by the time we're done. We could see some weather up in the website, but now let's head back to my other tab where I wanted to do some more stuff. So the other thing I want to do from CLI is in my little garden, I want to be able to track when the last time I watered it was. Luckily, it's been raining like every day, so I haven't actually watered these snap peas since I planted them. But I want to track when I do that. So we can come back in, and this is already cooking on this branch. So I don't even know if I should be checking out another branch while this is working on a branch. I haven't tried that. I don't recommend it. So I want to delegate this to the cloud instead. So I could type /delegate from here, and then this will assign an item to the GitHub Cloud coding agent on github.com. So let's do display or had the ability to display last watering date on my plants. I should be able to add a timeline of when I water, something like that. And then /delegate will have this happen not here locally. Because I'm developing locally, I'm not trying to mess up what I'm doing with my weather indicator over on the first tab. So I have uncommitted changes because I've already been working on this branch. So this will create a commit checkpoint and then send everything up to the cloud. I think that's fine. Okay, send this session. Yes, go ahead. Okay, so it's created the commit for me, that's fine. And now it's creating a branch from main up in the cloud. And it's going to just kick off. So it's creating a PR for me already up on my GitHub. So here it's now made that PR as a draft. It's going to take a little bit to start working, but it's, add the ability to display last watering date for plants. And it's going to go ahead and work on this so I can keep working locally, and this thing's working for me on my behalf over on github.com. And I haven't left my terminal. Everything is here. So we're going to just leave this for now. And then this sounded like it finished. So it finished my weather indicator. So I think it should work. My server, let's see. It looks like I'm getting a 500. Let's see if I can restart this. I don't know if this is going to work. We're live coding right now, so who knows? Kayla's garden. No weather. Okay. And then when these sorts of things happen, I'll work back and forth with Copilot to be like, hey, this isn't working. Where's my weather? And then it'll go figure it out. There are 500 errors here, so I'm sure it's something to do with the API call. Doesn't look like we're getting weather. Check in on those 500 errors. All right. And then we're in autopilot mode, so it's not going to bug me until it's done. So that's everything from CLI. So we've only been in the CLI, and this is awesome. But now let's talk about VS Code and how we can keep working if we're in an IDE. So here's my VS Code. A few things to note. I've got my agents window on the right, and here is that same CLI session of add a local weather indicator. We just kicked this off 8 minutes ago. You can see it, or 9 minutes ago. And then also, I think I have like a permission thing failing over in the cloud. That's okay. But my cloud session's here and my CLI session's here. So if I was working in the CLI and I want to see the code that's being written, or I want to continue, and then I want to continue that session, everything's hooked up with VS Code. So everything gets passed back and forth, and this is awesome. So and then this was the session that I used to make the website 5 days ago. So I can jump back in and keep working in that session, which I might want to do because all of my context is there, or I'll jump in with a new session and do things from CLI or cloud this way. The other thing to note that I've got on my screen is the integrated browser that I opened to localhost 3000. So this is really cool because I can just poke around my website. Oh, look, the weather worked. That's cool. Everything's working. So I figured out that 500 error because I heard that it finished. Let's see. Okay, yep. Fix the weather 500 error. That's great. Now I've got weather. This is awesome. Not supposed to rain today, and it didn't. So this is good. Okay, anyway. So I've got my integrated browser here, and I can click on elements in the website and attach them to a session, and then I can ask Copilot like, hey, go fix that, or hey, go change this, or like, hey, this looks funny. So we can do some of that here too. So let me just see if there's any questions to answer. How did you create this cool PowerShell profile? That's a great question. I use, let's see. Well, so in Terminal, there's different settings you can use. We'll just tangent really quickly, but I've got all of my background images and stuff over here on the profile setting and appearance, and then background image is here. So that's what my little gradient background is. And then I tone down the opacity because otherwise it's like hard to read. And then I use Oh My Posh. That's the other thing. So ohmyposh.dev you can go to, and then you can customize your prompt. So this is all with Oh My Posh. And then that is set up in my terminal profile or my PowerShell profile. So I pulled this up earlier, but this is Oh My Posh, initializing at the beginning of PowerShell, using my Oh My Posh theme that I have set up. And then I also have a terminal icons PowerShell module set up. So I recommend checking that out. Oh My Posh is really cool. And then also look into terminal settings because there's a ton of fun stuff in there too. So I'm big on customizing my terminal because I worked on terminal for a long time. Okay, back to VS Code. I love terminals. So anytime I see a question, I'm like, yes. Okay. So first thing we want to do, we've got a new session. So these three are fine. We'll leave them as is. Might be nice to plan a new feature. So one thing I want to do is I want this to work on my phone, which it's a website. It's going to work on my phone, but all of the storage of my garden and everything is only local to the device that I'm on. So I won't see sugar snap peas on my phone because it's not all hooked up. So I want to plan some kind of back-end mechanism that I can have this be cross-device and then maybe, I don't know, kick off like a GitHub action or something when I upload a picture, because like a whole database is kind of heavy. So I don't know. So I want to plan this because I don't want to just send this to Copilot. I want to like work with Copilot. So we're going to change this to plan mode, which should be, well, what the heck? I just up the, so a caveat here is that I'm using the VS Code Insiders train and things are constantly updating. So I think plan is not in the UI, but I think I could type /plan. We're going to try it. Yeah, /plan. Okay. I recommend VS Code Insiders because there's daily updates of where things are, of things coming in, but sometimes the UI changes. And I did update literally 5 minutes before this. So, okay, we want to plan, let's set up a backend where I can get the same garden across multiple devices. We could just start planning that. And let's plan it here, and this is fine. So this again isn't going to write any code, but I want to work with Copilot and on a good way to set up a backend. So it's just going to keep going, and then we can hop back and then do some more stuff. So this is just going to work in the background for me. And then next, I want to do some stuff here with the integrated browser. So I want to head over to the plant library, and what I really want is like, it already knows my location. So it should know which hardiness zone I'm in. And then it should therefore be able to tell me the best dates to plant this plant. So what I can do is I can grab an element of this website. So I'm going to click this little button here, and I'm going to grab this box because I think this is a good place to put this. Oh, see, now we're out of plan. I'm not sure what's happening there. Anyway, switch out of plan mode, and I think we're just going to send this. And I want to send this to the collab. So in the same way that we did /delegate over in CLI, you can do that from here as well in Visual Studio Code, VS Code. So I want to say, we already know my location. Let's add ideal planting dates to this box right here based on that. Okay, and then we'll commit the changes and delegate that up as well. So this is really cool if you are doing a lot of UI design but you don't want to do everything locally, you can grab elements from the web page and point at stuff directly, and it'll grab those and add them to the context of the chat. And then you can send it up to the cloud. So this is really cool if you don't are like let's say I'm honed in on that back end plan that we just kicked off over here. But then I'm like the UI looks funny, you could just start delegating stuff off while still getting those UI elements, which is really awesome. And then the other thing that I want to mention is that you can get access to the Copilot CLI from here too. Where is happening with my UI? Where's my box? Okay. There we go. All right, we're on Insider, so it's a little funky, but it's okay. So the other thing you can do, like let's say I'm still honed in on this branch, I don't want to mess with this branch. We're on the weather branch, which we worked on like 5 features ago. You can delegate to the CLI in a work tree. So this will basically take like a copy of your branch and then make another copy of it and then work off to the side. So I like to think of it as like a branch off of a branch, even though technically that's not what's happening, but that's kind of what it feels like. But then that way you're not messing with your main branch, and then whatever changes you agree to in your work tree, you can bring them back into the branch that you're working on. So what I want to do for my work tree is on my plants page, this is just an icon and I think that's boring. And I have this awesome picture of dirt that I would like to be my header photo for this plant. What I really want is my most recent photo of this plant to be that header photo on the card. So I can select this element again, and then I can say, make the most recent photo in the plant's timeline this image instead. And I'm delegating to a work tree and it's using Copilot CLI. So I can send this off. So now this is using the CLI under the hood away from what I'm doing, but it's still local. So that's kind of the difference between this and Delegate, where Delegate's sending up to the cloud, using all the cloud resources. It's on github.com. There's a draft pull request up there. It's all in the cloud. And then delegating to the CLI, it's all local. There's not going to be a pull request. It's just going to be files that have changed that I can then merge into my existing branch. So that's CLI weaving in with cloud, weaving in with local development of like, hey, I'm building a plan for a backend all within VS Code. So there's like a lot of ways you can hook everything up together that way. And then let's say you're not in the IDE, you just want to be on github.com. We can head over there and we can do some agent work here too without needing an IDE. So one way that you could do that is this little cloud icon up here. And this you can assign tasks to Copilot from the repo that you're on. And you can pick any repo from here. You can pick the branch that you're working off of. You can pick the agent and then throw images in this way. And then you can also pick your model. So this is auto selecting the model based off the task, which I think is fine. And then here we can add a request for something. So I don't have a link to GitHub at the bottom here, and I feel like I should. So we can just say like add a link to this GitHub repo across all pages. And we'll send that off to the agent. And now this is working off in the cloud. I think I need to change some billing and stuff, so the demos might not be working in the cloud today, but that's okay. The flow should be the same and it should work for you. I just have some things that are not hooked up correctly. So this would go off and then it would create a PR on my behalf. And then in the same way that this made a PR, this made another PR. This was the one from VS Code. So these are the ideal planting dates based off the location that I kicked off in VS Code. So this is going to be working here. And then another way you could do it is if you have a bunch of issues on your repo that are pretty easy, like they don't need a lot of development work from you, you can assign Copilot to issues here too. So another thing that I want is the location and settings should display which zone I'm in. So gardening has zones, and I think Boston's in like zone 5 or 6 or something. It'd be nice if that was here rather than just like frost states. So that's not too complicated. I don't really care what it's going to look like. I think it's going to be fine. So I can assign this to Copilot from here. So I can also add additional context here if I wanted, and I can just hit assign, and then Copilot's going to work on this on my behalf, which is great. And you can see that I assign this to Copilot. So if you're working in a team and you want to know like who's been assigned to work and when they use Copilot, this is a really great little UI change that they made where you could see that. I've got some billing issues, so none of my cloud things are going to be working, but in general, these should work correctly. And then this is going to then create a pull request, and then the code will be there. And then in the same way that you can assign an issue to Copilot, you can also assign a pull request to Copilot. So I am a reviewer of this PR. You can assign Copilot to review as well. And this can leverage different models based off of the ones that you've used to write the code. So that's kind of nice. Feels like getting different eyes on your PR, but it's all just Copilot anyway. So if you want an extra set of hands when it comes to reviewing, especially if you're like a solo developer, that's one way of doing that, is assigning Copilot to be a code reviewer. And Copilot has a code reviewer agent under the hood, so it is specialized for code reviewing. So it's going to be looking for those code vulnerabilities, security issues, anywhere where things can be optimized. That's really what it's going to be looking for. So Copilot works in the cloud. You can also, I can't really show this easily, but on your phone, you can connect to the GitHub mobile app and then do this same flow of either assigning issues to Copilot or just assigning a prompt from there too. So it just depends. So the way that I like to think about when I use the CLI versus VS Code versus the cloud depends on what I want to do. So the CLI is great if you don't really care to look at the code, but you want to do something locally and you want the power of the desktop available to you. So like one other example, which isn't even code related, but I feel like this was really cool, was my team's helping set up these Copilot dev days. And we have all of these PowerPoints to help presenters have assets of like everywhere Copilot's available. And we were hitting an upload limit in GitHub because the images in these PowerPoints were too large. So we used GitHub Copilot to find all of the images in the PowerPoint and shrink their size, and then we were able to upload them. So that was all from the CLI, but it has the ability to use like FFmpeg, for example, or any other tooling on your desktop to then go do those things. So CLI is really great for having the power of your desktop and somewhere where you don't really care to look at the code because you're in the terminal. So that's where I use CLI. And then VS Code is great if you want to look at the code, especially if you're doing like web development and you want to use this integrated browser, you're using UI development. This is a really great place to use the Copilot here. And you can also still delegate in the same way as if you were in CLI or in the cloud. So VS Code is really great if you want to look at all of the files that it's touching and if you're doing UI development. And then the cloud delegation up in GitHub is great if you're not at your machine, or if you have something that is simple enough where you don't need that back and forth integration. I mean, you can do that with like comments and stuff like in the PR and in the issues, but it's really nice to just send something off and then it's good on the first try because it's not that difficult of a task like writing documentation or something. The cloud's really great for that because it's out of sight, out of mind, and it doesn't need your input all the time. So that's kind of when I like to use all three of them. And like Visual Studio, for example, falls in a similar lane as VS Code, except more so for like app development. So for VS, if you want to do a lot of debugging hands-on with the code that you can look at, that's when I would be using Visual Studio with Copilot in there as well. So to just jump back into the slides quickly, and then I can help answer some of the questions. Copilot's really great at a lot of things. Like we were looking at writing code, but it's also good for like summarizing code bases. So if you could just ask it, like, what does this project do? How do I contribute to this project? Where's the front end code located? Like all of that stuff, you can just ask it. It's also great at automating commit messages and PR summaries for CI/CD pipelines. So if you wanted to generate release notes automatically, Copilot's really good at just reading all the commit messages and then coming up with paragraphs that someone can read rather than like commits that say change this, change this, change this, and the commits don't make a lot of sense. So It's great for that. And then code reviewing, we talked about a little bit. You can review PRs and suggest improvements and also highlight potential issues. You can do that. Unit testing is also great with CLI. I despise writing unit tests, so the CLI is really great at coming up with unit tests and then going and writing them, which just makes that much more fun for me at the end of the day when it comes to making sure my feature is fully complete end to end. And then it also is great for security, so it can detect and remediate vulnerabilities. And then you can also power your AI apps. So using this SDK, which has a CLI underneath the hood. So that's how that Garden site's working I plugged in the SDK and then it's using AI to pull in all that information about, I think we were looking at tomatoes. All of that is just using AI queries. I don't have a database of plant information. It's just the SDK doing all the work there. So you can make AI powered apps that way too. So if you want to get started using it in your code base, you can just go ahead and have it explore the code base if you want to just try it out and say like, hey, map the project structure and prerequisites, identify how to run tests. You can have it do kind of lightweight stuff. You can have it do local edits and reviewable diffs. So if you want to just test out like a quick refactor or a bug fix, that's a little bit more of a nice entry way of getting into it. And then if you run any commands, you can have it explain them to you. So if you don't remember syntax in PowerShell, for example, you can ask it to propose a command, explain it, and then run it for you. And then same, you can interact with GitHub, kind of what we were doing here, but a little bit more involved. So you could say like, list the open PRs in this repo, or like list the open issues in this repo, and then assign it to one of those issues. Like you can do all of that, or create an issue or draft a PR too. So it's really great at being able to interact with GitHub without having to leave your IDE or your terminal. It has that ability too. So that's kind of everything I want to show. In Q&A, I'm happy to go demo stuff as well. But I want to say thanks for letting me spiel for this long about Copilot. And if you want to get started with Copilot, you can hit gh.io/Copilot, and we've got some information there. But I can take a look through the Q&A and try to answer some of these questions that you guys have been submitting. But for now, thank you for listening to me talk about gardening and Copilot, because those are my two favorite things. So let me take a look at some of these questions. One of these questions says, what is the difference between Copilot and Claude Code? That's a really great question. And it really comes down to the way that we call it a harness, but the way that the harness interacts with the model underneath the hood. So like Copilot and Claude are basically layers that you interact with the model underneath. That's how that works. So like Claude Opus or Sonnet or GPT-5.4, that's the model. And then the thing that you're interacting with is going to be Claude, or it's going to be Copilot, or any of the other ones that are available. So what's different is maybe features that are provided, or the way that your input string gets then interpreted to the model, and then the way that the model's response gets interpreted back to you. That's like where it gets different. So Copilot is built differently than Claude Code. So it's really down to what experience you like, or if there's features that you like in one that aren't in the other. That's kind of where the differences are. But in general, there's just two different harnesses or two different ways you can interact with these LLMs. So that's it's like a kind of weird way to think about, but yeah, it's like the interaction layer. Do you have environment setup instructions? That I think would be, so you can find some instructions here in GitHub, gh.io/Copilot. There's also a lot of docs online if you just start looking up Copilot. My environment is the terminal canary version, which is just it's like a nightly build of Windows Terminal. You can get that on GitHub. And then I'm using Visual Studio Code Insiders, which is also available online. You can just install that too. And then Copilot CLI, which I've installed through Winget, which is the Windows Package Manager, but you can also grab that through NPM or Node, or Brew if you're on Mac. But there are docs online of how to get set up. It's really just installing, and then everything just kind of works once you've logged in with your GitHub account. So it's pretty seamless to get set up, but that's what I would suggest, is just looking up some docs. Let me see. I'm scrolling through questions. Also, thank you for all the thank yous. That's so nice. Let's see. Mm-hmm. Some of these I don't know the answers to because they're a bit nuanced, so I apologize for that. What's the best way to use plan mode versus autopilot mode safely? That's a great question as well. Plan mode, I think, is pretty safe regardless of where you're at because it's not writing any code. So it's not the only maybe thing that you wouldn't want with plan mode is if you have files that you don't want it to look in and read, you can prevent those from being looked at. Also, one second, my throat is getting really dry. But for tooling, plan mode is really just using like read. It shouldn't be writing anything. So that's fairly safe unless you have some like super locked down things that you don't want Copilot looking at. For autopilot mode, I recommend working in a code base that you trust that isn't going, like if it goes off the rails, maybe don't use autopilot there. I also recommend using containers if that's something that if you're like working on stuff that you don't want to go outside on your desktop, that's great for that. But autopilot, I recommend just making sure that you're cool with it touching pretty much everything that's in that repo. Otherwise, I wouldn't use autopilot mode. So like for real work scenarios, autopilot's a little scary. But if you're in a branch just locally and it's not going to mess up like the rest of what you've got going, I think it's fairly okay. And it's been pretty reliable for me, but that's what I'd suggest is just kind of like be in a container or like on a local branch that's not going to mess anything up. Or I just wouldn't use it. I would maybe just be cool with default permissions, or you can allow specific tools in your Copilot config file. So if you head to your root, so I'm in my root structure dot copilot slash dot copilot folder. This is where all of your Copilot CLI things are. So I've got my custom agents in here, and then my skills are in here. Any plugins I've installed, they're all in here. And then there's this config file. You can allow specific tools in this config file and then run it on the default permissions. So if you don't want it to use Git, I wouldn't add that in here, but if you're cool with other tools, you can add those in here too. And then you can add trusted folders as well. So if you are cool with it accessing a certain repo and you don't want it to continue asking for that, you can set that in here. And then the same goes for allowed URLs. So like I'm cool with it accessing GitHub and learn.com, so I've approved them here. So that's just automatic. So the config.json over in your root slash dot copilot is where you can go define some of those permissions. Ooh, what's this? Permissions config? Yeah, so here's where these tool approvals are going to be. So I apologize. It's the permissions-config.json file. So in this repo, for example, I've approved the MCP command, GitHub issue commands, and then like these PowerShell items as well. So you can run it on default approvals, but then have whatever tools you're cool with in here. So that will kind of be a nice balance between full autopilot or nothing. And then it's just like constantly asking. So there's that. Let's see. Any examples of containers would be like Docker, for example. You can set up a container where all of your code and your dependencies and your package installations and everything is in a container. So Docker is really the best example, but then that is isolated from the rest of your machine. And then anything that happens is just within that little box. So if you don't like what's going on, you can just tear down the container and spin up a new one. Or if the code is great, you can go merge from there too. So I recommend checking out Docker for that. But that's like a quick example of containers where you can use this. Let's see. Can you share more insight of the stack for the demo site? Is it local resources being run by Copilot locally or some interaction with Copilot model in the cloud? The demo website is, let's see. It's leveraging it's not local. Like I could hit, if I hosted this on GitHub Pages, for example, it will work over there too. It's running a Copilot CLI instance, which is then calling a model not in the cloud necessarily, but under the hood. So I don't need this running on my machine. This should just work anywhere. So it is web based. So it's only local because I haven't pushed up to a hosting site. But the architecture under the hood is all web based when it comes to that SDK integration, doing those CLI calls. Okay. I think I might be out of time for questions. It looks like I'm right at 6 o'clock. Yeah, but I want to say thank you everybody for all the awesome questions, and I hope this was helpful. I know this is a little like chaotic and some things didn't work and all of that, but really wanted to show like the breadth of Copilot and where you could use it. So thanks everyone for tuning in.
Thank you, Kayla. And before we close, do you have any guidelines or any recommendations on what one should absolutely not do when they set up Copilot? Because things can go south very easily, right? So
yeah,
what are the things that you would recommend that we shouldn't do?
Yeah. I mean, autopilot is kind of scary. Like if you're on a code base that you are really weary about just letting Copilot go loose on, I wouldn't run autopilot. I would do the custom permissions flow in the config file. Also, if there's any sensitive information, I wouldn't have Copilot like working with that because it might, I mean, you never know because it's an AI model, but I would be afraid if it like put like my personal access token up in my repo and publish it, for example, or like something like that. So I try to do those manually just to avoid any like, oh, here's the token, like here you go, and then it's published and it's scary. So I would avoid anything that's like sensitive in that way as well. But I think those are probably the main two that I'd suggest. Autopilot can be scary, so I would use it with caution. I'm just in like a demo play setup, so if anything breaks, it's not that big of a deal. But in real life, I would hesitate.
Yeah, sounds good. Thank you so much, Kayla. It was fun.
Cool. Thanks so much.
Thank you. Okay, so the first day comes to an end. We have 4 more days of discussion, 4 more days of tutorials and workshops. So tomorrow we have tomorrow is primarily all tutorials day. Day number 3, 4, and 5, we will have a lot of workshops. I believe we have 2 workshops per day. Before we close, I also wanted to actually talk about what we have done so far, right? So what we have done so far is we have looked at the entire end-to-end stack of building agentic AI applications. Starting from the first session was around how do you govern autonomy? The fact that LLM agents are built on LLMs. The fact that agentic AI is autonomous, the fact that it is non-deterministic, it exposes us to certain dangers. And we talked about how do you address some of those governance or autonomy concerns. The second panel, we talked about the economics of it. How do you understand whether proof of concept or a deployment is actually adding value? The third session was, again, around similar to governance. We were talking about keeping our agentic AI deployments or agents more under control, being more accountable, being able to audit them as needed. And finally, in the last one, once you know all of this, when you build an agent or an infrastructure to create agents, how do you actually manage technical debt? How do you make sure that you're not taking these technical expediency, right? So I need to get this done. And how do you actually avoid that? Technical debt is inevitable in any software implementation. In agentic AI, this once again the autonomy and the non-determinism, the fast pace of changing frameworks, it actually makes it much more harder problem to solve. So before we close, I would like to actually show all of you. Let me see, we have application, second screen. Okay. I would like to show all of you, we do have an Agentic AI bootcamp. In case you are interested, we have two versions of this Agentic AI bootcamp. One bootcamp is purely online. Let me see here. Yes, so one of the offering is purely online. You can actually attend it 3 hours a day for 3 hours a week, actually, for 10 weeks. So it's a more condensed program. And we talk about the entire stack. We talk about starting with transformers, take a deep dive into transformers, then we, the attention mechanism and all of that. So we set all the foundations correctly. We make sure that everything is taken care of. We talk about agentic AI. What does agentic AI really mean? We dive into LangChain, LangGraph. How do you build agents? We talk about vector databases, context engineering. We talk about guardrails, different kind of design patterns. I believe somewhere Jerry earlier today, Jerry mentioned deep agents. So we talk about deep agents. We talk about reflect, react, those kind of paradigms or those kind of design patterns. We talk about all the agentic AI design protocols. MCP. You may have heard of MCP. All the role-based access control and all of that. And most importantly, we talk about evaluation of LLM or evaluation of agents. This course is very, very hands-on, right? So what we do is, if you are a software developer, or for that matter, if you're not, we have completely curated exercises. You can, you click on it, and maybe I can show it tomorrow. I did not bring it up, but we have a learning platform where all the labs are there, carefully curated. We start with the foundation, and we slowly, gradually build that momentum. Pretty much everything that we talked about today is actually covered in, and much more than that is actually covered in our LLM bootcamp. An Agentic AI bootcamp. LLM bootcamp is more in person. Some people, they prefer that they want to be in person. So LLM bootcamp happens in Seattle in our office. It's a week-long bootcamp. You're in and out of it in a week, 8 hours a day, this waterfall. You learn a lot. And you just go back and start building applications right starting next week. So with that, I think that is it from our end. Yes, tomorrow's URLs should be the same. Thank you so much, everyone who joined. We have more tutorials coming up tomorrow, and I'm looking forward to seeing all of you tomorrow. Thanks, everyone.